Hello, and welcome to the full course session on Machine Learning Fundamentals in Depth, your gateway to mastering the foundational concepts of machine learning, artificial intelligence, and data science. This is a certified course session, so make sure to fill out the form in the description after completing the session to claim your certificate. You can proudly share your achievement on LinkedIn to showcase your new skills. At Skill-Lync, we're committed to providing industry-relevant advanced engineering courses. We partner with industry experts to offer top-notch training that equips you with the skills needed to excel in your career. Don't forget to subscribe to our channel for more insightful tutorials and updates on machine learning and AI tools and techniques. Hit the subscribe button and stay tuned. Here's a brief overview of what we'll cover in this training video. In the first chapter, we'll start with the basics of probability and statistics. You'll get an introduction to key concepts in statistics, probability, and how they relate to machine learning and artificial intelligence. We'll lay the groundwork by explaining the essential ideas that power data-driven decision-making. In the second chapter, we'll dive into the basics of machine learning and artificial intelligence, starting with supervised learning. You'll be introduced to normal and standard normal distributions, business moments, and a deeper understanding of how artificial intelligence is structured. In the third chapter, we'll focus on prediction in supervised learning, where you'll learn the principles of supervised learning and be introduced to linear regression, one-hot encoding, cost functions, and gradient descent, which are all key techniques in making accurate predictions. In the fourth chapter, we'll move into classification in supervised learning, where we'll explore classification algorithms. You'll learn about logistic regression, classification problems, and understand how cost functions and gradient descent apply to classification tasks. In the fifth chapter, we'll dive deeper into classification algorithms by introducing decision trees. You'll learn about entropy and information gain core concepts for building decision trees that can classify data effectively. In the sixth chapter, we'll cover random forest and model evaluation, where you'll learn about random forests and how bootstrapping and majority rule work. You'll also explore the methods for evaluating classifiers to ensure accurate and reliable model performance. In the seventh chapter, we'll introduce support vector machines and explain the mathematical intuition behind them. You'll also learn how SVM differs from other classification algorithms and when to apply it in your models. In the eighth chapter, we'll introduce k-nearest neighbor, explaining how this lazy algorithm works and how it relates to a single-layer neural network. You'll learn when and why KNN is a useful classification technique. In the ninth chapter, we'll shift to unsupervised learning, starting with k-means clustering. You'll learn about the concept of clustering, its importance, and how to apply the k-means algorithm along with the elbow curve to find optimal clusters. In the 10th chapter, we'll introduce hierarchical clustering. You'll learn about this alternative clustering technique, the concept of dendrograms, and how to evaluate the performance of clustering algorithms. In the 11th chapter, we'll cover principal component analysis, a feature selection technique used to reduce dimensionality. We'll explain the mathematical intuition behind PCA and its applications in simplifying complex datasets. Finally, in the 12th chapter, we'll dive into neural networks and deep learning. You'll learn about artificial neural networks, different activation functions, and the concept of backpropagation, which is essential for training deep learning models. Thank you for joining us. We're excited to have you on this learning journey. Make sure to subscribe for more updates and detailed tutorials. Complete the training, earn your certificate, and share your achievement on LinkedIn. Let's get started with machine learning fundamentals in depth.
Hello everyone. So the course is already on the screen, so I don't want to spend time on that. So before going into the course, I assume that some of the candidates would love to learn apart from looking at the videos and hearing the audio. I know that some candidates or some of the students would be more interested in reading. So for them, I have kept some of the reference books here. So this is what I found to be like. I have read these two books to some extent, and I found that these two are quite good books. So, and the reason why we have chosen Python is because if you look at the trends of different coding languages, you would notice that Python is on the top. So that's self-explanatory that most of the organizations most of the companies, most of the colleges, they are making sure that Python is one of the important coding languages which everyone should know. Okay, so that's the reason we have chosen Python. Okay, so these are the two books. One is by Manoranjan Pradhan and the other one is Abhishek Vijayavargya. So if you want to have a look, you can always have a look on those two books. Those are quite good. In this course, you will understand why ML is so important and why ML and AI is gaining so much importance in current era. Okay, and why we are looking at this course, why people are going after this course, because everyone knows that ML and AI is gaining a lot of attention in the market now. But why is it so? It's because that everyone tells that data is a new oil, right? Why generally people tell that data is a new oil? Didn't we have data before? Or is it that we are getting something new? Why is it so? So the reason is we had the data before also, we have the data now also. But the reason why this data is gaining so much importance because the price of storing the data has come down significantly, right? So if you could recollect from your school days, in your school, we used to have the floppies, right? And the floppy maximum size would have been, I don't remember, but it was in KBs, right? So do you think even a single song can fit into KB storage? No, right? It's not easy because if you could recollect the size of one single song, it's around 5 MB, right? So you can't even store a single song in floppy drives. So what was the cost of a floppy drive? So just imagine if you want to buy 1 terabyte of hard disk somewhere 20 years back, it was around $1 million if I'm not wrong. For 1 terabyte, people used to spend millions of money for just buying or storing 1 terabyte of data. But now, if you understand and if you look at the market and then if you look at some of the hard disk, you notice that 1 terabyte is cost around 3,000 to 4,000. And also now we have option to store the data in cloud, right? So this is the reason that the storing the data has become significantly very less expensive so that every organization is focusing on storing the data. And what happens by storing the data? It's pretty simple. When we have the data, historical data, we should be able to predict the future. And how do we do that? We cannot predict the future. We will be writing some algorithms which will be predicting the future. And how do we write those algorithms? With some statistical analysis. And how does statistical analysis or algorithms will know that what needs to be read and how does statistical methods would know what how to predict based on the past data. So it's simple. We have the past data, we are feeding that to machine or the statistical methods. Based on that, by looking at the data, machine is learning. That's the reason it is called as machine learning. And then machine learns the past data, it gets trained on the past data, and then it predicts on the future data. So this is a simple definition which will be repeated again and again throughout the course because it's very important. So everyone might have heard ML and AI of late, right? It's very important. But to become a machine learning engineer or artificial intelligence engineer, what do we need? If I want to go and look at this, what do we need to become a machine learning engineer? So the first thing which I would always tell to my candidates that the three most important things which are required to become a data scientist. So after completing this course, you will be applying for the job, right? So once you apply the job, you will get a job position of ML engineer or AI engineer or maybe data scientist. So what do we need to become that? While understanding this course, I want you guys to focus on three different points. And the first point is maths and stats. So this is the first point where I want you guys to focus. And second point, coding. Third point, common sense. And when I'm taking this course, I'll make sure that you work on all three. How will I do that? I'll keep on asking some mathematical and statistical questions throughout this course. And don't worry, guys, don't worry. This is a very basic maths and stats which is required. So you don't have to worry. I will make sure that you are coming up to that grip that you should be able to understand simple maths and stats. So if someone likes maths and statistics, then it's very good. And if you don't like, then don't worry, because this is very basic maths and statistics which is required for this course. And I'll make sure that at the end of this course, you will start loving maths and statistics. And coding, it's my responsibility. The onus is on me that I make sure that you guys, all the candidates have good amount of knowledge on these three areas. So how will I make sure that you're good in coding? So in every class, I will be doing some hands-on in Python, and after the class, there will be some assignments which you guys need to complete. So the onus is on you as well that you should complete the assignments. So if you complete the assignments, I don't see any reason that why don't you become a data scientist. So if you do your hard work from your end and just listen to the videos and complete the assignments and projects, then I'm pretty sure that you will start loving this course, and then you will fetch a good opportunity in data science field. And the third field, so which is my favorite, so common sense, right? I have thought a lot and I have done a lot of brainstorming on this, and I felt, how would I make sure that everyone should think like everyone would be working on it, right? So nowadays in our organization, in colleges, we keep thinking in this direction. But I've kept only one simple effort which I want to put forward from my side is, after every class, I'll keep asking the puzzles, guys. So by that, I will make sure that your logical thinking increases and your analytical skill increases, by which you will start loving the course. Okay. So these are the three things which we both in the sense, you all students and me, that we all have to focus on these three. Theory part, it's anywhere there, but these are the three core areas or core things which we always have to focus. Okay. Cool then. So let's get started. So this is the course structure. This course is divided in 12 weeks. So today is our first week. The first week, as I told, will start with some simple probability and mathematics and statistics, so that I can make sure that you have not forgotten your maths, what you have learned in your school, because I want everyone to go back and recollect all the fundas what we have learned in our school days. So in this session, we'll be looking at those points. And believe me, it's important. Probability and statistics is important for this course. So that's the basis of machine learning. And then we'll start with basics of machine learning and AI. From third week, we'll start the real predictions. So it's important. We'll start working on the predictions. So as I already told, machine learning is all about predicting, right? So that is where we'll start. And then I don't have to go into week 4, 5, 6, because those are also different machine learning algorithms from week 3rd to week 12. But first and second, first one is mostly mathematics. Second one is the basics of machine learning and AI, which is also again more of maths. Okay, so to get started, guys, welcome to this first week of course, and this is of basics of probability and statistics. We all know, and believe me, guys, I'll keep asking a lot of questions between the sessions. So, basics of probability and statistics. So, what is probability? In simple language, in a layman terms, how likely an event is to occur. Simple, right? For example, so as I told, this is for mostly, there will be a lot of mechanical aspirants in this course. And me coming from mechanical aspirant, I will also give a lot of examples in mechanical direction. So let's imagine that you have a machine. How likely that your machine will deteriorate, or how likely your machine might get spoiled. Simple, right? Or for example, on the brake disc, how likely your brakes will fail, something like that. And how do we calculate the probability? Probability is something, favorable events divided by total possible events, right? So here there are three pictures, and these are the three pictures which I have taken, thinking that in our school days we have done a lot of problems on probability on these three examples. Guys, before going into those questions, please let's play some games and let's think in this direction. Are you able to recollect all the basics of probability and statistics? First, starting with simple questions. I have one coin. What is the probability of getting heads? Quickly, guys. Simple question. How can it be 1? I agree with 1 by 2 and zero point 0.5. How can it be 1? It cannot be 1, right? Listen to the questions, guys. I have two coins. What is the probability of getting two heads? I agree with 1 by 4. I agree with 0.25. I do not agree with 1 by 3. I do not agree with 2 by 4. Yes, I agree with 1 by 4 and 0.25. So there are some candidates who have also answered incorrect. So that's not a problem. So that's the reason we have this first week of course. So it's simple. In the first example, I have one coin. What is the probability of getting heads? So by looking at the formula, what was the favorable event? Getting head. Now, total possible events. Now, what are the total possible events do we have? Two, right? Head and tail. What was the favorable event? It was head, which was 1, right? So the answer is 1 by 2, which is quite simple. But when I have two coins, okay, let me take this. I can do this exercise of two coins by taking two coins and tossing them and getting two heads, or tossing a single coin two times and getting head two times. So both will lead to the same solution. Okay. So in this case, when I'm tossing a coin two times, then the total possible events. What are the total possible events in this case, guys? It would be 4, right? How? Let's quickly do that. So I have two coins, right? So I can get heads, I can get head tails, I can get tail head, and then let me put it in brackets so that you don't get confused. And don't worry about my handwriting, guys. Till you are able to understand, I'm fine with it. Don't worry about the handwriting. So there are 4 outcomes when I'm tossing a coin 2 times, right? Head, 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 tails, tail, head, tail, tail, right? So all the total possible events are 4. Now, what was a favorable event? Getting 2 heads, and that would be only one event, right? So the answer is 1 by 4. So I hope everyone is able to understand this. Okay. If I am tossing a coin 3 times, what could be the possible outcomes? First of all, tell me how many outcomes will be there. 8, right? Okay, some of you have written 8. Great. See, guys, initially I'll be slightly slow because I want you guys to recollect all your fundas, the basics which we have learned in our school. Okay. So, and what is the probability of getting 3 heads now? It's 1 by 8. So let me rephrase the question now. So, okay, someone has written 2 cube for the denominator. So let me first explain that. We can't keep on writing all the events in the denominator, right? So if you want to know what is the denominator value, for that, if I'm tossing a coin single time, the denominator will be 2 power 1. If I'm tossing a coin 2 times, it will be 2 power 2. If I'm tossing a coin 3 times, it will be 2 power 3. If I'm tossing a coin 4 times, it will be 2 power 4, so on. So that's how your denominator will be decided, right? Now, let me rephrase my question, and I want everyone to tell this answer because till now I have asked very simple questions. Now this would be a slightly of intermediate level. Please listen to the question, guys. What is the probability of getting exactly one head when you're tossing a coin 3 times? I agree with 3 by 8. How can it be 1 by 8, guys? How can it be 2 by 8? It should be 3 by 8. So we all know how the denominator is 8, right? Now let's understand how we got the numerator as 3. Let's understand that. So this was one outcome. The second outcome was this one. This is your third outcome, fourth outcome, fifth outcome, sixth outcome. What will be the seventh one? Seventh outcome. What will be eighth one? Okay, so I have written all the 8 outcomes, right? Now if you notice, getting exactly one head, what are those? So let me write what are those. It's H, T, T and T, H, T and T, T, H. So now the total possible outcomes, we have 8. Getting exactly one head, we have 3. The total favorable events are 3. Total possible events are 8, right? So going back to the slide, exactly one head, the answer would be 3 by 8. I hope everyone is able to understand this. Okay, now let me rephrase. I'll be asking a lot of questions, guys. You have to answer it, okay? Because I want to make sure that you remember all your basics, okay? Now, I'm tossing a coin 3 times. What is the probability of getting exactly 2 heads? Come on. It's 3 by 8, right? So now all the total 8 possible events, right? So the denominator is 8, right? That's correct. But for numerator, so this would be 1, right? I'm just striking it, okay? This would be second, this would be third, right? Making sense? We have total 3 favorable events divided by all the 8 events, so 3 by 8. Right. Now, till now, I will come up with the logic, okay? So, till now, we are dealing with only 3 coins. That's the reason we are able to count them. Or what if we are tossing a coin 100 times? We'll look into such possibilities as well. But before going ahead, one more simple question. What is the probability of getting exactly one head tossing a coin 3 times? Come on, quickly. 7 by 8 is the right answer, guys. Why? So if I want to look that, for example, what are the possible ones? At least one head, right? So it can be one head once, which is this, this. At least one means it can be two also. So this one also, this one also, and this one also. The ones which I'm striking with blue color, okay? At least one means it can be 3 heads also, right? So now if you understand, the answer is pretty simple, which is 7 by 8. Now, we can also tell the answer in different way. At least one head means 1 minus 0 head probability, right? 1 minus the probability of getting no heads, right? Both are same, right? So probability of getting a no head is, that means when we have all the tails, right? So which is 1 by 8. So this will also be 7 by 8. And why we have 1 here? Because the sum of the probability for all the events will be 1, right? So sum of the probability will be equal to 1, right? So either you can get 7 by 8 by counting like this, or 1 minus probability of getting 0 heads, which is 1 by 8. So 1 minus 1 by 8, which is 7 by 8. Making sense, guys? Now one last question on this before we go into 100 coins. What is the probability of getting at least 2 heads? It's 4 by 8, right? 0.5. How? Because 2 heads means it can have either 2 heads or 3 heads. So for 3 heads, only one event. For getting 2 heads, there are 1, 2 and 3. So 1, 2, 3, 4, 4 divided by 8. Let's go to a difficult problem. Now I have 100 coins. Listen to the problem. Or let's imagine this. I am tossing a coin 100 times. What is the probability of getting exactly 50 heads? Let me simplify the problem and then you should tell me the answer, okay? If I'm tossing a coin 100 times, see, the probability cannot be greater than 1, guys. Okay, so as I told, for 100 coins, you don't have to worry because this is a complicated problem. You don't have to go with Poisson distribution. Okay, please hold on, guys. I will ask you one simple question. Tell me the answer for that first. I am tossing a coin 4 times. What is the probability of getting exactly 2 heads? As per your previous logic, is it 2 by 4? So everyone is writing 2 by 4. Okay. I'm tossing a coin 4 times. What is the probability of getting exactly 2 heads? See, this is where I want you to think. So that is where common sense comes in. Guys, everyone, please note down. As I already told, the logic for denominator, as you increase the number of tosses or the number of coins, the denominator increases with the power of 2, right? So for 4 coins, the denominator will be 2 power 4, right? Now we have to decide for the numerator. So 2 power 4 is 16, right? Please write all the 16 events because now you know that the denominator logic is very simple. When you're tossing a coin 1 time, the denominator will be 2 power 1. When you're tossing a coin 2 times, the denominator will be 2 power 2. When you're tossing a coin 3 times, it will be 2 power 3. When you're tossing a coin 4 times, it will be 2 power 4. So the denominator logic is pretty simple, guys. Okay. Now we have to decide for the numerator, right? Of exactly getting 2 heads. So everyone, please write it down on your piece of paper. Everyone, guys. So that's the reason why I'm taking this first week of course, because I want everyone to refresh their mathematical skills. Okay. For 4, there are 6 events, right? So now, what was the answer? The answer was 6 by 16. So was the answer 1 by 2? Was it 1 by 2, guys? No, right? It was not 1 by 2, right? As some rightly mentioned, 4c2 by 2 power 4. Now let me go back and tell you how did he get 4c2 by 2 power 4. Now you must be wondering what is this c, right? So that is what I always tell guys. Never ever forget your basics. So what is the C? Combination. Do you remember permutations and combinations, guys, from your school days? P and C, permutations and combinations. So we have 4 coins, that means 4 heads, right? Out of 4 heads, we want 2 heads. So we are selecting 2 heads, right? So that's the reason we have the numerator 4C2. And the denominator logic we already told, which is 2 power 4. So the answer is 4C2 by 2 power 4, and 4C2 is 6 by 16. I have 4 coins. I can get 4 heads maximum, but out of 4 coins, I want only heads on 2 coins, right? So that's the reason I have 4C2 here. Now, can you please tell me the answer, guys? It's for 100 coin questions. So answer is 100C50. If I want 50 heads, it is 100C50 by 2 power 100. So will it be 1 by 2? It will not be 1 by 2, right? Someone has already calculated through calculator. Thank you for the time. One more time. I have tossing a coin 100 times. What is the probability of getting 100 heads? It cannot be 1 by 2. So it's 100 C100 by 2 power 100. So it's 100 C100 divided by 2 power 100. And 100 C100 is 1. We'll discuss that. How to calculate the C values also we'll discuss that. But now, is everyone on the same page? Are we able to digest this? I can understand the answer it's very small, but yes. Here the answer is not important. The concept is important. Is everyone able to digest the concept? Now, listen to the question. I'm tossing a coin again 100 times. What is the probability of getting at least 99 heads? Okay guys, I'm not biased towards heads, okay? It's just that I'm taking all the questions with respect to heads. I can also ask the questions in terms of tails, okay? At least 99, at least guys, at least. Not exactly 99, not exactly 100. Someone has given the right answer, but can you please write that in terms of C? See, you cannot write in terms of 1 minus, guys. Yeah, you need to understand this. If I want to write that in terms of 1 minus, no, it will be very big answer. You need to understand when to write 1 minus and when to write directly the answer. Let me write down. Now, I have 100 coins. So the denominator is 2 power 100. Simple, right? Now, at least 99 means it can be 99 or it can be 100 or it can be greater than 100. But ideally, it cannot be greater than 100 because you have only 100 coins, right? So it can be only 99 and 100. So I can get 99 coins, or in permutations and combination language, if you remember, or means addition. 100C 100. So this would be your answer. Why I cannot write 1 minus? Because if I write 1 minus, then I have to write, see, if I ask you question of at least 1 head, then it was pretty simple. Because at least 1 head means 1 or 2 or 3 or 4 or so on up to 100 heads. So we can directly write 1 minus 0 heads or no heads. But for 99, you cannot write that, guys. It will be very difficult to write that, at least 99 heads, right? So if I want to write for at least 98 heads, then it will be 100C98 plus 100C99 plus 100C100 divided by 2 power 100. Making sense? So you should understand what does at least mean here, right? So plus means or in permutations and combination language, and means multiplication. So for 5 minutes we'll have Q&A questions. How to calculate C? Okay, I'll be telling this answer in the course anyways, so please hold on with that. Next question.
So how it is useful for mechanical industry?
So before going to this question, let me tell you, I'm also coming from a mechanical industry mostly, okay? And see, think in this way, we need break as a human being, right? We might fail. Similarly, machines can also fail, right? And now if you see, there are many opportunities in prediction when the machine will be failing. So that, for example, in the manufacturing area where you are manufacturing something, there will be a lot of machines, right? Let's example lathe machine. Everyone knows what is lathe machine, right? So if we know when this lathe machine gonna fail, if we can predict that, then we'll not be using that lathe machine in a weak condition. and using it furthermore and deteriorating it. Once we are able to predict it, then we can replace that machine or we can repair that machine. As someone has rightly mentioned, life of machine calculation. Yes, you can expect the life. You can predict the life of the machine. This is one example. There is one more example which I can give you guys. See, for example, as a mechanical engineer, we always think of temperature, right? So if we do this mechanical simulations, we know that mechanical simulations takes a lot of time, right? So we need to do something else. We need to predict the temperature, right? If we can predict the temperature, then it will be quite simple. We don't have to perform so many simulations for long enough time. We can directly predict the temperature itself. Is it possible to get a job in ML or AI domain with knowing Python software alone? To answer your question, see, if you know only Python, yes, you can directly get a job, but then you should have the knowledge of machine learning and AI. So by this course, you will have that knowledge. And yes, Python is enough. Believe me, Python is enough. In point view of industry, they can hire students from IT and CSC background. Please elaborate your question. Meanwhile, I look at some other question. Yes, is there any basic course on coding that can help us? Okay. So, see, there are a lot of courses, but you don't have to worry, guys, because, okay, I'll be starting with very basic of coding in this session. You don't have to worry. What is the difference in predicting by ourselves and by machines? Is it trustable? So if we are predicting something by ourselves, just imagine if you want to get the temperature of the brake disc, and if it is a transient simulation. I hope you are coming from a mechanical background. So if you want to predict the temperature of the brake disc, and if you want to perform the brake disc simulation over the vehicle, then just imagine, guys, to perform a brake simulation over the complete vehicle, it takes 25 days. Believe me, you might get the very good accuracy. You can compare the accuracy with test results. The accuracy might be say 90 to 95%, but is it really worth it spending 25 days? If you get the answer by predicting using machine learning within couple of hours, maybe with 80% of accuracy, we don't mind getting that 80% of accuracy if we are able to predict in 2 hours. So what we are doing, we are compromising with accuracy, but the computational time has significantly reduced, right? Isn't it? I think I have answered your question. You can elaborate if you want to, but use of R as compared to Python in ML. Okay. To answer this question, use of R. See, R is also quite famous, but then you have to understand when to use R, when to use Python. See, R is used for statistics. R is quite famous when you want to go with statistics. Okay. But when it comes to machine learning and deep learning or AI, Python is more robust. Okay, so that's the reason we are going with Python, and a lot of organizations are hiring for Python. How AI, ML, and DL related? Okay, for this question, there is already an answer in the second course, so I don't want to go into that. Okay, so but I can quickly tell you what is AI. AI is something where robots or machine can mimic humans. Simple. Machine learning is something where we are improving the machine's accuracy by looking at the past data. DL is advanced machine learning. It's a simple classification which I'm telling. Okay, we anyways have a separate second week of course on this. Don't worry. If I want to join in ML domain, should I only focus on programming part or in mechanical subjects as well? See, it depends in which organization you are getting hired for. If you're getting hired for mechanical subjects, you don't have to worry. Anyways, if you're coming from a different background, you don't have to worry, guys, because people will hire you only basis of your machine learning knowledge. Okay. If you have mechanical knowledge, it's just an advantage, but you can always apply for different organizations in different domain. Okay. It's just a matter of domain knowledge. Don't worry, guys. You can learn domain knowledge quickly after joining the organization, but your interview mostly will be on technical, which is machine learning and data science. Okay.
Most of the data analytics jobs from accounts for tools like Informatica, MDM, SAP, Boots. How to compare this job with data science using Python for ML and AI? How vast is its market in India based upon opportunities?
Okay. See, what I can tell you is you can look for the job opportunities. Just write data science in any job portal. I don't want to encourage any job portal, but that's the reason I'm not bringing out the name. But just open any job portal website and look for the opportunities in mechanical background or your corresponding domain knowledge background, and look for data science. You will come to know how data science is important. You have number of opportunities in data science, number of opportunities. Can you give him the list of companies? Because I have just, but Every company is using data science. Believe me, every company nowadays is using data science. Without data science, company might encounter loss because then they have to spend a lot of money in predicting something by themselves. So every company is using data science. To answer the question, how to calculate C. So what is C? Permutations and combinations, right? P and C. So if I want to calculate, for example, 100C2, then you have to write 100 and then one number less than that, and then in the denominator 2 into 1. Simple. If you want to calculate 100C3, then 100 into 99 into 98 divided by 3 into 2 into 1. Okay. Similarly, if you want to calculate 100C50, you understood, right? You have to write 100 into 99 into 98, so on up to 51 divided by 50 into 49 into so on, right? So I think everyone, you got the logic how to calculate the values of C. But there are few more things which you need to understand, because we cannot, for example, if I want to calculate say 100C99, I cannot calculate 100C99 like this. 100C99 will be equal to 100C1, so which will be 100 by 1, which is 100. I cannot calculate 100C99 in the below method, right? So there is a particular logics. So you have to go back and refresh your basics. Okay. How to calculate the permutations and combinations. There are different formulas for permutations and combinations. You can also read them, but this is how you basically calculate the C values. Now for permutations, let me just tell you for P also. I don't want to spend much time on this, but let me just quickly do that. 100, this is 100P2. Okay, let me write 100P2 once again. It's 100 into 99, simple. In C, you will get the denominator. In P, you will not have denominator. The denominator will be 1, simple. We are still on first slide, guys. I need to hurry up. Let's quickly have some more questions. You can take this as an assignment, guys. I have 2 dice. What is the probability of getting 1 on both the dice? 1 by 36, yes. So denominator, you got the logic, right? For coin, it was 2 powers. For dice, it will be 6 power. So it's pretty simple. And I don't want to take some more examples here. Let's go ahead. And everyone has enough knowledge on probability. So basics of probability and statistics. So this is very important. So the slide which I'm showing you now, this is the basis of your machine learning. So imagine this. This is your population. So when we have the data, we have the data of the population. What is population? Population is everything. So if I'm collecting the data of everything, then that's a population data. But if I perform my algorithms, which we'll be learning in the future classes, if we'll be doing our analysis on the population data, just imagine how much time will it take. So what we do, we use sampling techniques, and then we will bring out a sample. So we'll be taking this out of population, we'll be extracting the sample. How we'll extract the sample? Based on sampling technique. And then we perform our analysis on this sample. Okay. See, the reason why I'm stressing so much on sample, because your machine learning is completely dependent on samples. So we'll extract the sample using some sampling techniques. We'll have a look what are those sampling techniques, but first understand this flowchart. So we have extracted the sample now. We perform our descriptive analytics. We do lot of analysis, and this analysis on the sample is called descriptive analytics or descriptive statistics. Now, using sample, we do a lot of analysis, a lot of descriptive analytics, or a lot of descriptive statistics. And then, based on this analysis, we infer, see, when we do analysis, we'll get some results. And then using those results, we'll infer and we'll draw the conclusion for population. Okay, so it's like a loop. So to give a simple example here, just imagine I have one place. Suppose, let's take, I have one land. There I have lot of companies, say 1,000 of companies, and I cannot read the data of 1,000 of companies. So what I do, I will take the sample. Say I take the sample, let's take, I say 50 to 60 samples. Okay. And what I see, if I take the sample of 50 to 60 companies and I read about those companies, and if I see those 50 to 60 companies are say Mercedes-Benz, BMW, or say Porsche, or say Chrysler or something else. Okay, so what I am understanding from this, so what I can infer about the population, I can infer that all the 1,000 companies might be, okay, understand this, because we are predicting, we are not telling something certainly, we are predicting. So might be all the companies in that area would be mechanical industry or automobile industry. That is what we are predicting, right? This is how we do descriptive statistics and inferential statistics. What is inferential statistics? Some based on the sample results, we are inferring something about population. So that is inferential statistics. Now, see the reason why I have focused so much on this flowchart, because this is the basis of your machine learning. Now, what are the sampling techniques? In the broader picture, sampling is divided into two. One is probability sampling method. The other one is non-probability sampling methods. See, non-probability is pretty simple. I don't want to get into more detail over there. There are a lot of non-probability sampling methods, okay, first of all. But this non-probability sampling methods would be slightly biased, okay, because we understand probability is for unbiased, right? So we cannot go with non-probability sampling methods for our analysis. We should always go with probability sampling methods. We should always go with probability sampling methods. So now these are divided into four. The first one is simple random sampling. Now in this example, I have 1,000 companies. I have say sampled 50 companies. How would I do that? Say all the 1,000 companies are lined in one after other, first, second, third, so on. How would I sample them? Or let's take a even further simple example. I have 10 boys and 5 girls, and I want to form a team of 3 members, which I will be sending for national competitions. So how would I sample these 3 people from this 10 male and 5 females? So out of 15, I will do simple random sampling. Simple random sampling is I will directly choose 3 people randomly. That is called as simple random sampling. What is systematic sampling? For example, if I number the people 1, 2, 3, so on up to 15, okay? And if I want 3 people for my team who will be going for nationals. So what I will do using systematic sampling, that means what is systematic sampling? Systematic, right? Simple English word, systematic. So for example, I'll choose in this 15 people, I will choose 5th person, 10th person and 15th person. Simple, systematic sampling, right? Stratified sampling. This is mostly, so simple random sampling and stratified sampling is used in majority of the organizations. Systematic and cluster generally do not used as much as simple random sampling and stratified sampling is being used in different organizations. So what is stratified? For example, if I want to form, see, imagine in this way, I have 10 men, 5 women. I want to select a team of 3 people. Now, if I choose simple random sampling, there might be a chance all the 3 people are men, right? There could be a chance, right? So this is where stratified sampling is important. So for example, if I want to form a team of 3 people such that 2 of them should be men, 1 of them should be female. So in this case, what I do, I'll make some stratas. Stratas means groups. Okay. So I'll form a group of 10 men as one group and 5 female as other group. So out of this 10 male, I will select 2 randomly, and then out of 5 female, I'll select 1 female randomly. Okay. So this is how we do stratified sampling. I want you guys to read about clustered sampling. Okay, I will not go into that. I want you guys to do homework. And I also want you guys to read about non-probability sampling methods also, because people, a lot of interviewers also ask questions on this. So I don't want you to lose some opportunity because of this. So you can also read about it. Okay. But I'll be focusing more on important areas and you have to do the homework. Okay. Now, as I already discussed about population and sample, we all know what is mean. We have learnt in our school days, right? So let's do one simple exercise again. I have 5 numbers. Everyone note down. I have 5 numbers 1, 2, 3, 4, 5. What would be the mean? Please write it in the chat box. 3, right? How is it 3? 1 plus 2 plus 3 plus 4 plus 5 divided by 5. So it's a simple average, right? So the mean would be calculated for population and sample using the same formula. Now what is variance? So mean is you're measuring something. It's a measure of central tendency. Variance is how much your data is variated, right? That means the measure of dispersion. Okay, for example, let me quickly draw it. So I have 5 students, right? 1, 2, 3, say 4, 5. Or you can take 1, 2, 3, 4, 5. So this is a mean 3. But this point is dispersed from the means with this quantity, right? With this much. This 3 is lying on the mean. This is again dispersed about the mean. This point is again dispersed about the mean, right? So that is the reason variance is called measure of dispersion, and it is calculated using this formula which I am showing you. So what is xi? So what is this? Xi are the observations or the records or the numbers which I told 1, 2, 3, 4, 5. What is mean? Mean is 3, which we have already calculated. What is n? Number of observations. In this case, it is 5. What is sigma? Sigma from our school days, if you remember, the sigma is denoted for summation, right? So variance is denoted by this other sigma square. Okay, this is also called as sigma. This is also called as sigma. Do not get confused. Okay, so this is sigma square is variance and this sigma is summation. So this is how your variance is calculated. So this variance is calculated for all the observations over the mean or about the mean. Yes, you have a very good question. Why variance is always square? See, the point is, anyways, I was about to explain that. See, for example, just say that x is the observations of, say, different vehicle speeds, and we know that vehicle speed will be kilometer per hour or meter per second. So the mean will also be in same units, right? But when you take the variance, this variance has a square, right? So that's the reason. Now once we have a square for the variance, the units will become meter square per second square, right? So that's the reason it is denoted by sigma square. Now to answer your question, why it is always having square, it is very interesting question. I can understand this. In our school days, we never have thought in this direction, but you have a very valid question. So this is our mean. This is 1, this is 2, this is 3, this is 4, this is 5. Now if I want to calculate the variance, the dispersion without square, just imagine without square, x minus mean, right? For this 1 minus 3, which is minus 2. For this 2 minus 3 minus 1. This is 3 minus 3, which is 0. This will be 4 minus 3, which will be 1. This is 5 minus 3, which will be 2. Now sigma means summation, right? So if I add this now, minus 2 plus minus 1 plus 0 plus 1 plus 2. Now I will get 0, right? So it has no significance. We could see that from here we have a variance, we have the dispersion, but the value is 0. It is clear from the graph we have the dispersion, but from this value it is clear that it tells there is no dispersion. So there is something wrong, right? So that is the reason we always square it. We always square it, because once we square a number, negative number will also become positive, right? So that is the reason we always square. Again, you have a very valid question. Why can't we have mod? Okay, I can answer this question, but you have to hold on. For this question, the answer will be there in 3rd week, because I don't want to tell anything which would not make sense to you now, because I want to take one step at one point of time, so that by end of this course everyone should be able to understand what is the significance of each term. Okay, I want you guys to ask this kind of questions, because this kind of things we have never learned in our school days, Okay, now we have learned about variance. There is something called as standard deviation also, right? So standard deviation would be square root of variance, simple. So now tell me, when variance is giving us the measure of dispersion, why there is something called as standard deviation in this whole earth? Why there is something called as standard deviation? See, we know variance and standard deviation from our school days, that both are measure of dispersion. And what is standard deviation? Square root of variance. You can tell the answer, guys. You can be wrong, okay? Give me the explanation with only simple basic knowledge. When we already have variance on earth, why there is something called as standard deviation being discovered? You understood my question, everyone?
Yeah, so we have an answer. Standard deviation is required to estimate the capability of the process or acceptable range of variance for a process.
Okay, let's think in this direction. Yes, you all are right, but to see in this direction, okay, let me go back to the OneNote and then explain it in a better way. What I told, for example, if I have vehicle speeds, right? Say some vehicle are driving with 30 kilometer per hour, some of them are driving with 50, some of them are driving with 70, some of them are driving with 90, and some of them are driving with 100. So, okay, one vehicle is driving with 30, one vehicle with 50, one with 70, one 90 and 100. If I take the mean, I can calculate the mean here. It's not a big deal. I can calculate the mean. I can also calculate the variance. But if you remember the formula for the variance, we have a square, right? And why we have a square, I have already told. So now, if we take the square, yes, the measure of dispersion will be squared. But why there is a standard deviation? That is still not answered. But if you see in this way, see the what will be the units of the mean? It will be again kilometer per hour, right? But the units of variance will be kilometer square per hour square, right? So this is incorrect. For our analysis, we have to maintain the consistency with respect to units. We have learnt in our 11th class, in units and dimensions, we should maintain the consistency with respect to units. To maintain the consistency, we take the square root over here. So if I take a square root of variance, which is called as standard deviation. So this is our standard deviation, so that our units comes back to the original unit, which is kilometer per hour, right? So our measure of dispersion should go back to the original units. But you should understand that if mean is some unit, say meter per second, then variance would be meter square per second square. To bring back, and your observations are also in meter per second. To bring back the units in the same meter per second, we have to take the square root of v, which is called as standard deviation, which is again meter per second. So that is the reason, guys, there is something called as standard deviation was discovered. No, variance and standard deviation will have the units. It depends on your observations. Your units will be taken based on your observation. If your observation is in meter per second, then mean will always, see, why do we always call the average speed? Average speed means we have a units, right? And then measure of dispersion. For what we are doing? Measure of dispersion. We are measuring the dispersion of the speed with respect to mean, right? So the dispersion should also have the units, right? Getting my point? So that is the reason the units needs to be consistent. Now, the assignment for you guys, I have taken an example with 5 observations, okay? You can take an example with 10 observations, 20 observations, or 100 observations. We cannot directly use standard deviation. Tell me, could you please tell me how do we use standard deviation directly?
Actually, we have a variance and then its formula, right?
Right.
So instead of that, why can't we use standard deviation and have its own formula, square
See,
root of variance?
see why we are squaring? So that the negative values, what we have learned here, the negative dispersion and the positive dispersion should not get cancelled, right?
Yeah,
That is the reason we are squaring it.
yeah,
So,
that's right.
so when we are squaring it, we know that we are changing the units. So that is the reason we want some intermediate measure, and that intermediate measure is called as variance. And through variance, we are calculating standard deviation. If you want to write directly for a formula of standard deviation, you can directly write square root of sigma x minus mu whole square divided by n. There is no harm in that. Okay.
Yeah.
But then it's important that we know what is the significance of variance and standard deviation. See, I'm not here to do a lot of maths in this class. I'm here to explain the significance of each parameter.
Okay, sir, got it.
Again, you have brought a very good point. We can do different mathematics. Everyone can do a lot of calculation, but we should know the significance of each term what we have learned in our school days. Okay?
Yeah, sure, sir. Thank you.
Welcome. Okay, so now the assignment for you guys. If you have the observation, say 1, 3, 5, 7, 9, 11, 13, 15, 17, and 19. Take simple random sampling and take only 3 samples, and then calculate the variance using this formula and then sample formula. So you must have noticed that there is a slight change in the formula, right, in variance and sample. So this is your assignment, guys. In our school days, our teacher might have told us that this is the formula and then we are mugged up. I don't want you to do that. In my class, I want you to tell the reason why the formula has changed. Did the mean formula change? Yes or no? Please type. No, right? Mean formula has not changed for population and sample. Then why did variance formula change? You have to think, guys, okay? Then why did variance formula has changed? Now again, this is a random variable. So for example, what can be the random variable? In this first example, if you remember, I have tossed 2 coins, right? And I wanted to check for the probability of getting 2 heads, right? A probability of getting exactly one head, a probability of getting no head. So that is our random variable. So in this case, x could be number of times we receive head when a coin is flipped, 5 times. So x equal to 1 means head is appeared 1 time. X equal to 2 means head has appeared 2 times. Okay, so that is called as random variable. Now random variable can be of 2 types. It can be of discrete, it can be of continuous. Discrete random variable, so it's very simple English, guys. Okay, what is discrete random variables? Where discrete means something for which the decimal point does not make sense. For example, number of people. Can I tell 1.5 people? No, I cannot tell 2.35 people. I can only tell 1, 2, 3, 4, 5. I can tell 1 head, 2 heads, 3 heads, 4 heads. I cannot tell 1.5 heads. So that is discrete random variable. But continuous random variable, where the decimal point makes sense. Salary, your weight can be 70.5, 70.2, right? So it makes sense, right? So that's the difference between discrete random variable and continuous random variable. Okay. So for example, number of machines which are failing would be discrete or continuous. Please write down, guys. Discrete, right? Good. So number of TVs sold, discrete or continuous? Discrete, right? Height of a person, discrete or continuous? Continuous, right? Great. So let's go ahead. I want everyone to do some simple analysis, okay? So for example, this is a Python interface, okay, guys? So if I'm writing, say 2 plus 2, say x equal to, I want you all, everyone to do this, okay, at your home. And we'll be sharing the guideline how to install the Python interface. And then you have to start writing this, okay? Yes, we'll do that. We'll do that. So, and then you have to write simple codes. Okay, for example, like this. And then you have to run the code. Now, if you see, I have printed x, which is 2 plus 2, so 4, right? If I want to print 2 power 100, so this is not 2 power 100 in Python, so this is what happens. So we have to remember the syntax. I believe this is the right one for 2 power 100. Yes, so this is the 2 power 100. So for some simple things which I wanted to do, guys, okay, play around with Python, okay. For example, if I want to put some characters, then characters should always be within the double quotes, okay. For example, if I want to comment this now, because I don't want to print this again and again, so I have to put hash here. So this is commented, okay. So it's taking some time to print because, yeah, I have opened this Python after a long time. Okay, so guys, you have to do in this way. You have to do lot of practice on Python. Do simple Python. Okay, I'm not asking anything more, right? Just do simple mathematics in Python. Print simple characters in Python. Okay, at least with respect to some simple maths, 2 into 3, 5 into 100, something like that, so that you should get the flavor of Python, so that in next class we can go with other things. For example, some important syntaxes for such as if else, for loop, so that we can learn all those stuff, okay, in next class. For example, repeating 500 times, we have to use for loop, right? Something like that. Do some simple things, okay, and then you will start loving coding. And you have to practice, guys. In the class I can teach you the syntaxes, I can tell you what needs to be written in coding, but until and unless you practice, you will not be familiar with the coding. You will be scared of coding, but I don't want you guys to be scared of coding. Do simple things on Python, and next session we'll be going with some complicated syntaxes. That would not be much complicated, that would also be very simple. And after that we'll start with some algorithms. Okay, so let me take the questions. You can use Sublime also, it's up to you. I generally use Visual Code Studio, but it's up to you. You can use Sublime also. Someone has answered the question of our fourth question, right? I don't
Yes,
want to.
sir.
What is the probability of drawing two jacks on a pack of card? So no, that's incorrect. You can please think on it, okay? Because the probability, right? It is probability. Probability can never be greater than 1. Okay, guys. So what I'm telling is, for the fourth question, you are telling the answer, right? Probability cannot be greater than 1. You have told the answer 44C4, which is greater than 1. Yes, you can use the Anaconda interface, but I recommend to use Visual Studio Code. It's because so that we both are on the same page. Okay. So you have to work on these 6 questions. DL and AI can also be used in Python. Yes, that's the reason we are looking for Python, right? Because deep learning and artificial intelligence is in Python. We'll be doing a lot of stuff in Python. You will start liking it. Is MATLAB and Python same? To some extent, yes. The coding is very simple in Python. Python is very simple coding language. I would not say that both are same or not. To some extent, both are similar, okay? But then Python is very simple. That's the reason we have chosen Python, and that's the reason Python is in so much demand in market now.
We have used Mac techniques. Does IT engineers also use the same?
Okay, so see, if IT engineer, there is nothing such IT engineer or mechanical engineer. Those are different domains, okay? IT, electrical, mechanical. In mechanical, again, we have a separate domain such as manufacturing, thermal, right? So we have different domains. It's not that we cannot use these techniques in IT engineer, IT domain or electrical domain. We can use this technology in every domain. IT, ECE, electrical, mechanical, in everything. Okay, but we'll be looking into a lot of mechanical examples in this course, because this is developed in a way that mechanical aspirants should be interested to join this course. Okay, and others can also join this course. If they are not able to understand the example of mechanical, they can always stop me and tell me to provide some simple example. Okay, since our class is for mechanical aspirants. Yes, you can use the same techniques. See, the techniques are not changing, techniques are same. You can use the same techniques in IT, electrical also. Okay, see, by this end of this course, I would say you would be at the intermediate level, provided you practice, you complete all the challenges, projects what we give. Okay, and provided again you spend some time on this course, do lot of practice. Okay, and up to which level? So this is very important question. Okay, entry level or mid level? See, it depends on your current experience also. See, how much experience do you have now? For example, if you have 1 or 2 years, then you would be able to apply for entry level. If you have, like, if you have 5 to 6 years, then you can apply for mid level. If you have 2 years, then you have to apply for entry level. Okay, and you don't have to worry. If you don't have to worry, your salary would be increased. If you switch the job, and you all know that data science is on high boom, right? It's booming now. So you don't have to worry whether you're joining as an entry level or mid level. Important here is learning. Learning is important, and whether with this course, are you able to get placed in different organization? Is your salary increasing? That's important. And for me, all of you should get the course. For example, not formula. I want you to understand the significance. For example, the way I have explained the significance of square in variance formula, why there is standard deviation when variance exists. Something like this, guys. That is where I will be focusing so that you can clear your interviews easily. Okay. Can ML and AI be useful for applying? Yes, you can. Okay, this is very important. Yes, there are a lot of master's course as well. Okay, in the world. So you don't have to worry for that. Will the classes be recorded or interactive? It will be from my side. All the courses will be interactive. And if you have any questions, then you can always get back to us. Is there any sync from Python to different software? Yes, you can do the same thing. What we are doing in Python, you can do the same thing in R also. But that, as I already told, it's just a matter of syntax. Python is more robust, and you can do the same thing in R. You can do the same thing in MATLAB also. But then it's just a matter of which is more robust, and most of the organizations are working in which language. Simple. Is it related more to language or math? It's related more to mathematics. Okay, it's related to maths, and I'm very close to math. Okay, math is very close to my heart, so you don't have to worry. I'll make sure that by the end of this course, you will also start liking mathematics, and then you will understand the significance of different terminologies. Oh, of course, yes. I have done a lot of simulations on external aerodynamics. I have not a lot of simulations, but I have done some simulations on external aerodynamics. It was really beneficial, believe me. Can I use this course in automotive design? Of course, yes. See, that's what I told. No, I'm also coming from CAE field. I'm coming from CFD field. I have used this ML and AI in different fields. Yes, you can. Machine learning is useful in, I'm telling you, take any domain, you will find the examples on internet for machine learning and AI with respect to that field. Okay, so before ending, okay, as I've promised that I will try to improve your logical thinking by giving puzzles, right? I have one puzzle for you guys. Are you ready for it? Meanwhile, I'll take this last question. So the first puzzle is, how many squares are there in a chessboard? Okay. Thank you everyone for joining. Welcome everyone to the second course. So to begin with, for Vikas, I'll quickly go through what we discussed yesterday. We discussed some basic probability for the coin. When we roll the dice, what is the probability of getting 1? What is the probability of getting 2? So on. And then if we have a pack of cards, what is the probability of getting 2 jacks? What is the probability of getting 2 A's? Or what is the probability of getting 1 A? Something like that, some basic probabilities. Because machine learning is a course which is built on mathematics and statistics. Okay. We have also discussed yesterday that we would have a lot of data which is considered as population. And then we take a subset of that which is called as a sample using some sampling techniques. And those sampling techniques are mentioned here. So we can either go with probability sampling methods or non-probability sampling methods. But in general, we go with probability sampling methods because those will be non-biased. So we apply some sampling techniques, we come up with some sample, we do some analysis which is called as descriptive sampling or descriptive analysis. And then from the results what we get from the sample, we try to infer about the population. So this is called as inferential statistic, right? So for example, if there is a locality where say 500 houses are there, and I don't want to do the survey on all 500 houses, then I'll take the sample of say 50 houses and then I will check. So all the 50 houses, say assume all of them, all the people in those 50 houses are IT engineers or mechanical engineers. So I've taken a sample, I've done the analysis on sample, and then I came to know that all the 50 houses are being resident by mechanical engineers. And then we can infer the same for the complete locality, saying that the most of the people staying in this locality are mechanical engineers. So this is called as inferential statistics, right? And then I have explained mean and variance for population and sample. Okay, I've also asked some questions on this. So what I want now, let's go to the next slide first and then I will have the interactive session. But first let's go to the next slide so that Vikas is also on the same page along with us. So a random variable, what is random variable? It's a variable for which there is a chance of coming in. There is some chance associated with that, right? So for example, I'm tossing a coin 5 times and For me, x is a random variable which tells number of times we receive head. Then x can take the value of 0, that means 0 heads or no heads. X can take a value of 1, x can take the value of 2, x can take the value of 3, 4 and 5, right? Something like that. So similarly, this random variable can be divided into two, which is discrete random variable and continuous random variable. So for discrete, I've given the example of number of people entering into the store, number of cars in the garage. So I can have one car, two car. I cannot have 1.5 car or 2.5 car, right? So that means whenever the decimal point is not making sense out of that number for that particular example, then it is called discrete random variable. And when decimal point making some sense, then it is called continuous random variable, right? For example, salary, height of a person, weight of a person, something like this. Okay, the temperature measurement is continuous random variable, right? Because temperature can take 30 degrees, 30.5 degrees, 40 degrees, 40.25 degrees. Pressure, velocity, all these parameters are continuous random variable, right? So can you guys tell me if stress is a continuous random variable or discrete random variable? Not the English word stress, the word stress which is of mechanical terms. Okay, so could you please tell me? Continuous, right? Great. So now, okay, so this is the important session I wanted to discuss before going into the next session, because I will not be telling the answer here, but I'll be taking 5 minutes out of it and we'll be discussing, not me in particular, I would say you guys have to type the answer. I would not say whether it is right or wrong now, but I want to see your answers. Okay, so that I just want to make sure if you guys are trying or not, at least you're going back to your school days and then reading something about statistics or not. Okay, so what is the answer for first question, guys? Quickly, we have 5 minutes, we have 6 questions to cover. I will not be judging whether the answer is correct or wrong. You guys have to tell your answer just to make sure that you're working on it, and so that by your idea others can also get the idea if they are not working on it. It's important that we are spreading the knowledge among ourselves, right? Maybe I might be having a different reason for this, you might be having a different reason, so we are educating ourselves, right? So it's better, can you please everyone write in one statement answer in the chat box why there is a difference in the formula of variance for population and sample. Okay, answering second question. But for first one, due to difference in the denominator value, there is a difference. Yes, but why there is a denominator? Why there is a difference in the denominator? That's a question, right? Why there is a difference in the formula? That's the question. See, that's what I told yesterday, guys. Remember, I am not particular about the formulas. I am particular about the significance of each parameter. Why there is a change in formula? Okay, I got an answer. I got slightly better answer from Jayaram. Okay, so good. Some of you have answered, or some of you have answered. At least you have tried for it. I'm really thankful. For the second one, mentioned that, right? So Sarsha has also mentioned something about second question. Great. So it's good that you guys are trying. But now I want to know. Third one is interesting for me. How many different samples can be created out of a population of size n? Could you please give a try for this? Let's go one by one. What could be the answer for third one? N factorial? Let's think in this way, guys. For example, I have a population of say 1, 2, 3 and 4. How many samples I can create out of this? This is 1, this is 2, this is one more, this is one more. Similarly, so shall I write 2 comma 1? No, right? Because that's not a distinct sample, right? So I don't want to write anyways here, but there are so many samples which we can come up with from. Say for example, if I have 3, which is simple to write, so let me write it for 3 quickly. If this is my population, the sample would be this one will not be there, right? So there is no 4 here. And then, so I think you got the answer now. How many different samples I can come up with one particular population. So if I have n elements in a sample, then how many populations can it form? Right. So the answer, I would say, yes, 2 comma 1 is not possible, Harsha. Yes. 8 samples for 3. Okay, now there is a twist here. If you are considering a null set or empty set as a sample, then you would have 8, right? If you're not considering null set, then the answer would be 7 samples, right? But it depends what if you're considering or not considering, it's up to you. But for n, someone has already given the right answer. So you can think now you got the different answers. I want you guys to work on it and come up with the right answer. For the fourth one, what is the probability of drawing 2 jack from a pack of cards, guys? Is it 2 by 13? So the pack of card will always have 52 cards, guys. So I would say please go back and read the stuff from the probability from your school books. It's important because to understand machine learning in a depth knowledge, it's important that we know the basics, right? It's very important, guys. Okay, so I think there are different answers from different guys, but I want you guys to work on it now. Fifth one, what is the probability that both the numbers are on dice are same while rolling 2 dice? Fifth one would be pretty simple for everyone. What could be the answer for fifth one? Everyone knows the answer for fifth one, right? And now, why standard deviation when variance can measure the dispersion, which I've already discussed yesterday. So let's get started. Again, before going into the second week of course, I wanted to ask, did you guys try to work on that puzzle also? Because it's important, guys, for logical thinking, for problem, for structured thinking, it's important that you should solve the puzzles. So do work. Yes, chess puzzle. What is the answer for the chess puzzle? Right, it's 204. That's the right answer. So I hope everyone is working on the puzzle. Okay, so how many squares are there in a chessboard? Simple question. Okay, so before going ahead, do you all have now Python, Visual Studio, or any other interface of Python? Did you all install it? Great. So let's get started with some Python, because before going into the second week of course, I want to make sure that we have done some basics of Python, right? Okay, so let's make a list of vector, for example. So for example, I have a vector of x or list, something like this. If I want to print x, let's notice what do we get. So you notice that we are getting x as 1356, right? Now, if I want to say print x of 2, we understand 2, right? 2 is the index now. So we have x, based on the index value will come of this, it will print the value of x of 2. So can everyone write their answer? What could be the answer when I print this x of 2? Okay, someone has written 5. Great. So that's the right answer. So let me save this first. My output is on the bottom. You can check it. So I'm running it. So it has printed 5, right? So now what we understood from here is, if I write x of 2, I'm getting 5. If I write x of 1, it will be 3. If I write x of 0, it will be 1. So that's important. Python always start the index from 0. That's an important. Okay, so let me quickly go with some more questions. So column means 1 to 3, and 1 to 3 are index. So not numerical 2, English 2, TO2. So 1 to 3. So now what will this print, everyone? So it will print 356. According to me, it will print only 3 and 5. I'll tell you why. But first, let's print the output. You can see it's only printing 3 and 5. So always remember, Python will always exclude the last number from this. That's how the Python has been built. Okay, so it will always, this function colon has built in such a way that it always excludes the last number. So from 1 to 3, which is 1 comma 2 comma 3, it is excluding 3. So now it has only 1 and 2. So for 1, we know that for index 1, the value is 3. For index 2, the value is 5, right? So I want you to play around, guys. Please play around in Python. It's important. Okay, we cannot avoid Python because a lot of organization ask for Python. Okay, so let me quickly erase this now and let's do some complicated, I would not say complicated, some new code, but those are also very simple if you can understand it. Okay, let me write x equal to 0. If x is equal to 0, print Mercedes, else print BMW. So guys, quickly tell me what it will print now. If I run this code, what it will print? Mercedes, right? It's important. The important thing which we should know is for any conditional loops means if else. If you want to write some more else, then you have to write say else if, for example, if x equal to 1, print Porsche, or let's say Hyundai. Now, so the important thing which we have to understand here is every conditional statement ends with colon, right? And then what we want to specify within that condition loop will start with some space. It will start with after giving some space, and that space is called indentation. It's an interview question. What is indentation? Okay, and what is its importance? So if you remember from your college days, we used to give curly brackets. If you want to write any loop, conditional loop or for loop, we used to write between the flower brackets. So it used to create a lot of confusion. If you remember, we have so many loops, for example, then we have to open so many loops, right? Then we will get confused with this. Instead, by giving this indentation, it will be organized in a better way. We will understand this code in a better way. We will able to debug the code in a better way. Okay, so now tell me what it will print, guys, for this one. For x equal to 1, what it will print? Right. So see, the point is, if I write say x equal to 100, then BMW, right? Now, for example, if I write y equal to 100, then what it will print? Right, x is not defined. See guys, so it's important that every one of you know coding. It's just that we are scared of coding, right? So you don't have to be scared of coding. We know how to code. See, no one will ask the syntax, okay? No one will ask the syntax. Everyone will ask you the logic. So you know coding. It's just that we won't be able to recollect the syntax. You don't have to worry for that. We can always surf on internet for the syntax. See, I also cannot remember all the syntax. It's no one can remember that, right? Why is it not printing? How will it print? Because the condition is for x, right? So if condition is for x, right? So when the condition is based on x, it will check for only x for all the three conditional loops. It will not check for y. Got it? I think if you can see, the output is here in my machine. The reason, there could be several reasons that you're not able to see the output, because you might not have opened your terminal window on the bottom, which you have to do that. Or there could be that is done. Okay. Then you might not be in the right path. See where you are saving this file. That is important. If you are saving this test.py file in say location Naga, then you should go into the folder Naga. Here it should be Naga, and then you should run the code by Python, and then Python file name, which is test.py. Making sense? So to want to clarify this further more, let's do one thing. Now if you notice, you will get the output. Okay, now tell me what could be the output in this case. What could be the output, guys? See, I am writing here or, right? Or means this or this. This or this. So if x is equal to 1 or y is equal to 1, then it should print this. So it's or, it's not and, right? So it will print Hyundai in this case if I'm not wrong, right? The reason here we have mentioned or means any one of them should be true. Okay, so in this case, with this value, this one is true, right? This conditional loop is true, right? If both of them are true, then also the answer will be same. For example, this one. Now, you must be thinking, what if it's x equal to 1 and y equal to 0? Then this is a critical stage, because it follows both two conditional loops, but it is giving Mercedes 1, okay? Because the reason, it goes step by step, right? So first it takes x equal to 1 and then y equal to 0, and then it goes into if. In if, it will check whether x is equal to 0 or y is equal to 0, and it comes to know yes, y is equal to 0, then it will straight away print Mercedes. So this was critical, okay? So sometimes this will also be your interview question. Now if I write and, that is important. And means both the conditions should be true, okay? Both the conditions should be true. Now in this case, tell me what could be the answer. So it should be BMW, right? Because both should be true. But for if only one is true, the other one is false. So if both of them true, then only it will enter this if. Here also only one is true, so it will not enter into this. So it will go into else condition and then it will print BMW. Making sense? So far so good, guys. So we are able to understand the code. We are able to debug the code. It's just that how to write the code, right? So don't worry, the syntax are very simple. If you're not able to remember the syntax, go to the internet, check for the syntax. Simple, guys. So don't be scared of coding. It's very simple. And when it comes to machine learning or data science, the coding is further simpler. You're not going for a software developer job. You're going for a data scientist job which requires or mathematical coding only. So which is very simple. Start practicing. For example, let me now let's use for I. This is the syntax for loop. You remember for loop, everyone, from your college days? For I in range of 0, 100. Let me take simple one, 5. Okay, print x and then increase x by x plus 1. Okay, now tell me what will it print when I print this output. What will be the values of x which I'll be getting? Can you just take a guess, guys? See, first of all, I will take the value of 0. It will print x, then it will increment x by 1, which is now x equal to 2, and then I has taken already 0, so I will take 1 now. Then it will print x, which was 2, then it will increment x again, right? So it will print 1, 2, 3, 4, 5. Now it is important whether it will print 6 or not. So it will not print 6 because, as I told, in Python it will always exclude the last number. So it will exclude this 5. So how many times it will enter into the loop? I is equal to 0, I is equal to 1, I is equal to 2, I is equal to 3, I is equal to 4, right? So for I equal to 5, it will not go into the loop. Okay. So now if I run this, so it's printing only 1, 2, 3, 4, 5, right? Making sense? Now, see, it's important that for loop also we should maintain this indentation, this gap. Okay. Now tell me, what will this print? Will it print I? It will print 0, 1, 2, 3, 4. Yes, because I is taking the value from 0 to 5, excluding 5, right? Okay, now to clarify this, if I write inside quotes, then it will print I. Check this. Then it is printing I 5 times, right? Because here I is a character, it's a string. Okay, based on this I value, it is entering into this loop 5 times, and then it is printing I 5 times because it is into double quotes. So every time you want to mention any character or string in Python, it should be in double quotes. Whenever you are not mentioning in the double quotes, then it will assume it as a variable, or it will assume it as a number or some mathematical calculation. Okay, did I clear your question? Making sense? So it is printing I several times. For example, if I write say XYZ, if I write say X, it will not print the value of X here. It will print X 5 times. If I remove this double quotes, then it will print 1 for 5 times because it is entering into the loop 5 times because we are excluding this 5 here, right? Always remember this. This is the basics of Python. Okay, it will always exclude the last number. And all the conditional loop for loop will end with double colon. And after that, if you want to write anything inside that loop, then you should always give that indentation. Okay, great. Now, for example, do you remember from yesterday's class, what is this? I asterisk asterisk 2. What does this represent? I square. So what will be the value now? Tell me guys. It will be 214. You forgot 0. I is starting from 0, no? Right. So 0, 1, 4, 9, 16. So 0 is, this 0 is 0 square. This 1 is 1 square. This 4 is 2 square. This 9 is 3 square. 16 is 4 square. So this kind of coding is required. You don't have to worry much. And now if you want to combine this value with the string, for example, if I want to have a good structure here, then I should do something like this. Square values are equal to this. Okay. Now what will it print? It will give square value is equal to 0, square value equal to 1, square equal to this. Okay, making sense? Now for example, if you want to write this in a even better way, for example, square of this is this, square of this is this, square of this is this, right? Then the better way is square of, this is a string, right? Of what? I. So we should write, we have to separate that string with normal variable I. So the way we do that in Python is separate that with plus. First, let me tell you what is this plus doing for numerical numbers. For numbers, we know how does plus work, right? For string, how does it work? I'll just show you. Say square of cube of, okay? Now check this, what it is printing. Square of cube of, square of cube of, square of cube of. So what is this plus doing between the strings? This plus is concatenating the strings, right? So now you understood, right? If there is a string, then it will concatenate. If there are numbers, then it will add. Concatenation means adding, but characters cannot be added, so they can just join, right? So that is the reason we have something like this. So similarly, what I was telling, square of I, right? So I should write like this. Now I should not be in quotes because I should be the variable, right? Is I square. Now if you notice, this will give you better representation. Okay, so what it is saying, this cannot concatenate. So what it is saying that we cannot concatenate here the character, the string and the integer, right? So what we should do, so we have to convert this I into string. How do we do that? Just write string of I, but we are not putting quotation on I, right? So it will still be considered I as a variable. We are forcefully converting this as string so that it can concatenate, because only strings can be concatenated and integers can or numbers can be added up, right? The combination will not work. So I'm just converting everything into string. So now if you notice, square of 0 is 0, square of 1 is 1, square of 2 is 4, square of 3 is 9, square of 4 is 16, right? If you want to give space, then you can further give space here. You can give space here. You have to give space inside quotation because the space is also considered as a string, right? So now we have got a better representation, right? Making sense? Great. So now, guys, it's important that you should go back and keep working on coding. Do some simple coding. It's important that you keep on working on coding because see, you will start loving it. I'm pretty sure that you will start loving coding. I'm also coming from mechanical engineer. I have started loving coding. You will also start loving coding. Okay, so you don't have to worry anything about it. It's just that you have to practice, dedicate some time Okay, so now to do some fun projects now. Okay, now let's combine for and if loop. Okay, let's combine for and if loop. If I is divided by, so divided means if the remainder, say when I is divided by 2 and the remainder is say 0, the remainder is represented by percentile. Okay, then so you notice that there is one more indentation because this print is inside if and this if is inside for loop. Okay, print I is an even number, else print I is odd number. So now first I will take 0, right? I will take start with 0 and then it will continue till 4, right? So let's see what it happens. So if you notice, it is giving, okay, so I think it's the remainder thing. If I could recollect properly, okay, it's not I here, okay, I've written 1, okay, let me correct that. Okay, now if you notice, because 0 is divided by 2, right, the remainder will be 0, that's the reason 0 is an even number, and then comes 1 which is odd number, then comes 2 which is even number, then comes 3 which is odd number, then comes 4 which is even number. So if you want to write it in a further better way, then what you should do, you should write I, and then you should first write string of I and then plus, because you have to concatenate this, right? So now if you notice, it is saying 0 is an even number, 1 is an odd number, 2 is an even number, 3 is an odd number, 4 is an even number. So it's so simple. It's just that you have to combine all the basics knowledge what we have learned. Try to do some simple coding here at your home. Try to look at some simple codes in Python, very simple, very basic codes on internet. Try to write on your own. Try to see if you're getting some error. If you're getting error, try to understand that error. Try to debug your code and then try to correct your code. Okay. So this is very important, right? Because coding is very important. Okay. So we don't need to close loops in like scene. Yeah, that's what I said. No, that's the beauty of Python. You don't have to close because the indentation itself tells that this is in for loop. This indentation tells that it is in for loop. This indentation tells that it is in for loop. This indentation tells it is in for loop. This indentation plus this indentation tells that this is in inside if loop and if is inside for loop. Okay. So the structure wise, if you look the code, it will look better structured when you compare to other coding language. No, it is more structured way. Okay. How to define a sample size? Okay. So there are different formulas. Naga, it's very important that you have asked this question, how to define a sample size, right? So for example, there are different ways by which you can define the sample. Okay, there are different ways by which you can define the samples. But to give you very one simple formula, we have say 1000 in the population, we have say 1000 data. Okay, now for example, for one particular component, you are putting the sensor probe points in 1000 different locations. And if you want to read that out of those 1000, if you want to read only say some of them, because you won't be having time, right, to read all the 1000 probe points, what it is measuring. So in that case, we will use sample size, right? So there are different ways again. The first way is how much error we can expect in our inferential statistics. That means once you take the sample, so just imagine in this simple way, very simple way. If I have 1000 population and if I take all the 1000 data for reading my calculation, then the error would be almost negligible to zero, almost negligible, right? It will be almost zero, right? Then if I make the sample size to be say 500, then I might get some accuracy for that model. The error would be like, let's say the error might be say 2%. Let's say that the error is 2%. when you are doing the inferential statistic, once you got the result from the sample of 500, you are inferring something about the population, and the error what you got is say 2%. Now, when you take 100 samples, the error will increase or decrease? Increase, right? So it's everything. That's what I'm saying. This complete course, machine learning and AI, it's pretty simple. It's based on only math, coding, and common sense. So it depends what is the error which is acceptable. So in general, there are different formulas, but anyways, I'll just write down one of the basic formulas, one of the simple formulas for sample size. So 1 by error square. Okay. So for example, if the error is say 10%, that means 0.1, right? So 1 by 0.1 whole square will be how much? 100, right? So with 10% of error, you need 100 samples. Now let's say you are working in a domain where you cannot accept 10% of error. Let's say if you want to have only 5% of error. So with 5%, what will be the value for 1 by 0.05 whole square? Will it be 250? 1 by 0.05 whole square. How much will it be? Will it be 2500? No, Raga, it will be, it's pretty straightforward, no? It's 400, right? Can you please check it? Let us calculate. Why is it so difficult? With 5%, say this is 5 by 100 whole square. So this will be 100 square by 5 square, which will be 10,000 by 25, which will be 400, no? Right? Making sense? So that's simple, no? So now you got the point, right? It's up to you what error you can accept in your analysis. And that will be given by your client. So you don't have to worry, that will be given by your client. And based on that, you have to extract the sample. Okay, great. So now let's check this. Yesterday we have read about discrete random variable and continuous random variable, right? Now there are two types of distribution also. Discrete probability distribution and continuous probability distribution. Again, in this case, we will be doing a lot of interaction. Okay, so let me put this chat box here because we'll be doing a lot of interaction again. Okay, so that I can see what you are typing. Okay, so now discrete probability distribution and continuous probability distribution. For example, rolling, say tossing a coin, right? Will it be the distribution what we will get tossing a single coin? Will it be a discrete probability distribution or continuous? Discrete, right? It's simple, no? Because either we can get heads or tails. So if I want to write probability distribution for heads and tails, probability is say 1 by 2, 1 by 2 for both of them, right? So this is called as discrete probability distribution, and moreover it is called as uniform probability distribution. Why? Because the probability is same for both head and tails, right? Making sense? So in discrete you have uniform discrete probability distribution. Similarly, you will have Bernoulli and binomial discrete probability distribution, which I want you guys to read about it. Okay, now going to the continuous distribution, which I want to explain because this is quite complicated, which I want to explain. Okay, continuous probability distribution or continuous distribution is divided into two, which is uniform distribution and normal distribution. Okay, making sense? So for uniform means for every random variable, for every continuous random variable, you will have some probability associated with it, right? And for all it will be same. Okay, so it's pretty clear from this graph, the frequency for the different random variables has to be same, then it is called as uniform continuous probability distribution, right? Now what is normal distribution? This is very important, guys. What all we'll be dealing in our coming sessions will be based on normal distribution. So this is important. Remember this, normal distribution. So I hope you all guys work in different organizations, or maybe you might be knowing about appraisals, right? Yeah. Do you know about appraisals? You all know about appraisals in the companies, different companies, right? How does that appraisal work? So For example, say this is, let me draw it once again. Say this is your normal distribution. Okay. Now this is your frequency or number of times it is appearing, and this is your random variable, right? Now appraisal will range, say for example, in appraisal in a particular company, say appraisal is ranging from say 5 to 20% of hike every year. Now what does this hike, this peak means? That means there is a very high frequency for this particular x values, right? That means in this range, if you notice, there will be, what will be the x value in this range? Say 10 to 15, 10 to 15%. So if you notice, there is high frequency for the people, or that means there are high number of people who are getting a hike between 10% to 15%, right? Because here there will be very less frequency. That means there will be very less people with 20% hike. There will be very less people with 5% hike also. Why? What can be the reason? If company gives high frequency for 20, if there are high number of people with 20% increment, then company would be in trouble, right? They have to always follow the normal distribution. That would be the relative, right? So they have to give the relative appraisal based on the performance. They will give this appraisal, right? They cannot give every member 20% hike. They cannot give every person 5% hike. And even they cannot give most of the people 20% hike and most of the people to with 5% of hike. It's simple. It's a simple tendency, right? So most of the people will get an average hike. And that's the reason in this average hike, there are most of the people falling in this, right? In this region, most of the people are falling. Clear? Making sense? So similarly, if you want to see, let's assume this is the temperature values. Say this is 0 degree for one particular component, or let's say I have different components of a vehicle. Say I have say some car, and there are different components in these cars, right? We all know what all different components we can have: fuel tank, engine, radiator, fan, everything, right? So, and vehicle is driving, the chassis, BIW, right? So let's assume this is the temperature values. Our random variables or the possible values are say temperature values. These are the temperature values on x-axis, and on the y-axis it's frequency. So it's pretty clear that lower temperature, say this is starting from 0 degrees say till 200 degrees. Okay, so if I have a car with most of the components with 0 degree, then you can understand what will happen with the car, right? And if I have a car with most of the components at 200 degrees, like the engine does have somewhere around 130 or 110, so you can understand what will happen to the car, right? So it's important that it will be in somewhere in the ambient temperature. You all understand ambient temperature? Ambient temperature is the air temperature, right? Outside air temperature, right? So most of the components in the vehicle would be near to the ambient temperature. So that's the reason in this average temperature, which would be the ambient temperature, near to the ambient temperature, there will be a lot of components which are falling, and that's the reason we have high frequency here. So that's the simple logic about normal distribution, and that's the reason you are seeing the mean value here. This is important, guys. Did you understand normal distribution? Can everyone please write yes or no at least? Because normal distribution is the basis of machine learning. Or we have to always check the data whether it is normal or not. Okay, so this is the first step. Whenever you get the data set, you should always check whether the data is normal or not. Let's take a simple example. Okay, so what was this? This was the example of temperature, right? And there will be a lot of components which will be having the ambient temperature, right? Similarly, I can have the normal distribution curve for pressure also, or the vehicle speed also, right? I have, for example, I have a different vehicle speeds. Then most of the time vehicle cannot be at 0, right? While running, vehicle has to move with some average speed, right? So most of the occurrences will be at average speed. Similarly, pressure, right? So what do you think? Velocity and pressure will also follow this normal distribution, right? Yes or no? Now, the challenge here is, if you want to compare these two, for example, I have one more curve here. Assume that I have one more curve, okay? Say What would be the ambient temperature, guys? 1 atmospheric pressure, right? And what would be the ambient temperature? 35 degrees. So if I have two curves, one for temperature, the average temperature is 35 degrees, and the other one is say pressure curve, where the ambient temperature is say 1 atmospheric pressure. So don't you think it will be difficult to compare these two curves because the scales are different? Yes or no? Because we all know if I want to write 1 atmospheric pressure in SI units, you have to write that in Pascal, right? And then pressure will become what is how much 1 atmospheric is equal to how many pascals? So you got it right, right? So you are writing in some other units, Harsha, I believe, but yes. So somewhere near to average, the value would be 10 power 5, right? So exact value would be the one which is mentioned by Georgi, right? But that's not the issue. Let's take 10 power 5. So don't you think the scales are different? The scales are different, right? So to bring those two different scales into one common scale, we convert all the normal distribution curves into standard normal distribution. So for example, say I have pressure curve, I have temperature curve, I have say velocity curve. Here, if I want to do normal distribution with average would be somewhere around 10 power 5 pascals. For temperature, it would be 35 degrees. For velocity, it would be like say 45 kmph. Now, if you notice, the scale is different for all the three normal distribution and the units are also different, right? But the most important thing is scale is different, right? So how would you compare? How would you bring? And if I want to bring all these three curves, say this curve, and this curve, and this curve, if I want to bring all these three curves into one curve, will it be possible for me? No, right? It will not be possible, right? So what's important here is to bring all those five which I was talking about. So I'm just showing it here. I have so many normal distributions with different colors and I want to bring them. See the importance of this. I want to bring all those different distributions to one common scale. So for that, what I do you remember what is mu? Mu is mean. X is observation. Sigma is standard deviation, right? Making sense? So what I will do for every corresponding X value, for example, for temperature values, average temperature divided by standard deviation of temperature. I'll convert all the temperatures with Z values of temperature with this formula. I'm converting my temperature column. Say, for example, I have a data set in which I have velocity, pressure, and temperature. And I know that all the three has a different scale. To bring them to a normal scale, for temperature, the scale would be different, right? For pressure, the scale would be different. For velocity, the scale would be different. So now, to compare these features, it would be really difficult. And when you do machine learning analysis, your machine learning will be dependent on your values. So for pressure, the values are very high, right? So that will influence your machine learning algorithm. And we don't want to do that. So for that reason, we convert all the different columns into one single parameter or common scale to one particular common scale, which is called as Z scores. I will generally call Z scores as Z scores. Okay. So this Z score is for temperature, it will be X of temperatures minus the average of that temperatures. I have the value of different temperatures and then I have the average of the temperature. I have the standard deviation of the temperature. You know, I have already explained how to calculate standard deviation, right? So once the mean and the standard deviation would be constant for temperature column. For the different values of temperature, you will get the different Z value, right? Yes or no? Right. Similarly, we do the same thing for pressure. See, for example, if the temperature values are ranging from say 0 to, say for example, from 0 to 200 degrees centigrade, and the average is say ambient temperature, the average is also ranging in the same scale. So what we are trying to do here is, let's do one simple exercise, guys. If I explain you might not be able to understand. Let's do one simple exercise. Open your Excel sheet, guys. Calculate. Let's open your Excel sheet. Let's assume you have some X value, which are say 1, 2, 3, 4. Sorry, let me write 1, 2, 3, 4, 5. And say Y value as 100, 150, 175, 200, 225. Okay. Please everyone open your Excel sheet now. Instead of temperature, pressure and velocity, I'm taking some random features or random columns here, which are X and Y here. Okay. What is the mean for this column? Can you please tell me, guys? 3, right? What is the standard deviation? So please calculate the standard deviation. How do you calculate standard deviation? There are inbuilt functions in Excel, or you can directly apply that formula which we have learned, right? X minus mu whole square divided by n under root, right? Square root of x minus mu whole square divided by n, right? So you can directly apply that formula here, but I'm directly using that function here. Okay, so let's use that function, or let's calculate, because so that you can also practice. Everyone can practice that now. So let's first calculate x minus mu, which is mean, right? What will be the value of this? X minus mu. What will be the value of this? Minus 2, minus 1, 0, 1, 2. And then x minus mean whole square, right? What will be the value of this? Minus 2 whole square. See, we don't have to do that. You have to just write this square and then drag it. So these are the square values, right? Now what is the summation of this column? Sigma, right? Summation. Summation is equal to, what is the summation of this? 10, right? So now we have calculated the summation. We have to divide that by number of observations, which is n for population, right? For the population formula, we have n, right? So in this case, 10 by 5, which is 2, right? 10 by number of observation, which is 5, which is 2. Okay, I don't know why is it taking like this, but we know that it is 2. Okay, it's still taking date. It's because it's in the date format, I believe. I have to change that format. Okay. So let me, so 2, okay. Now, standard deviation is, this is the variance, right? This is variance. So what will be standard deviation? Square root of 2, which is 1.414, right? So now we have mean, we have standard deviation also, right? Can you have, so can you guys please calculate the mean and standard deviation for this y? Can you please quickly do it, guys? Okay, so mean is 43.1, standard deviation is 43.1, mean is 170. Okay, that was, I was wondering, how can mean be lesser than the minimum number? So mean is 170, standard deviation is 43.01. Similarly here, the mean is 3 and the standard deviation is 1.414. Okay, so now let me erase all this. Now let's calculate the z value. Z value for x. Okay, now you would notice something really interesting, guys. Okay, now what is the formula for z? X minus mu by, so x minus mu, and this mu is constant, right? So I have to put $sign here. Let me just increase the font size. Why is it not increasing? I'm sorry, I'm not sure why is it not increasing, but you got the logic, right? So x minus mu divided by sigma, and the sigma is again constant value, which is this one. Okay, Now if I drag it, I'll get the z values for everything, right? Okay. Is everyone able to understand this? Z values for x minus mu by sigma, right? Similarly, let's do it for y. Z values for y. Can you guys please do it for y also, everyone, on your laptops? Did you get the z values for x and y both? Please reply by yes or no at least. Everyone, please complete this quickly. Everyone, did everyone complete this? Please reply yes or no, guys. Okay. So now see the importance. Now we will come to know the importance, the significance of this, of z-score. As I always tell, don't go with the formula, go with the significance of each parameter. Now calculate this, call for this z values for x, calculate the mean. You will see something interesting. Can you do that, guys? 0, right? That's the importance. Calculate the mean for z values for y. 0, right? So did you understand the beauty? Calculate the sigma, calculate the standard deviation for this quickly, for both z values of x, z values for y. Quickly do that. Calculate standard deviation for these new two columns. The way we have calculated standard deviation for normal x and y, let's do that for z of x and z of y. You will notice something really interesting. Did you calculate standard deviation, guys? Yes, exactly. It will be 1. So for both of them. So what did you understand? For two different scales x and y whose mean were so different, whose standard deviation was so different, we have brought down those two different parameters to a same scale such that their mean is 0 and the standard deviation is 1. So now if you notice this, all the different graphs can be incorporated in one single graph. So the graph which we had earlier with different scales, now we will have something like this. Now you will have something like this. Okay. Okay, there is some problem with this. Just give me a minute. Let me draw it here. Yes. So you will have now all the graphs with same mean. I'm not very good in drawing, but you got the logic, right? You will have all the different normal distributions with same mean and standard deviation now. Did you understand, guys? Yes, it will be 1 and 1. Yes, for both the x and y. Did you understand the significance now of z-score, right? So this is important, guys, so that trying to bring different scales into one normal scale is called standard normal distribution. And now this is important again. If I tell you, if I have a x value of, say, this, on the x-axis we have random variable, right? On the y-axis we have frequency, right? So if you look into this again, that appraisal example or the temperature example or pressure example, the temperature of the 68% of the components will be near to the ambient temperature from, and this is called as one standard deviation. So you know the standard deviation value is 1, right? So mean is 0, which is here. This will be -1, this will be +1. 0, +1, +2, +3, 0, -1, -2 and -3. Okay, so there will be 68% of the components will be lying between -1 and 1. There will be 95% of the components which will be lying from -2 sigma to +2 sigma. There will be 99.7% of the data will be lying between -3 sigma and +3 sigma. Does it make sense, guys? Did you understand this? Because highly frequent components or the temperature which are near to average temperature will be more frequently occurring, right? So that will be lying here, right? So that's the logic, guys. That's the importance. That's the essence of this normal distribution. So if you all might have heard this 6 sigma of very late, right? 6 sigma, people are talking about 6 sigma quality. What do they mean by 6 sigma? That means if we predict or if we do something, the quality of the analysis what we do or anything what we do, that should be with 6 sigma. So if you can understand now, with 3 sigma we have 99.7% of the data lying within 3 sigma about the mean. So for 6 sigma, you can imagine what will be the value. It will be 99.99999 something. So you must have heard in your organization follows 6 sigma quality. And this is what they mean by 6 sigma in real life. Yes, so why particularly these values? So always we can calculate these values. If you want to do that, you can do that on Python, R or Excel, it's up to you. But if you notice, first of all, understand this. What is this normal distribution? No, it's not about a common given values. Yes, it is a common given values, but they have derived these values. How? Let's understand that also. How did they derive? Because I don't want you to just mug up the values, right? As I always tell. This is your normal distribution. In this normal distribution, all your data will be lying, right? So if I ask the probability value, the sum of the probability values will be 1. Yes or no? Because the sum of all the probability should be equal to 1. Yes. So if I give any data, the probability of that data lying between plus or minus 1 sigma would be 68%. Now, how did we come to this value 68%, right? That is your question, right? So tell me, if this is the this normal distribution is 1, the probability for this curve is 1, area under this curve is 1, which is denoted as the probability. If I divide that at the mean, then 0.5 probability will be on the right side, 0.5 probability will be on the left side. 50% of the data will be lying on the left side, 50% of the data will be lying on the right side, right? So if I want to check what is the area under this curve, you know how to calculate the area under this curve? The 68% is denoting the area under this curve. So if you do the calculation, you have to calculate the probability. Okay, you have to calculate the probability. And how to do that? What will be the value of z? You can use integration, yes, but I don't want to get into that. You are rightly said. You can use integration, but I don't want to get into that because that would be a very complicated mathematical topic. Let's understand in a simple English, and then we will see. You guys can do that in replicate that in coding. Tell me what is the z value here at my cursor? 0. What will be the z value at this point? At this point, similarly on the left side, right? Now what we have to do is, there is something called as z tables in the internet. You can use that, and that z table tells you how much area is covered between 0 to +1 and -1 to 0. See, here it is very simple because we know these values, or these are the very standard values which we have derived. But for example, if we want to find the area between this curve, then it will be difficult, right? So for that we need table. So you can use z table, you can type it on internet and check for that, or you can use Python, or you can use R or Excel to calculate this probabilities value. See, you can do that, but I want to show it practically. So what I will do, I'll just use internet in this case. Okay, is everyone able to see this table? Okay, now for example, for the value of z, say 1. For z equal to 1, what is the probability that we have to check? So this is for negative values, these are the positive values. Look at my cursor, guys. Z equal to 1. I told 1, right? Did I say 1.05 or 1.01? No, I told 1. Z equal to 1 with 0, right? So what is the value? Can everyone please write 0.84134 on the chat box? Okay. Now, what is this value 0.84134? Let's go back to the presentation. So where is z equal to 1? Here. So this, it's all the left side, all the area which is covered from here, from left side till z equal to 1 will be 84% of the area will be covered on that. Okay. From left side till z equal to 1, the area covered is 84%, right? 0.84134 means 84.134%, right? We have to calculate between -1 and 1, right? Yes or no? So let's go calculate for -1 now. For z equal to -1, the value is 0.15866, right? Now, see what this value denotes for -1. Area covered from left side till z equal to -1. What is z equal to 1 value indicates? Area from left side till z equal to 1. And what do we need to calculate? Area between -1 and 1, right? We want to calculate area between -1 and 1. So See what we have done, we have calculated till -1, which is this 0.15. We have also calculated till 1, which is 0.84. Now we want to calculate this, right? The intermediate part. So what should we do? We should subtract these two values, right? Yes or no? Yes. So you got the value. So now you understood how did we get this answer? You will get near to 68%. Yes. So now you got the logic, right? It's the significance of z-score is you have this data available to calculate the probability based on z value, because we are converting different normal distributions into standard normal distribution, by which we are calculating the probability. Let's start with this. These are the 4 business movements. Okay, guys. First one is pretty simple. Measure of central tendency, which we have learned, which is mean, right? Second business movement we have already learned, which is measure of dispersion, which is variance. Third business movement is skewness. Okay, so if you notice, we can have the normal distribution slightly skewed like this or slightly skewed like this, right? We can also have this kind of curves, right? So this is where we call that the data is slightly skewed, and this has its own importance, guys. Okay, for example, by this we are telling that if we have, for example, if we have data of the temperature say 0 to 200, and most of the temperature values are lying near to 35-40 degrees, and then remaining are here also, right? So the temperature is not lying exactly at 100. The average temperature is not exactly 100, right? It's near to 35, and most of the data is falling near to 35, right? So that's the reason the graph is something like this. Similarly, you can come up with an example for what data such cases we will have this kind of examples. For example, the vehicle speed is say 0 kmph to 60 kmph, and most of the times we'll be driving the vehicle with 40 kmph, right? And above 40 it will be very rare, right? Because nowadays in India we have a lot of traffic, so most of the people will be driving with 40 or less than 40. So this is how the data looks like, right? So this is called as skewness, and this is how you have to analyze your data. Okay, did you all understand skewness? Similarly, we have fourth business movement, which is kurtosis. So this is also very simple, guys. For kurtosis, if you notice, you have a very symmetric normal distribution. Ideally it will not be a case, but let's assume this. You have two normal distribution curves like this and like this. If you notice, the peak thickness is more. That means most of the people, there are so many people which are falling under average, exactly near to average, exactly near to average. In this case, there are few people which are near to the average. Making sense? So now the task for you guys is, see, I told you an example for skewness. You have to come up with an example for kurtosis and tell me what would be the significance of this kurtosis in the analysis. Okay, before going ahead, I want to go back to the second business movement. In second business movement, we have learned variance and standard deviation, right? Similarly, for first business movement, there are other two parameters which you have learned in your school days: mean, median, and mode, right? Which is a measure of central tendency. We have all learned this: mean, median, and mode. What is mean? Average. What is median? Central value. What is mode? Most frequently occurred value in a series, right? Yes or no, guys? Now tell me, when we already have something called as mean, which is giving the average value, why there is something called as median in the world? See, I told you, no, I will make sure that you understand the significance of the parameters, not the formulas. When there is already mean exist in the world, then why do we have median as a separate central tendency measure? What do you mean by for accuracy? Just imagine guys, right? So just imagine, in this case, I give you the data series, say 1 2 3 4 5. What is the mean and what is the median? Tell me, guys. I have given you the data set of 1 2 3 4 5. What is the mean and what is the median? 3 and 3, right? How do we calculate the median? Put the series in increasing or decreasing order, and then the central value would be the median, right? So now do one thing. The series is 1, 2, 3, 4, 100. 1, 2, 3, 4, 100. Now please calculate mean and median. Median is 3, yes, mean, right? So now just understand in this way. I want to do, for example, MBA. Let's take, I want to do MTech. Let's assume that I have already completed MTech, but let's assume that I wanted to do MTech from IITs. Now, in different IITs, they tell that the average package what their students are getting after completing the MTech from their college, let's assume that, only assume, okay? The average package is 22 lakhs per annum, okay? Then what does that mean? The average package is influenced by this value 100, right? But median is not influenced by 3. See, there could be a chance for different university, the mean might be 10 and the median might also be 10 or 11, right? Making sense? So what I'm trying to tell here is you cannot always look at the average value or mean value, right? See, by just looking at the mean value, I think, say if I have two universities, University A and University B. In University A, I have the average package 22 and the median package is 3 lakhs per annum. For University B, the average package is 10 lakhs per annum and the median package is also 10 lakhs per annum. Then which university you will choose now? Tell me. University A or B for your admission? B, right? You cannot choose A because see, in University A is influenced by one of the student who has got very high package. So it's not necessary that we will also get the same package, right? Making sense? So only one of the instances is there with very high package which is influencing your mean. But median is not influenced by these high values. B, this 100 is called as outlier. That means it is out of the range of the data set. It's not following the normal trend of the data set. That means if you notice, all the university tells that this is our average package, please join our college, this is our average package, we are getting this placement of so 20 lakhs, 10 lakhs, please join this package. But have we ever noticed what is the median of that? We never notice the median because mean is always influenced by outlier. And this is your interview question, guys. Mean is always influenced by outlier. Okay, did everyone understand this? Okay, so before going into the next slide, we can take up that next slide in the next session. But before that, I want to show you, this is what you have to work as a challenge. Okay, there are 5 questions you have to work on these challenges. In this average, okay, Naga, you have a question. In this example, even median doesn't guarantee the proper inference. Yes, see, the point is inference will tell you, median will at least tell you that don't take your decision only by looking at the mean. See, what happens if you, by looking at the mean, you might join the university A, right? And then you end up asking, like, once you do the lot of analysis, you will come to know that that mean is influenced by that very high package, right? That's the beauty of this. Mean and median both will help you. See, even alone median can't help you. So both mean and median is helping you how to analyze what decision you should make, right? That's the whole point. So that's the reason I always tell, just don't look at the average values. You should look for average and median both, because averages are influenced by outliers. Okay, so this is a challenge. So you have to work on these 5 questions, guys. Okay, please start working on it. See, here we are not doing simple maths. We are trying to understand the logic behind the math. We are trying to understand the significance, the mathematical intuition, so that this all can be applied from next session when we start with machine learning algorithms, for which we have huge demand in outside market, right? It's not just that for Platicotic Naga, you can have like 3 also, 4 also. You don't have to worry with 2 different variables. Okay, it's not about 2 different variables. You will have the same. First of all, it's not about 2 different variables. You will have the single variable which will be taking different values, right? For example, you have the temperature here on the x-axis. Here you have 0 degree, 10 degree, 20 degree, 30 degree, 40 degree, 50 degree, 60 degree, so on up to 200 degrees, right? Right, different data value. So it's not about 2. It's just an example. Don't worry. So it's just, it says that most of the value will lie most of the values lie near to this average value at the center. In platycotic, in leptocotic, values will lie near to average, but not in comparison to platycotic, it will be lesser. So you have to come up with an example for this kurtosis. How will this kurtosis be helpful in our analysis? So next section we'll start with machine learning and AI. Okay guys, so I'll take a leave if you don't have any questions. Thank you everyone. Hello everyone. So I'm excited to go into machine learning. Till now we were into statistics. So guys, I hope you are working on the assignments. I hope I have gone through all the 4 different business movements. Let me maximize this. So we had 4 different business movement in the previous session, if you remember guys. the central tendency. In central tendency, we had mean, median, and mode. And then measure of dispersion, where we had variance and standard deviation. And in measure of dispersion, some people also measure range. So what does range mean? Well, range is very simple. What is range? As per English dictionary, also range is from one point to other. In statistics also range is maximum minus minimum. Simple. So that is your range, which also comes under second business movement, which is measure of dispersion. And then third one is measure of skewness, right, which we have already discussed. The fourth one is measure of kurtosis. So if you notice, in the first business movement, we didn't have any squares or cube. If you look at the formula, if you have gone through the previous session and then if you have gone through internet and then you have done your homework, then I believe that you must be knowing now that mean is just a power of 1, sigma x by n, right? Median, there is no power, there is no square, cube or anything. But in second business movement, the power is 2. In third business movement, the power is 3. In the fourth business movement, the power is 4. So, if you notice, these 4 business movement, I would say, are the pillars for descriptive analytics. Okay, so I've been telling this word descriptive analytics again and again. What does this descriptive analytics mean? See, whenever you get a project, now it's very important because we are going into next step, which is machine learning algorithms. So it's very important that we should understand whenever we get a new project, there are 4 different analytics which we always look for. Okay, this is very important. The first one is descriptive analytics. The second one is diagnostic analytics. The fourth one is predictive analytics. Sorry, the first one is descriptive, second one is diagnostic, third one is predictive, and fourth one is prescriptive. Okay, so these are the 4 pillars, I would say. Whenever you get a project, you should always think on these lines. So what happens in descriptive analytics is you have to do a lot of analysis by looking at the data. Like for example, whenever you get a new data, you have to understand the data. You have to do some cleaning of the data. You have to do some statistical analysis on the data. Simple statistical analysis or exploratory data analysis, such as mean, median, variance, skewness, drawing the different plots, histogram, bar chart. We all know what is histogram, bar chart, right? So all these different graph and different analysis, what I'm talking now comes under descriptive analytics. So what we are doing by looking at the data itself, we are trying to analyze the data. We are not doing any machine learning now on this first step. This is only descriptive analytics. Okay. So once we have the data, we are just trying to play around with the data, trying to understand the data, what's there in the data. Can we come up with some insights by looking at this data, by drawing some graphs or some statistical measures such as mean, variance. We're just trying to draw some inferences by just looking at the data. So this will be helpful when we predict in the later stage. When we go into predictive analytics, I'll tell you how this will be helpful. Okay. Now the second step is diagnostic analytics. Okay, what is diagnostic analytics? Diagnostic analytics is why we are looking at this data in first place, why we are working on this project, why there is something, what exactly for which we are solving for, what is the problem in this data, okay, why we are trying to solve this. Okay, so all these questions should appear when we are working into diagnostic analytics. Diagnostic analytics is most of verbal and thinking, so it doesn't require any coding. Descriptive analytics require coding, but diagnostic analytics is just that, trying to understand the problem. The third one is predictive analytics. Predictive analytics is where we will be going into machine learning, predictive analytics. But then what is predictive analytics? As the name suggests, we are predicting something. Okay, so if you remember, in first step we have done descriptive analytics. We have played around with the data. When we play around with the data, that point also we can predict to some extent, but with less accuracy. But we know that we can predict by just looking at the data. For example, for the bigger data sets, it's not possible to predict just by looking at the data. So you have to play around with the data. You have to do a lot of exploratory data analysis, which is also called as abbreviated as EDA. EDA in the sense this all four business movements calculation, which we have to do in descriptive analytics. That will help us in predicting. Okay, so see, doing the predictive analytics is only like 2 or 3 lines of code. But before that, we have to do descriptive analytics, because what we are predicting in the predictive analytics, does it make sense to us? We should be able to judge that, right? And to judge that, we should be in a situation that we are playing around with the data. And that is what we do in descriptive analytics. So now in third step, we are predicting something which we will be verifying with the accuracy, and then we'll be verifying that with our inferences, what we have inferred from descriptive analytics. And then fourth one is prescriptive analytics. So in prescriptive analytics, we do lot. So we have already completed predictive analytics. We have come up with the predictions. Now in prescriptive analytics, we will give insights or recommendations to our clients that this could be better or this could not be better in your business. So these are the 4 steps. Okay. So for example, if you are looking for machine failure, if you are looking for a problem which is of machine failure, so when we do descriptive analytics, then we can look into different parameters such as the machine which is quite older than 10 years, then those machines are failing. By looking at our historical data, we understood that the machines which are 10 years old are failing. This is just an example. In the second step, diagnostic analytics. So in the first step, how did we come to know whether if the machines are 10 years old, then only it is failing? By working on a lot of descriptive analytics, playing around with the data. In the second step, diagnostic analytics, you're diagnosing. As a doctor says, we have to diagnose you, right? Similarly, why is this problem? There are some functions in the machines with the age are stopped working. That could be the reason that machine is not working. Okay, so this is like simple. The doctor diagnoses, right? We are engineers. We have to diagnose the machines, right? We have to understand the machine. In third step, which is where machine learning comes in, predictive analytics. We have to predict now. Whenever there is a new machine which comes in, so I have taken only one factor. Machine is more than 10 years old. That could be the reason it is failing. It could be a reason that machine is only 2 years old, but it is still failing because the manufacturer of that machine is not good. There are several reasons, right? And those several reasons will be handy, or all the theory which you have come up with in your descriptive analytics can be validated in your third step, which is predictive analytics. So whenever there is a new machine, you can always tell that whether this machine will fail or pass. Okay, by looking at the different parameters such as how old is the machine, who is the manufacturer of this machine, what is this machine meant for. So for example, different machines last for different time, right? For example, mobiles nowadays, mobile last for 2 or 3 years. Mobile is also a machine, right? And the cars might last for around 7 to 8 years. So depending on the different category, different machines will last for different time, right? So this is where machine learning comes in. It tells whether this machine will fail or pass. Simple. Okay. For example, whether the equipment can able to handle this thermal load or not, whether the engine can go up to this temperature, yes, like can sustain this temperature or not. So such kind of example. But then the point is, what we are doing here, the first step and the third step are interrelated. Okay, if you don't do the first step and just directly jump into third step, you will not be able to understand the business problem. Okay, and then if you're not able to understand the business problem, you cannot recommend or you cannot come up with the insights which you need to provide to your customer or to your client. In turn, you won't able to make the profit. Simple, right? So first step is important so that you can understand the data and the business problem. And then you have to go to second, third, and fourth step. I hope this makes sense to you guys. Okay. So now, what in this first problem, calculate all 4 business movements using pen and paper for below dataset. So this was important because the dataset was very small. I didn't ask you to calculate it over Excel or Python. Okay. I wanted you to solve it on pen and paper because so that you get used with the data. So did you all calculate all the 4 business movement? Oh, sorry, before going into 4 business movement, did you calculate mean for this?
Probability of X with the value of X.
Right. It's important. If you remember, I told the difference between mean and expected value, right? Both are one and the same, but there is a slight difference. So could you please tell me why didn't you use sigma x by n? And why did you use this formula, expected value formula?
Because earlier probability of, for example, in the case of tossing a coin, probability of head is equals to probability of tail.
Right.
So there is no need of like each event is having same probability.
Right.
Then you need not consider the p of x. But here 0 is having one probability, 1 is having other probability. Then so you should take weighted average of these values and their corresponding probabilities.
Right, that's the whole point. See, now you're understanding the significance. Rather than just solving the problem with respect to the formula, you're trying to understand it, its essence. That's more important for me. Exactly, you are right. So when there is a uniform probability distribution, what is uniform probability? That means when the probability is same for all the different random variables or for all the events, then you can directly use simple mean. Otherwise, you have to go ahead and choose for expected value, which is x into probability of the corresponding x value. So, what is the value? What is the mean which you got it? Naga?
1.4.
Okay, great. So, what does this expected value 1.4 means now? That means, see, 1.4 is between 1 and 2, right? And more towards 1 because it is 1.4. That means the probability of getting 0 and 1s, the probability of getting 0 and 1 is more than 2, 3 and 4 because the expected value is somewhere near to 1 and 2 but more near towards 1, right? And if you also notice the data, that also tells the same thing, that probability for 0 and 1 is more. So this is the whole point, that this is how you should validate your analysis. Now, did you all calculate whether the probability of sum of the probability was equal to 1 or not? Sum of the probability should be equal to 1, right? Then only it makes sense because these are the mutually exhaustive data, right? So the sum of the probability should be equal to 1, right? For the same event, we are trying to calculate the probabilities, right? Now, if I write 5 here, just imagine I'm writing 5 here. Below 4, I'm writing 5. Then what would be the probability? Well, for the same data set, 0, right? Exactly. The probability will be 0 because the sum of the probability should be equal to 1. Second question, what is the significance of expected value when simple mean, which is already in place? I think Naga has already explained that, and I have also enlightened you guys on this, right? I've just described a few pointers on this. Third one, having skewness in the curve considered to be a bad in the analysis? Do you consider having skewness in the curve, is it bad or good? Or just guess, no? Just think and just write the answer whether it is good or bad. If you didn't work on it, just think and tell me, like, just type it, no? Whether it is good or bad. Okay. In statistics, when you calculate something, you have to be very conscious when we are making a point. Okay. So in this case, having a skewness in the data is neither bad nor good. Okay. See, we always assume because we are habituated to look at the graphs which are quite beautiful. For example, in this case, when we have the symmetric graph, people say that having a symmetric curve is good and having non-symmetric curve is bad. So exactly, it's neither. It's a measure of distribution. So you should never consider a distribution whether it is good or bad. It depends on the analysis, what analysis you are working on. See, for example, for some analysis, having a skewness might be good. Okay. For some analysis, having the skewness might not be good. So it's just a measure of distribution. So for example, in this case, let's assume that selling number of cars having this distribution. For example, number of cars which are sold 1, 2, 3, 4, 5, 6, 7 and so on. So if the number of cars are getting sold which are very high at 5 and 6, which makes sense, right? There are more number of days where 5 or 6 cars are getting sold, which are more frequent, right? Selling 5 or 6 cars in a day is more frequent rather than, because it's quite obvious that no showroom can sell more than 20 cars in a single day. It's just a distribution which we have to understand. And by looking at the distribution, we should understand whether this distribution is making sense or not. Right? For example, let us take in this way. Let's take this is a for high-end classes. For example, let's take this as high-end cars such as Mercedes, BMW. So selling 4 or 5 cars are more frequent rather than selling 20 cars in a day. And let's take these are low-end cars such as Maruti or maybe Alto or something. So they can actually, there are a lot of, then it makes sense that selling more of 17, 18 cars in a single day, right? So it's just a measure, it's just a different distribution, and this depends on your business problem which you are working on, right? So similarly, I've asked you guys to work on kurtosis. How kurtosis is, what does kurtosis explains? How does it help us in our analysis? So what you can do when you send the challenge sheet, when you send us the sheet for the second assignment, you can also tell us the importance of kurtosis. Okay, you can consider that as your 6th question. Now, 4th question is important, guys. You have to solve this, and there was a particular reason why I have chosen this. Okay, so guys, I'll just give you the hint for the 4th question also now. Evaluate the probabilities for continuous probability distribution with given mean as 680 and standard deviation as 31. So if you remember, guys, I have explained you z-scores in the previous session, right? Where this is our mu, this is our sigma, right? Now the value of x is 711. Then you have to calculate the z value for corresponding this x value, so that you can make sure that the mean is 0 and the standard deviation is 1. So what happens, it's clear that from here, you don't have to go into Z tables and calculate the probability, because first one is very simple. So for example, we have converted our normal distribution into standard normal distribution, where mean was is equal to 680 and standard deviation was 31, right? And I'm asking for the value probability for x less than 711. Let me just make it more. Yeah. So what we are doing here, it's pretty simple for this problem because x is greater than mean here, and that too how much, 31 values, right? So which is equal to 1 standard deviation. So it has to be, if suppose 1 standard deviation is here in the standard normal distribution, this is 0, this is 1 sigma, then this would be your final probability, right? This would be your answer. And we have already discussed in the previous class the probability or the data lying between -1 and +1 sigma is 68 point something, right? So this has to be 34. So this has to be 34%. And this we know this is symmetric, so this will be 50%. So 50 plus 34 is 84%, which is 0.84 probability. So the probability for x less than 711 is 0.84, right? So it's pretty simple in this case because your x value was excess of mean with exactly one standard deviation, but not happens every day, right? So this was simple problem. X greater than 740, right? So for 740, you have to identify where will your 740 lie, calculate the z value with respect to 740, and then calculate the probability with respect to 740, depending on the new z score as per 740. So the probability which you will get will be always on the left side, lesser than, right? So once you get the probability, just do 1 minus of that probability, you will get the answer for B, probability of x greater than 740. Similarly, for C, you can do it now. You have to calculate the probability for x lying lesser than 720. You have to find the probability for x lying lesser than, for the x lesser than 600, and then you have to subtract those two values, right? The fourth one is interesting, and this is an interview question, guys. Probability for x equal to 720. Can someone tell the answer for this? This is very important, guys. Can someone tell the answer for the probability x equal to 720? 0. Yes, exactly, because it's a continuous normal distribution and probability is defined by the area, right? Area lying in that region. So for x equal to 7, for x less than 720, for example, for first A1, for A1 it was clear. If 711 is lying somewhere here, lesser than the shaded region, but equal to, for example, 720 is lying here, you will have only one line, right? You will have 720 say for somewhere here, and you will have, so your 720, suppose your 720 is lying somewhere here, or it should lie actually greater than 1 sigma, right? So somewhere on this side, it's okay. But my point is, if your point is here and you're calculating the probability is equal to this, there is no area under this region, right? Simple. So the probability has to be 0. And this is very important question, guys, because people in interview, they cannot ask these kind of questions, less than, greater than, because it will take some time to solve. But they can ask this question, okay? So you have to be very conscious. Okay, and the fifth one, I think you can explain this graph. It's very simple, guys. Okay. So now coming back to the predictive analytics. So before going into predictive analytics, I want to tell you something about artificial intelligence, machine learning, and deep learning. Okay. So see, there is a specific reason why I have written the font size of artificial intelligence is greater than machine learning and the font size of machine learning greater than deep learning. Can someone tell me what could be the reason why I have written in this font? See, I always tell you guys, remember, logical thinking is important. Apart from coding and the concept knowledge, you should also have logical thinking, right? Can you think what could be the logic behind the font size? Subsets? Yes, exactly. If this is my artificial intelligence, then machine learning is a subset of AI and deep learning is a subset of a machine learning. You remember from your school days, right? Subset is denoted by C, right? DL is a subset of machine learning. Machine learning is a subset of AI. So what is AI? What is artificial intelligence? It's very simple. A machine which mimics your human behavior. Anything which mimics your human behavior, for example, if you want to go and switch on the fan, and if a robot does it for you, then that's artificial intelligence. Okay, simple. No. What is machine learning? That is where we are focusing in this course, right? See, today, machine, for example, just imagine, which is working with the accuracy of say 70%. And we want to improve the accuracy of this machine. It's just not a matter of accuracy. There are other parameters which we will be learning in coming sessions. But let's take an example only of accuracy for this as of now. So today, for example, for a particular machine, the accuracy is say 70%. Okay. And we have been noticing that the accuracy of some particular machine is 70%. And if we want to improve the accuracy, then we will calibrate that, right? Something like that. Just imagine in that way, we are calibrating, right? So day by day, we have more data. We are trying to calibrate the machine in a better way daily. We are trying to increase the accuracy of the machine learning on the daily basis. Just imagine in this way of that particular machine. Any machine, say Venturi meter. It's very simple, right? In our school, we have learned Venturi meter, right? So Venturi meter, we are trying to calibrate Venturi meter. Just imagine in this way, right? But this is what we are doing manually. What if the machine or the if you write an algorithm which controls this Venturi meter, or for example, if you are writing an algorithm which read all the data, and with reading this data it can actually predict the accuracy by itself, or it is trying to improve the accuracy of that machine, then it is called as machine learning. See, for example, the machine will fail or not. See, we have to work on that machine. We have to keep working on that machine. One fine day it might fail, and then we won't be having a backup for that machine. But if we have an algorithm which predicts when will this machine fail, if we know that this machine will fail at the end of 5 years, then we can always have a backup at near whenever we are going, like we are reaching to that 5 year stage, we can arrange for a backup, right? So that is where machine learning helps us. In that way, we are not stopping our production. For example, we have different lathe machines, for example. Then in that way, we have the backup, and then we are not stopping our production, right? Now, in deep learning is a subset of machine learning. Okay, I don't want to go into deep learning as of now. As the name suggests, it's just a deeper method of machine learning. That means advanced version of machine learning. I don't want to get into that as of now, because first we will understand what is machine learning, because that's important here. So a machine is learning. How the machine is learning? The machine is learning with the help of the data. And by what algorithm? By some statistical methods. We are writing an algorithm so that that algorithm or that machine learns the data or get trained on the data and then predict the future for us. Okay, simple. Did you all understand this? The terminology which I'm using for machine learning? Please type yes or no. It's very simple, right? Please type yes or no, guys. It's very simple, right? A machine is getting trained with the help of some statistical methods by looking at historical data. Simple. So once the machine is trained on the historical data, we will feed some new data and we will ask the machine, in our case it is algorithm, we'll ask the algorithm to predict for this new data what could be the outcome. Simple. For example, I have 10 machines and I know for those 10 machines which machines are sustaining or which machines are failing. Then whenever I get a new machine, I will be having a lot of different input parameters for this analysis as well. But let's not go into that detail as of now. But by looking at all the different input parameters for that new machine, the algorithm will predict whether the machine will sustain after this amount of years or not. Simple. This is a simple terminology. See, the reason why I'm focusing so much on this one slide is this is very important. Okay, you should know what you are doing in coding. You should know what algorithms you are writing. You should know why we are writing the algorithms. Now, this is again machine learning. Machine learning is divided into supervised learning, unsupervised learning, and reinforcement learning. Supervised learning, unsupervised learning, and reinforcement learning. As the name suggests, in the supervised learning, supervision, right? For example, you have different images of different cars. Okay, you have the lot of images. You have lot of images for of different variants of vehicles: Mercedes, BMW, Porsche, Alto, Mahindra, something, something, so and so. Now, you are supervising those cars by looking at the image. You're telling the output for that. So, for example, the input is, say, image. Okay, let's say the input is image. And the output is, you are writing the output, you are labeling them as whether this is Mercedes-Benz, whether this is Audi, so and so. So there is a supervision of outputs on inputs. So whenever there is a new image of a new complete vehicle, the algorithm will try to predict whether this is a Audi or BMW or something else. Okay. So whenever we have an output, those kind of algorithms are called supervised learning. For example, in simple language, when you have the inputs as x1, x2, x3 and so on, and the output is y. See, being a mechanical and mathematical guy, I always try to give example in terms of mechanical and mathematical. So when you draw the graph, two-dimensional graph, if this is your x, this is your y, this is your input, this is your output. For example, this is your height, this is your weight. In most of the cases, weight is dependent on height, right? Or let's say what engine it is. For example, engine, BS4 or BS5, I'm not sure, but let's say what engine, and then you are predicting the price for that particular vehicle. So this is your X, this is your Y output. Now, X can be X1, X2, and so on, okay? But price is our output. So there can be multiple inputs. The output is price. In unsupervised learning, there is no output as such. It's only x1, x2, x3, so on. And then you are trying to find some patterns out of it. For example, if I give you different parameters, say engine and say torque, cc, the volume, different thing, maximum speed which it can attain, then you can automatically find some patterns in those. By looking at those data, you can also identify that high-end ones would be, the high-end cars would have better performance slightly, right? So by that you can identify some patterns. For example, airbags. Most of the high-end cars will only have the airbags, right? So by this you are trying to find the patterns. So by looking at the input data, you will try to find the patterns. Reinforcement learning, we will not be focusing on in this course. In this course, we'll not be focusing into reinforcement learning, but it's very simple. Just imagine that it's learning from the mistakes. Okay, you have committed some mistake today. Tomorrow, you know that if you do the same thing, you might encounter a same mistake. So you don't have to repeat that mistake, right? Of course, you can repeat a different mistake, but then that is how you will learn, right? Learning from the mistakes. And deep learning would be one of the examples for reinforcement learning, which will be focusing in the later sessions. But will not be going into great depth of deep learning in this course. Okay? In this course, we'll be focusing more on machine learning. Okay, so this is very simple. I'll just give you one simple example. Classic. Before going into machine learning algorithms. So this is supervised learning, okay? It is hidden behind this stop share thing. So what I can do quickly is, I'm not sure if I can track this, but let me quickly do one thing. Yes. So as you can see, this is supervised learning. So from now, we have started our machine learning predictive analytics course. So in this third session, and the basis is first and second session. So this is supervised learning, guys. Okay. And this is where you have to focus now. Sorry. So in supervised learning, there are different kind of outputs. For example, if the output is say price, you're predicting the price, right? Then it's very simple. The problem is called as regression. Under supervised learning, it is a regression problem. You have all heard linear regression in your school days, but in this session we will see what is its physical significance of linear regression. But this is the image which I have taken from linear regression, but nothing to worry now. The point here which I want to make is regression is where you predict the output as you're predicting the output such as income, sales, or something like continuous output, or the output which is having some range. Okay. In classification problem, you're not predicting income or sales or number of peoples coming into the stores or something. What we are predicting is, it's a classification problem. We are predicting what class to this person belong. For example, whether the person is married, bachelor, or divorced. For example, there is a new email which comes in, whether that email is spam or not spam. How this Gmail is actually segregating your emails as spam and non-spam with so high accuracy. In your initial days, if you remember, the accuracy, there were a lot of emails in your inbox which were spam. But now, the frequency of emails which are spam and getting into inbox is very less. How? That is machine learning. Okay. So, whether if you have a lot of cars, for example, lot of images of the cars, and you want to predict whether that image is of Mercedes-Benz or of Audi or BMW. So you're predicting the class. Okay. When you're predicting the discrete output or categorical output, then it is a classification problem. Okay, guys. There are some calculations involved in the algorithms. So you should be able to understand those algorithms in mathematical way. What is a backend calculation? How is it calculating? Okay. See, in coding, it's just a one line of code. You just need to write the function. For linear regression, you just need to write linear regression. That's not the case. We should not work in that way, right? Because we should try to understand what is the mathematical intuition of each algorithm. What's happening at the back end of this code. Okay. So yes, you have to understand the calculation. Okay guys, I'm just talking about the simple. Let's imagine. See, I'm just taking one input and one output because it's easy to analyze. But in reality, you might have multiple inputs. Okay, so 3-dimensional, 4-dimensional, 5-dimensional. What do I mean by 3-dimensional, 4-dimensional? For example, X is say your engine type and Y is your price, right? Now, depending on the engine, your price is changing. So this is your input. But in reality, your output is also dependent on other features, right? For example, the shape of the rear mirror, or for example, how well efficient you have, like which kind of tires the vehicle is using. So there are different input parameters, right? So what I meant is there can be multiple inputs such as x1, x2 and x3 so on, but our output is y. But let's take for simplicity only one x and one y. So in this case, for example, x comma y is somewhere here, x comma y is somewhere here, x comma y is somewhere here. So there are different data points which I have, right? Now, by these data points, I should train my algorithm so that in future, for example, there is a one future data point which is here. I want to predict what is y for that, right? Oh, sorry, not here. Let me just do that. Your new future point is somewhere here. X value is somewhere here. Okay. So you have to correspondingly, you have to find what is the y for this, right? So now the point is, for this data points or these are the black points are historical data points on which your model will get trained. Let's say this is your future data set. So, okay, this is new terminology for you guys. When your algorithm is on the data on which your algorithm gets trained, that is called training data set. Remember, guys. And any new data for which you do the prediction, that is called test data set. Different people have different terminologies. They call it as training data set, test data set. Some people call it as train data set, validation data set. Some people call it as dev data set, future data set. Some people call it as train data set, dev. Some people actually split them into three: training data set, dev data set, and test data set. So you don't have to worry. The logic is same. The concept is same. Okay. So now, for example, here for these data points, I can have multiple linear lines because we are working. The first algorithm of machine learning which we'll be looking at is linear regression, right? So there can be multiple linear lines, right? So based on these multiple linear lines, the value of y will be changed. It will be different for this x value, right? If for this line, the value of y might be somewhere here. For this line, for the corresponding x, the y might be somewhere here, right? So it's not simple. We have to come up with the best linear line, right? Because we can draw any infinite number of lines which actually passes through these different data points. But the line which is called as best fit line or the best line across this data, for example, this is your best fit line. There will only one best fit line, and that will be calculated based on the errors. Errors in the sense, for example, your data point was lying here. It was here, right? Let me do. Okay. And of course, there can be some points which will be exactly on this line. So for this corresponding x, there will be some y, right? Which is y actual. Let's assume for this point, if this is x, for this point, this would be y actual. But what will be y predicted for this point? Y predicted would be the arrows should not be in this direction. Okay, let me draw it once again. For example, this is your data point. The error will be always calculated perpendicular to the x-axis because, for example, let's take, this is your point, say x1 comma y1. Let's say x1 comma y1. This to be x2 comma y2. Let's take some example. So these y at these points are your y actuals, right? But with this linear regression, for this corresponding x, your y is somewhere here. So this is your y predicted. Okay. So your error is calculated between y actual and y predicted. Okay. And how do we calculate that? So it's a simple Euclidean distance formula or the distance formula which we have learned in our school days. What is the distance formula? Or let's take this one because x is same. The error would be sigma of y actuals minus y predicted whole square. Simple, right? So for all the data points, for example, if you have 5 data points, then this n value would be 5. And then sigma would be repeated for 5 different data points for which you will subtract y a minus yp and whole square it. Okay, this is called as root mean square error. Okay, so there can be infinite number of lines through these data points, but there will be only one line which will be having this minimum error. When you have achieved the minimum error for particular line, that is called as best fit line. And this best fit line will have a linear equation, right? So whenever there is as we all know, if there is a linear equation, whenever there is a new data point, just put that x value in the equation and find out y. Okay, so it's straightforward. It's a very simple thing. But now the important thing which I want to explain here is there are different ways for calculating error. There is something called as mean square error, which is 1 by n sigma ya minus yp whole square. There is something called as mean absolute error. Okay, in this case the error is calculated in this way, modulus of ya minus yp. So there are different ways for calculating this error. Okay, making sense, guys? Now see, and we know that the best fit line will have the minimum error, right? You can use any error formula, but the best fit line should have the minimum error. Making sense? Now this is where your mathematics comes in again. If we could recollect, guys, from your college days, if we want to minimize something or maximize something, what do we used to use? I think I have already answered your question, no? How are we choosing best fit line? The line which has the minimum error. But yes, I got your question. How are we choosing? It's not straightforward, right? We cannot keep on calculating errors for different lines. We cannot do that, right? So there has to be some method which actually chooses the best possible line, right? So how do we do that? So as I already told, we have to minimize the error. So could you please tell me what is the concept which we have used for minimizing and maximizing in our college days? As we are calculating the error for different lines, we know the best fit line would be the one which has the minimum error. And if we want to find at what point we will have the minima or maxima, what we used to do, guys, in our college days, we have to differentiate, right? Using differentiation. So here also we have to use differentiation, for which there is an assignment which you have to work on, guys. I'll just give you the mathematical intuition. So for example, let's take a very simple line equation. This is called as simple linear regression. When we have one input and one output, it is called simple linear regression. When we have multiple inputs, then it is called multiple linear regression. But as I told, I will explain the concept for simple linear regression. You can always extend that for multilinear regression because the concept is same. So see, in our school days, what we used to do, we used to get the line equation, we used to substitute the values of x and get the values of y, and then we have to plot the graph, right? But now we have grown up. Now the problem is difficult. What we have is, we have different data points. We have x and y. We have to find beta naught and beta 1 such that the error is minimum. That is what we have to do. And that is where we have the challenge now. You're getting my point. So just imagine in this case, say this is your beta naught, say this is your beta 1, and there is a third dimension which is called as, say, error. Okay, or let's say this is your error, and this dimension says, let's say this is your beta 1. Don't get confused, it's a 3-dimensional. So when you draw the graph between this different beta naught and beta 1, you'll get the different error values, right? So this error needs to be minimized. For example, for this beta naught and beta 1, let me take some other color. Yes. So for example, for this beta naught and beta 1, the error is so high. Okay. And how we are drawing this graph, it is important to understand. Now we have to slowly move down. How do we move down through the graph? Through tangents, right? And how do we come up with the tangents? By derivation, right? So we are moving along this graph. Okay. And this is where you have the minima, right? So if the error is minima, for which particular beta naught and beta 1 your error is minimum, we will take that beta naught and beta 1 and that will be considered as your best fit line. So far so good. But how we are moving down? How can we make sure that we are moving down? For that, there is a concept of tangents, right? Remember from your school days or college days, how do we calculate the tangent? By differentiating. And what we have to differentiate? In this case, I have just written y, but in reality, what we are differentiating? We have to differentiate the equation what we need to minimize. And what we need to minimize? The error, right? So we have to minimize error with respect to beta naught, and we have to minimize error with respect to beta 1. Okay, and what is the error equation? For simplification, we can use this error equation. Now you must be wondering, where is x here in this equation, right? Actual value is already given. The predicted ones would be based on this. Okay, substitute that yp in this error equation, and then you have to differentiate. And once you differentiate, what you will get? You will get tangents, right? So by that you will get and slowly you have to move down, and by that you will get the minimum value. Okay, so now I have given you the mathematical intuition behind how does this minimum thing, which what we are trying to minimize, how does it work. And whenever you are trying to minimize or maximize something, that is called as gradient descent method. Okay, in our case we always try to minimize something because we are minimizing the error. Okay, so this is important. This is our error function, and this is what we are trying to minimize. Okay guys, this is also called as your loss function, or this is also called as cost function, but you don't have to worry much about the terminologies. This you will learn it slowly, all the terminologies, but the important thing is what we are trying to minimize. We are trying to minimize this error, and this equation is called as cost function or loss function. So there is a slight difference between cost function and loss function, which you have to work while reading. You have to come to know what is that difference, and you can tell me in the next session what is that difference. But that is not important for me. The important thing is we are trying to minimize mean square error using derivatives, and that this derivative method is called as gradient descent method. Okay guys, so you got the logic, you got the mathematical intuition, but in coding you don't have to do this much. There is one simple line of code which will give you best fit line, but as I always tell, don't go with the one line of code. Understand what's happening at the back end, right? So for example, I have different inputs x1, x2, so on, and this is my value y. Okay, now the reason why I have written e is, so for example, this is your x1, y1, x2, y2, x3, y3, x4, y4, so on. For corresponding x1 there will be y actual, but what we are writing here is y predicted, right? This linear regression is for predictions. This will be y predicted, and it will have some error, and that error is by this line, right? It is shown by this line, right? Making sense? Now these all are okay. We are coming up with the best fit line, but how do we evaluate whether the best fit line what we are getting, is it good or not? How do we evaluate? So for that there is something called as coefficient of determination, which is also called denoted as r square. So for example, if r square is say near to 1, that means it is the prediction what we are making are with very good accuracy. If the r square is lesser than 1, for example say 0.7, then the predictions what we are making, it might not be very near to the actual values. Okay, if the r square value goes further down, then it is actually the accuracy of the model is even going down. Okay, so we have to make sure that the r square is always near to 1, but sometimes it's not easy to bring your r square value to 1. It's not very straightforward. So the assignment or the challenges what I have given, in this case you just need to you have to come up with a linear regression, and then you have to evaluate the r square. You don't have to improve the r square value in this course. We will see how to do that in the coming sessions, but now as of now you don't have to do that. Okay, but the important point is r square is, it's a measure for validating or evaluating your linear regression model algorithm. How well your linear equation will predict the output for the given inputs. Simple. I'm just using simple English words here. Okay, making sense? I'm just using simple English in my course so that you all can understand. So this is what I was talking about, gradient descent. This is my mean square error which I was talking. If you remember, 1 by n sigma y actual minus y predicted. And what is your y predicted? This is your y predicted. I have substituted that here. Instead of writing beta naught and beta 1, I have written mx plus b. Instead of beta naught, I have written here beta naught is b and beta 1 is m. No confusion, right guys? It's just replacement of that coefficients beta naught and beta 1 with m and b. Now I have differentiated the error with respect to m and then with respect to b. And then I am moving from one point to other point to find where is that point for which the error would be minimum. You can always keep on moving, but then you will notice at one particular point, your error, initially it might be increasing, but at one particular point, your error might start increasing. Okay, so initially your error might be decreasing, but at one particular point, you might notice that your error is increasing. And that is where you have to stop, guys, because that gives you a hint that the error is minimized at that particular value. Okay, and then so how we are moving on to that particular tangent? By using these values. For example, what is this? This gives you the tangent, and the tangent might be, say for example, for this curve, the tangent for this point, say the tangent is this much. So now the tangent can be this much, the tangent can be this much, the tangent can be this much, right? So how do we ensure that we have to slowly move, right? How do we ensure that we have to move slowly? So for that, there is something called as learning rate. So we have started with some random values of b and m. We got some error. We have taken that one big tangent, but we have to make sure by using the learning rate, we are not going far. If we are going far, then we are going away from our destination. So we have to go slowly. So ideally, learning rate, in most of the cases, learning rate will be 0.001, but it depends on the problem again. Okay, if with 0.001 your learning rate, the error is increasing, then you have to reduce it further. So what we are doing, using tangents, derivatives, we got the tangents. Now we are updating b and m again with some smaller values of learning rates. Now we are here, and then again we calculate error. Okay, then again by using this error, again we calculate this derivatives. Again this using derivatives, we again calculate b and m. So we are updating our b and m value. So now suppose you are here, so you have to take tangents again, and then your point is here. So you have to keep moving, and then at particular point you will notice that the error is minimized. So that is where you have to stop, and that particular b and m value would be your final value, which will be used for your predictions, mx plus b. So once you get the final m and b, so this your y prediction is trained. Now your output is trained. Now whenever you get a new x value, you just need to substitute here with the same value of m. Say x is some new x new, which is a test data right now, because we have trained the model on training data set. Now x new, and now you have to predict a y value for this x new. In our college days, we used to call this as extrapolation or interpolation, right? Math behind this. Now you can imagine how much math is involved behind this, right? So moving forward, okay, now we have to go into hands-on, okay guys? But before going into hands-on, did you all understand what is training data set and what is test data set? In real life, the test data set, so for example, if you have 100 data points, the training data set will have more data points because that is where your algorithm is getting trained, right? So people will generally take 70-30 ratio, 80-20 ratio, or 90-10 ratio. It depends, okay? 70% of the data going into training data set, 30% of the data going into test data set. Okay, so you always have to split your data set into training and test data set, so that your model is trained on training data set, and then you can predict the output for test data set, and you can see how well our model is performing. Okay, so training data set, test data set, what all we have learned, different types of errors, how do we minimize that errors using gradient descent and derivatives, how to achieve the optimum value of m and b. So you don't have to worry if you don't understand gradient descent, because it's more of maths, but please go back and do the homework. So in the challenges also, there is one thing which I mentioned on gradient descent. If you can just go and work on those challenges, you will understand how this gradient descent works. Okay, you're getting my point, right? Until unless you practice, you will not be comfortable. It's simple. You must be thinking in the coding that it's only a one line of code, I will just use those one line of codes. But then, as I always tell, to do the fourth analytics, which is descriptive, diagnostic, predictive, and prescriptive analytics, right? To do prescriptive analytics, you should know what is the math behind it. In Python, there is a simple one-line code which you can directly use. But if you want to implement that as a gradient descent method, if you are thinking I want to come up with a best fit line by my own, the Python function, then you have to write these equations in Python and you have to put in for loop, because it's a for loop, right? You have to keep on updating b value, m value, and then for which particular b and m you will get the minimum error, right? So that's the whole point. If you want to do it from the scratch, you can do all these equations, you can incorporate in your for loop. But if you want to directly write one line of code, then there is a one line of code which you can do it. But as I always tell, you can write the one line of codes while doing the projects, but for while doing the challenges, it's important that you learn as much as possible. So for that, I recommend if you can do some pen and paper practice also on this, and if you want to write a code, you can also write a code. That would be better for you guys. Okay, this is a machine learning algorithm only. This is a very basic algorithm of machine learning, so which is linear regression. I've also given this as a assignment. Perform gradient descent in Python with any loss function. What do I mean by any loss function? That means any error equation. You can use this equation, RMSE, you can use MSE, you can use mean absolute error. There are different ways of calculating the error, okay? You can use any function which you want. But the most famous one are mean square error and the mean absolute error. For doing the gradient descent method, the famous ones are mean square error and mean absolute error. Okay, making sense? So L1 is called as mean absolute error, L2 is mean square error. Okay, I already told you the difference, but just tell me what are the pros and cons for both the loss functions. There should be some pros and cons, right? That's the reason there are so many ways of calculating error. So you have to work on this, guys. And in this, till now I have not given any data set on which you have to work. You can come up with your own data set and work on it. Very simple data set, say only 1x, 1y with 5 records. It's up to you, because I want you should know how to create data sets also, right? So you can just make your own data sets. For example, torque and price of the vehicle. Very simple data set with 5 records. Changing the torque, you know how if torque increases, you all know, right? If torque increases, whether the price of the vehicle increases or decreases. Okay, you can think on it. I don't want to get into mechanical stuff as of now, but then yes. So take any mechanical example with 5 records and try working on it, because of, I would say, from 7th session, you have to write codes. That doesn't mean that you don't have to write code now. You have to write code now also, but from 7th week, you will have a lot of projects. Okay. So going back to Python now. So I'll just give you the intuition. How does linear regression can be incorporated in Python? Okay, guys. So before that, I'll just tell you a few things. In Python, as per to become a data scientist, you have to remember 4 or 5 libraries. Because we are beginner now, it's important that we remember 4 or 5 libraries. As we proceed in future, you can go with different libraries. Okay, and I will write down all the libraries names here. So can anyone tell me, you must have heard a lot of buzzwords about data science, right? Can someone tell me what does NumPy do? If you just have some hint, that's it. Because it's important that we should have more interactions. See, what all descriptive analytics which we talk, right? That is where NumPy comes in. For example, let's go to coding window. So if you notice now, guys, this is how we import all the libraries. NumPy, pandas, different libraries, that's okay. But for example, let me comment this code for time being so that I can go to the basics. Okay, so these are the libraries which I have installed. First, let me explain what is NumPy. Okay, for example, if I have x equal to 1 to 100, I hope you guys are practicing at your home. Okay, there is some syntax error here. Okay. Let me just take simple one because I think I have to write list over there. I have to write range there. Then it will work. But anyways, let me take a simple example. Okay. I know there is no comma between 3 and 4. That's okay. Okay. Now we have printed x, right? Now if I want to find the mean of x, it says mean is not defined. Okay. It will come by practice that we should know which functions are placed in which library. Okay. I also don't know everything. It's just that by practice you will come to know what all functions are placed in what all libraries. So NumPy is a library where mean is stored in. So we have imported NumPy as NP, right? So if you write np.mean of x, then I believe it should work. I have to print it. So the mean is 10.5. So did you understand? So similarly, mean, median, everything will be in NumPy. And pandas. So what is pandas? See, in real life, we work with a data set, right? Data set in the sense you will have lot of records, you will have lot of rows, you will have lot of columns. In data science language, we call it as lot of records as lot of rows and lot of features as lot of columns. So let's go with data science language, lot of records or observations and lot of features. So features are x1, x2 and so on, and the output is say y is one more feature. So this data set is kind of matrix, right? But the problem is a matrix will always have the numerical data or similar kind of data for all the features. But when we work on the data, real life project, there might be some features which will have numerical data. There might be some features which will have categorical data, which you have to convert into numerical. That's of course. But then there might be some features which will have discrete data, right? So for those kind of data, there is something called as data frame. Or if you want to import an Excel file, for example, then you have to import it as a data frame in Python. So for example, I have one Excel file. I am importing it as the Excel file is say XYZ. So you will get the recording. You can write the same line of codes, but I would always recommend that you guys keep practicing. Okay, just try to play around with the code. So this is where pandas come in. Pandas is the one which helps you in lot of things, but the main advantage is you can create a data frame directly by importing a file. And by importing this file using this function read underscore CSV, I'm creating a new data frame. Now if I print this, for example, you will see that there is a new data frame which is coming in. There is a new data frame, and for one of the values there is no value. Okay, but you don't have to worry as of now. For this case, there is a special way for handling the missing values, but don't worry about it now. So what it says, area, bedroom and age of the apartment. So based on that, we are predicting the price. So how many x we have? X1, X2 and X3, and then we are predicting the price. Okay, so it's very simple. I'm just importing the file. Now I'm trying to, by only one syntax, by using only one function which is describe. See, by using only one function which is describe, I'm able to get the count, the number of observations, which is 5, the mean for each feature, area, bedroom and everything, the standard deviation, the minimum, 25 percentile, 50 percentile and 75 percentile max values. So these values we are able to get it by using directly one function. So this is what you need to do, guys, exploratory data analysis. This is only one thing. You have to do a lot of things. You have to plot the graph, you have to plot scatter plots, you have to plot bar chart, go and explore what is the function for bar chart, what is the function for histogram, try to understand the data, understand whether the data is normally distributed or not, what happens if the data is not normally distributed. So please explore it. Okay, so when you work, then only you can explore on this. So this is function for median. I don't need this anyways. Okay, this is for mean. That's okay. So I'm just using this command, 2 lines which I'm highlighting here, 19 and 20. I'm just trying to replace this missing values with a median value. Now why I'm replacing with the median value? I can also replace with mean. See, there is a particular feature bedroom. In this, there is a missing value, right? So I have to fill this because you cannot work with a missing value data set. So whenever you are working with a missing values data set, you have to implement imputation. This is again a separate technique which you will learn later on, but you can remember this. Imputation is a technique to handle missing values. And imputation, there are different techniques. One of them is just find the median of this feature 3, 4, 3, 5 and replace this missing value with median of that. The other way is replace the value with mean. There are different ways, guys. There are different ways. Okay. But anyways, now the important thing is we know what is NumPy, what is pandas, what is matplotlib. As the name suggests, all the graph libraries, most of the graph libraries or most of the graph functions will be placed in this library. So far so good. We know what is NumPy, what is pandas, what is matplotlib. Then what is Skill-Learn? Skill-Learn is the heart of machine learning. All that one line of code which I was talking about, all those one line of functions are already inbuilt in this Skill-Learn. Okay. And again, you know what is the backend of this one line code, right? Gradient descent, which we have learned, but that is already in place for that one line of function. So what I am doing here is from Skill-Learn, I am importing linear model. In that linear model, I have a linear regression, which is inbuilt. Okay. So I'm assigning linear regression to one variable called as regression. Making sense? I'm assigning linear regression to one variable called rig. And then I am fitting the curve between all the inputs and output. See, inputs are separated and output is separated by this. Okay. So this is the syntax. The variable dot fit all x comma y. Okay, did you understand how what did I do using imputation? So far till imputation it is okay, right? I'm just replacing the missing values, right, Naga? There are different ways of doing imputation, but the simplest ones are mean imputation and median imputation. Now what I am doing here is, see, there is a library called as Skill-Learn. In that there is one function, or I would say, let's say there is a one function by name linear underscores model. In that linear underscores model, there are different functions inbuilt, in which one of the functions is linear regression. And for our challenges, for our course, for this session, we need linear regression, right? So this is how we have to assign the linear regression in one of the variables. This is a basic step what we have to perform. Okay. So far so good. So I'm assigning the linear regression function into one variable called as reg. Now I have to fit the curve between x and y, between inputs and output. In our case, we have 3 inputs and 1 output, right? So this is multi-linear regression, right? This is not simple linear regression, because in simple linear regression, you will have only 1 input and 1 output. Here we have 3 inputs, multi-linear regression. So these are inputs, right? Please note down here also. At the bottom, if you see this table, this is your data frame or data set. In Python language, data set is called as data frame. So these are your inputs and this is your output, and this is the syntax which you have to write for fitting your inputs and outputs. So far so good. Please write yes or no. Once I fit the model, my linear regression is built and it is stored in reg, because we are already denoting linear regression with reg, and this linear regression is fitted as per our data set. So now we have built the linear regression equation. Now to look at that equation, see, we know what is y, what is x. Y is price, x1 is area, x2 is bedroom, x3 is age. What we need to find is coefficient, right? So if we print reg.coef underscores, what we are seeing here, these are the coefficients. If you want to write the equation, you can write it, but it's not required, because now reg has everything. This reg variable, it has our best fit linear regression line. So for each variable, you have each coefficient, and if you want to print the intercept, you know what is intercept, right? Right, guys? Mx plus b. M was the coefficient for x, b was the intercept. But here we have 3x, x1, x2 and x3. So now you can always write the equation with this. you know y is equal to 137.25 into x1, which is area, plus this coefficient into x2 plus this coefficient into x3 plus the intercept. Now you have the equation. Now whenever you get new x1, x2, x3, you can calculate the y using equation, right? But you don't have to do that. You can directly do that in the Python. Now, for example, if you have new values of area, bedroom and age, then you have to write these three new values and you have to write. So it's very simple, right? That is how builder also works. So if you are working as a civil engineer, for example, and you are an advisor for one of the builders, then it's important that you should be able to predict the price for different flats, right? Then, for example, for new, so this, our model is built on the training data set. Now this is our new test data set on which we are trying to predict. And the syntax is reg.predict, simple. Now let's predict that. So for this new values, the price is 5,88,000. Let's think in this way, guys. When the area was 2600, the price was 5,50,000. When the area was 4,000, the price was 7 lakhs. But again, if you notice this 3,000 and 3,200, for example, this area with 3,200 and area with 3,600, what we think? Bigger area, higher price. No, not really. It depends on the age of the flat, right? This is the older flat. So the price would be lesser, right? So we have to analyze. And then for the new test data, what we have given, whether this price makes sense or not. Simple. Making sense? Now, you know, we have got all the R square, sorry, you have built the model, you have done the prediction, but how well your model is predicting, that is dependent on your R square value, right? For that, the syntax is reg.score between your input and output. Okay. So you have to just write reg.score. So if you notice, R square value is 0.94, which is very, very good. In real life, it is very difficult anyways, but then it is important to know what is this R square. So the model what we have built is predicting very well for the given data set. So we can use this linear regression model for predicting the price for future data set or for any test data set which is coming in. So there might be today someone might have asked you, some new client comes to you and tells you that, see, I want the area of the flat, say 4,000, but I need only 2 bedrooms. Okay. And it should be only just find me a flat with 4,000 square feet and it should be having only two bedrooms. That means very spacious bedrooms. And then the flat should not be that old. It should be only 2 or 3 years old. Then you should tell to your client that you can predict the price somewhere near to this. For example, say 4,000 area and 2 bedrooms and only 2 years old. So tell me, now if you notice, the price is 8 lakhs, and which makes sense, right? If you notice from this, for 4,000 it was 7,60,000. Now we have 4,000 square feet area, but the flat is new, right? So the price should be higher. So it's logical. So this is how you have to always interpret the results, guys. Don't blindly follow the results. Interpret the results, whether the results what you are getting, is it really making sense or not? So this is one of the simple examples which I have taken for civil engineers, but then again, you can take different examples. For example, you will be doing this assignment anyways in your projects. Once you complete 6 weeks of course, there is one assignment, there is one project where you have to predict the mileage based on the horsepower of the vehicle, based on the volume of the vehicle or volume. So based on the different parameters, you have to predict the mileage. So that is a multilinear regression problem. So you have to predict the mileage. Okay, so far so good. But remember, this data set was very small. Ideally, you will have a very big data set. So as I told, you have to split the data set into training data set and test data set. You have to build the model on training data set and then you have to predict for test data set. But this was a very simple model. That's the reason I have taken a very simple data set. So I have taken all the data sets for building up the model. Okay. But in real life, you will have a lot of data sets. So for that, you have to split the data set 70-30, 80-20 or 80-20 or 90-10. It's up to you. Where you are getting better accuracy and where your results are interpreted in better way, or where your results are making more sense. Okay. So did you all understand this line of codes? See, if it's very simple, right? The one line of code which is important is this, right? So you have completed, it's just that in within 10 lines you have completed your machine learning model. But if you think in this way, it will not be helpful. You should understand what's happening at the back end, right? Similarly, you will have a lot of different algorithms. So this linear regression is used for predicting the price, sales, continuous variable. In next session, we will see how to predict the class. Okay. So before logging out, I just wanted to ask you one puzzle, and then you can start asking your questions. Okay. So the puzzle for today's session is, how many rectangles are there in a chessboard? I assume that you all solve for a puzzle of how many squares are there in a chessboard, right? Please solve a puzzle where you have to calculate how many rectangles are there in a chessboard. Please solve it. Now please put in your questions in the chat box.
So we have one question regarding equations for business moments in class. Is there any material for where we can get details of the same?
You don't have to find a specific material. You just need to write in Google, or just write what are the 4 business movements in Google. You will directly get it. So you don't need to specifically refer any material for that.
Equation, yes, a follow-up question. Equation appears different from the same, especially quarters.
Okay, so there could be a chance different guys. So see, this is important. Okay, see, for different websites, I believe you must be thinking the equations might be slightly different, but that's it depends. Okay, see, for the different analysis, they choose different kind of formulas, but the formulas which I have written are the standard ones. So you will see a lot of things in statistics, more about how you analyze. For example, you're doing a failure analysis, and in your analysis, the probability for a machine to fail is say 0.7%. Then what you will infer from this? That machine will fail, because you will assume that 0.5 is your threshold limit for your probability, right? If the probability of failing is less than 0.5, then you will think it is not failing. If it is greater than 0.5, then you will think it is failing, right? But in reality, it's not the case. The threshold value of probability is again calculated based on different analysis. Okay, so similarly, it depends on the analysis. But the important thing is, what is the importance of kurtosis? Formula is not important, as I always tell. What is the importance of kurtosis? Did you understand what I'm trying to tell? Yes, you're right. It's a measure, but I want you to think in terms of, you have to come up with some examples where kurtosis can be really important. I have not given any example on kurtosis, if you remember. I have given you examples on skewness, variance, central tendency, mean, median, but I have not given any example on kurtosis. So when you try to look for the examples on kurtosis on internet or explore yourself, please explore it, okay? And then only by this you will learn a lot of things. Thank you. Any more questions? And also, you guys are solving puzzles or not, guys? Just listening to the classes will not help, guys. You have to practice. Okay, then if there are no questions, then I'll take a leave. Let's catch up tomorrow again. We will be looking for classification problem, okay, which is an extended version of linear regression, which is called as logistic regression. So let's catch up tomorrow, guys. Thank you. Hello everyone. In the last session, we have discussed about what is the difference between classification and regression. So I hope you all have understood the difference. That's the first point, because it's important that we all understand and we all are in the same page, because all the algorithms will be based on this now. And we have talked about multilinear regression or simple linear regression. In simple linear regression, there will be only one input. In multilinear regression, there will be multiple inputs. So that's the only difference. And apart from this, there is something called as errors. If you remember, I have talked to you about how did we achieve this best fit line, right? So the most important criteria is how to achieve this best fit line. So for that, if you remember, we have discussed about different types of errors. And on those different types of errors, we have to minimize the error. Now, how to do that? In our college days, we have learned about derivatives. In the application of derivatives, we have learned derivatives are also used for finding minima and maxima, right? And that's the same technique which we have implemented here. So, and how do we calculate error? It's very simple. For say this is a particular point, for x, say this is your y actual, but y predicted would be on the line, right? So please notice my cursor, okay? So that would be a y predicted. So that's how we have to find those differences, square it, and then take the sum over the distance or the differences for all the data points, and then average it out over number of data points. So that is called as mean square error. So let's discuss once again how do we code it, because it's important that you should understand how to code gradient descent in Python. Yesterday we have looked into mathematics, so let me go and tell you step by step how to code it in Python. It's just a matter of equations, so I believe it might have been difficult for you guys to code it. So today I just thought I'll just give you a step-by-step process so that you can use different for loops and write and code it for gradient descent using mean square error. So as we see, this is a mean square error. So the first step, what should be the first step? So let's go step by step. Okay, let me take this. Yeah. So what is first step? First step is calculate the mean square error, right? Go into Python, just use for loop because we are using summation, so we need for loop, right? Use for loop. Now let's assume that you are starting with your initial random initialization for m is equal to 0 and b is equal to 0. Let's assume that. Okay, so with this values, you know now with different x you will be having y predicted, right? And this is your y actual. So use this formula. Okay, it's very simple. You just need to write the formula in Python. Okay, and then use the for loop for summation. How do you do that? For loop for I in range of 0 comma length of, you can just use x or y anything because it's a number of data points, right? So it's up to you. So whatever x you have in your data frames, so you can use this for loop in your Python, and then you can start coding. And then in this for loop, for different data points, you will get the mean square error. That is your first step. Okay. Now we have to minimize this, right? Our ultimate objective is to minimize this. So what we do differentiation. We do differentiation. This is partial differentiation. Okay. So before going ahead, it's important for me. Can someone tell what is the difference between ordinary derivative and partial derivative? See here, if the equation would have been, say, y equal to x square or y equal to x square plus 3x plus 2x or something like that, then y is only a function of x, right? Then if you want to find the derivative, then if you use partial derivative or ordinary derivative, it doesn't matter, because you have to derivate your y with respect to x only, right? So here also we have a function which is actually dependent on m and b. Why I am telling only m and b? Because x and y are the data points which are given to us, right? So those are like constant for us and which are repeatedly changing for each sigma or summation. The values which are variable or which are varying are m and b, and that is what we have to come up with a optimized value of m and b for which the gradient descent method can be achieved and you can minimize the error, right? So the first step I've already explained. Now the second step is just denote this derivative d by dou m as say some d1, okay, in your Python. And then again in for loop, find the summation and find this value. Okay. You know yi, which are actually changing with respect to data points. So in this case, for example, we have 4, 5, 6, 7, 8, 9, 10, 10 data points, right? So then the n should be 10, right? So that is how you can calculate d1. Similarly, so you can use the same for loop if you want, guys, okay? And then third step is, so you should be able to find the optimized code, okay? Whether to use separate for loops or same for loop. Now the third step to calculate dou by dou b, which you can assign it to d2, for example. Now, do I need to explain how to derivate this with respect to m? Now we already know the derivatives, and now we have calculated d1 and d2. Now, the fourth step is, once you calculated the d1 and d2, you have to keep updating your b and m. Here alpha is your learning rate. Okay, so now think in this way, guys. For me, I think it will be very easy to explain you, because we are all mechanical engineers and we have learned numerical methods, right? So what is numerical methods? See, if you remember the Euler method, RK4 method, RK5 method, there are different methods, right? Newton-Raphson methods. There are so many methods which you have learned in our numerical method session, right, in our college days. So as a mechanical engineer, it was mandatory for us to learn, because our simulations, most of the simulations would be iterative process, right? So we will always try to achieve to a optimized value or to the solution by using iterative process, right? And that is what we have to do here. This is also iterative process. So we have to keep updating our values of b and m again and again until and unless you achieve the mean square error as minimum. So at one particular point, so how now the point is, this is one thing, this for loop is one thing, okay? There would be one more for loop on this above this, I would say above this, okay? So this for loops which I have used is to use for calculating error derivatives, but there would be one more for loop on the top of this, right? And that it's up to you. For example, let me take this as j. Then let's assume that in 1000 steps we are able to achieve the optimized solution. What do I mean by 1000 steps? If this is our error curve, we are, for example, m equal to 0 and b equal to 0, somewhere here, let's say somewhere here. With the help of learning rate, we are slowly moving towards our optimized minimum or minima value, right? So yes, so see, let's say j equal to 0, then it will go into this for loop, and then it will calculate the mean square error, then it will calculate d1, d2, and then initially we have assigned b equal to 0 and m equal to 0, right? So right, we have to update b and m, and then again it will go to the upper for loop now. Then it will take j equal to 1, and then again in the inner for loop it will calculate again with different m and b. It will calculate mean square error, again d1, again d2, and then based on d1 and d2 and the learning rate, it will again calculate, it will update the value of b and m, and then again it will go to the upper for loop and it will take j equal to 2, and then again it will go into inner for loop where it will calculate mean square error, and then d1 and d2, and then it will calculate b and m, and then again it will go to the next for loop. So the point is what learning rate you are deciding. If your learning rate is very high, then it will, instead of going on this slope, it might directly go out of this curve, okay? So you have to be very careful and start with smaller learning rate. And then if you notice in 1000 iterations, if it is not converging, then you can increase the iterations. or else keep on increasing the learning rate and find that an optimum value of learning rate where your error value is not increasing. Okay, so this is just a trial and error, but what I do with my initial stage, I choose this learning rate as 0.001 and with 1000 iterations, and that means 1000 different m and b values. That means 1000 times I'm updating m and b, and then we will find if there is any minimum mean square error. Once we achieve minimum mean square error, then we should stop there. How would we know if we have achieved the minimum mean square error? In this for loop, you have to write if else condition also, that if the mean square error for current iteration is increasing from the previous iteration, then we have to stop, right? So perform gradient descent in Python with any loss function. Loss function in the sense error, any error function which you are willing to. I would say you can use L2, which is this mean square error, because L1 will be having mean absolute error. There you will be having modulus, right? So what is mean absolute error? Which is also known as M1. It is 1 by sigma absolute of y actual minus y predicted, and y predicted is mx plus b. Now we have to differentiate this also, right? So it would be difficult if you, it not be difficult, it's just that if you could recollect what is the differentiation of mod x, if you remember guys, because this is something like mod x, right? To keep updating your values b and m like we have done for L2 function. For L1 function, we have to find derivative of this, right? In the previous case, it was simple. You had square, and we know what is the derivative of x square. But here, we have to find the derivative of mod x. So the first question was perform gradient descent, which I've already explained. Difference between L1 and L2 gradient descent method, which I already told you. How does the equation looks like? You have to tell me what are the pros and cons. Okay. And the third question, what are the different loss functions for regression? I have told you 2 or 3, I believe. You can come up with different ones. In the fourth one, what is the importance of learning rate? To come up with the importance of the learning rate, see, I've already explained you, if you increase the learning rate very high value, then there is a slight chance that your tangent will go. So your tangent will be like this, right? Then if you take very high learning rate, then your value would be somewhere here. Then instead of going below the bowl, you are actually going outside the bowl, right? So it's important to choose right learning rate, but I would recommend that you go back and in Python coding, you have to change the values of different learning rates and do trial and error method, and you will understand its significance. How to evaluate linear regression? I've already told you. What is the difference between multiple and adjusted coefficient of determination? This is something which I didn't tell you and I want you to explore, okay? One hint which I can give is, for simple linear regression, if it is multiple or adjusted, it doesn't make much difference. See, what do I mean by coefficient of determination? R square, right? R square is our coefficient of determination, right? So this R square, what we were talking about in simple linear regression, that was coefficient multiple or coefficient of determination. So both are R square only. It's just that there will be slight difference in the values and in the formula. For simple linear regression, when there is only one input, both are one and the same. There is negligible difference, I believe. But when it comes to multilinear regression, you should know which value should I look at. Okay, in Python, it's very simple. If you just write score, dot score, it will give you directly the one which you have to look at. But you should know the difference. What is the difference between multiple coefficient of determination and adjusted coefficient of determination? So this difference would be noticeable when you work on multilinear regression. And multilinear regression is when you have multiple. So I have given one puzzle yesterday, right? How many rectangles are there in the chessboard? For example, let me take very small chessboard of 2 by 2. Right, so you have the answer, but I'll tell you the different logic here. Let me take 2 by 2 square board. How many rectangles do we have? One important thing which you should know is every square is a special type of rectangle, right? So here if you notice, one square, two rectangle, one rectangle, two rectangle, three rectangle, third one, fourth one, fifth one, sixth one, because every square is a special type of rectangle. So you will have 9 rectangles here. Now, how did I tell this? There is a specific reason why I have asked this puzzle, because see, to get to master, say I will not use master word, I would say to understand probability in a better way, if you remember, permutations and combinations are important, right? So this puzzle is on permutations and combination itself. So what I have done for 2 by 2, I had 3 lines, 3 horizontal lines and 3 vertical lines, right? So every rectangle can be made of 2 vertical lines and 2 horizontal lines. So we have 3 horizontal lines and 3 vertical lines. Out of 3, we have to choose 2 to make a rectangle, right? And out of 3 vertical lines, we have to choose 2 vertical lines to make a rectangle, right? So I told I need 2 horizontal and 2 vertical. So whenever there is and, there should be a multiplication. So this would be equal to 9. So you have 9 rectangles, right? Simple. Now for 8 by 8, can you tell me now for 8 by 8 what could be the answer? It is 9C2 into 9C2. So Jairam has solved this problem from a different logic, and this is the one which I had in my mind. Okay, cool. Okay, so to get started with classification. So now we are in classification. Now you must be thinking, if it is a logistic regression problem, if it is a logistic regression, as I already told, regression is used for prediction, the continuous variable or something which is in specified range, such as height of a person, weight of a person, income, salary, sales. And classification is the one where we used to predict the class, whether the email is spam or not, whether the machine will sustain or not, right? Whether the temperature of the brake disc is greater than 100 degrees or less than 100 degrees. So for this kind of problems, right? Or whether the temperature of the fuel tank is between 30 degrees to 50 degrees, one class, 50 degrees to 70 degrees, second class, 70 degrees to 90 degrees, third class, 90 degrees to 110 degrees, fourth class. So this is like 4 different classes where we have to predict what would be the output, right? In whether this data will fall in class 1, class 2 or class 3 or class 4, right? It is very simple, but the reason why it is called as regression, it's because of this equation again. See, it's because of the same equation. We are using the same equation in logistic regression also, which is the linear regression equation. Now, you must be thinking, if we are using linear regression, how do we predict the class? We can predict the output if it is continuous variable using linear regression. How do we predict the output which is discrete, right? So for that, what we do, we implement something called a sigmoid function. So first of all, the sigmoid function, what it is, I will let you know. The sigmoid function is equal to 1 by 1 plus e power minus, say, x in minus x. This is a real equation of sigmoid function. But in our case, we are just replacing that x with this y. Okay. And that is, the sigmoid function gives us the probability. Okay. So the value what we get, it will be based out in the form of probability. Tell me something, will this sigmoid function be ever greater than 1? Will it be ever greater than 1? See, I have a function which is something like this. Substitute some random values for x and calculate the value of this. Can we ever get the value of this function greater than 1? No, right? Because you can substitute whatever value you want, but it will be never greater than 1 because your numerator is 1 and the denominator is greater than 1, right? Now, tell me, can it be lesser than 0? Can the value of this be lesser than 0? Yes or no? No, right? Why? Because that too, it can only reach 0 when x is, it will be always positive. Yes, that's correct. So it will be never greater than less than 0 and it cannot be greater than 1 because your numerator will be always lesser than your denominator. In the worst case, it can be 1. So it will always lies between 0 to 1. Now if you substitute some values of x and if you plot it, you will notice the graph of a sigmoid function will look like a S curve. It will look like something S curve. Okay, S. It looks like a symbol of integration, right? Oh yeah, but then it is S shape. Okay. So as the values are ranging from 0 to 1, and we also know the probabilities are also ranging from 0 to 1. So this can be considered as a probability values, right? So as I already told, now the reason why it is called as regression because of this linear regression equation, and with the help of probability values we actually tell the class. What do I mean by class? For example, the red color dots are of one class and the green color dots are of one class. So let's say I have a data set where I have multiple inputs again, and the output is, we have to predict by looking at, say, just imagine the different configurations of air conditions. We have to just predict the class of the air condition, whether it is a split air conditioner or window AC, right? You all understand what is window AC and split AC, right? So based on that, we have the different data set. Now we have this many data sets. Let's assume 1 denotes all the split AC and the 0 denotes window AC. Okay. So we have the different data sets with different inputs, and the output is whether the AC is window or split, right? Now, as I always tell, the first step is to do descriptive analytics, which is exploratory data analysis. Again in coding also. The second step is divide the data into training data set and test data set. In descriptive analytics, you know, right? All the EDA, graph, everything will come in the first step. And the third step is you have to implement that one function. For yesterday, if you remember, for linear regression, we have used linear regression. Similarly, for logistic regression, you will be using logistic regression. Okay. So, but how do we decide of which class it is? So now we have understood our output is the probabilities value, right? So if your output is in general, okay, in majority of the cases in general, if the probability value is greater than 0.5, then it is assumed that the new data will fall under class 1. If the probability value is less than or equal to 0.5, then the new data for which we are doing the prediction will fall under class 0. So for logistic regression, not even logistic regression, in most of the cases, sigmoid curve will always gives you the value, the output of the sigmoid function will be the probability values, and it will be always lying between 0 and 1. It's not just because it is lying between 0 and 1, it's because the sigmoid curve is meant in such way that it will give you the output would be probability values. So in future also you will come up with this sigmoid function later on in different sessions where you will be using the sigmoid curve, okay, where you will be using the threshold or where you will be considering this as probability values. So I was talking about sigmoid function. So if I want to clear your answer, Naga, you have to understand the loss function for this. Okay. So if you remember the odd, what do we mean by odd? Odds. If you remember that something called as from your college days in the probabilities odd ratio. Do you remember what is odds ratio? It's a ratio between the probability that the certain positive or the certain event occurs and the probability that the event does not occurs. That is called as odds ratio, right? So in general, it is divided as, see the odds ratio. Let me explain you about the odds ratio. I'll just give you the some hint here so that you can understand it in a better way, which is P by 1 minus P. P is the probability, right? So the probability always lies between 0 to 1. That's the reason for the probability to occur, any event is P divided by the probability not occurring is 1 minus P. So far so good. So if you could recollect this odds ratio, the way we have done, it's not just because 0 to 1, but I have just given that as an example because it was easy to understand. But if you want to go into very deep of logistic regression, it will take a lot of time. But I'm just giving you the hint so that you can go back and explore yourself. Okay. So there is something called as odds ratio, which is P by 1 minus P. So there is something after this, there is something called as logit function. Logit function is apply just log to this odds ratio. Okay. So when you apply logit function to this odds ratio, you will notice that somewhere down the line, you will come up with this equation. When you apply log to this odds ratio, that is a logit function, which is also on this name logit function, logistic regression has come up. So logistic, because of this logit function only, the name is logistic regression. Okay. So when you apply log on the odds ratio, which is log of P by 1 minus P. So log of A by B is log A minus log B. So then you know it will be log P minus log of 1 minus P. And when you expand that, you will notice you will get the equation in this term. Okay. So that is where that is the reason that it is giving us the probability values. So I just didn't wanted to go into big detail because that would become a very advanced thing. But you can always go back and explore it on this. Okay. So you have to again do the same thing. What we have done here, the gradient descent method for the loss function, and this is the loss function, right? In the linear regression. Similarly, you will have the loss function in logistic regression also. Okay. So which you have to understand and then you have to work on that, and then at the end you will understand how we got this value and why it is denoted as probability. Okay. So but we can have a separate session on that in future. I believe there will be a very advanced session on logistic regression and the linear regression, different machine learning algorithms. There will be very advanced session for each algorithm, I believe. Now this probability value is like a sigmoid function because it is using the sigmoid function equation, and based on this p value, this is the curve which we will be getting. And if the p value is greater than 0.5, it goes into class 1. If the p value is lesser than or equal to 0.5, then it will be in the class 0. Okay. So let me explain it to you one more time. See, in simple language, you have y, which is using linear regression, right? Which is a plus, let's say a1, let's say a naught. Okay, a naught, a1 x1, a2 x2 plus so on. So this is our linear regression equation, right? Now what we are using, we are applying sigmoid function on this, sigmoid of y. So the sigmoid function is itself is 1 by e power minus y. So I have to substitute this y here, 1 plus e power minus a naught plus a1 x1 plus a2 x2 and so on. So I'm just replacing y with these values, right? So what I was talking about was odds ratio. So let me not bring in odds ratio now because odds ratio is a complicated topic. So let's not focus on this now because this will anyways be covered in the future sessions. Okay. So let's not worry about this. Okay. It's just that you have to apply log and all. Let's keep it aside. Let's think in this way as of now, that this sigmoid function will give us the probability values, right? So the final probability is 1 by 1 plus e power minus a naught plus a1 x1 so on, right? Now what is a naught, a1, a2, h3? It's again, these are all again coefficients, right? So similar to linear regression, you have to derive, you have to come up with a naught, a1, a2 again, similar to linear regression, where we were trying to determine the m and b, the coefficients and the intercepts using gradient descent method. Similar to that, here also we have to do the same thing, okay? But I am not going into that detail because that is anyways covered in the future advanced session, okay? So it's very simple now to understand that. For example, let me take some x1, x2, x3, let's say y, okay? Let's say your y is whether your AC is split AC or window AC. Let's take your split AC is denoted as 1, window AC is denoted as 0. Now you have different input features. Input features could be the power, right? So let me take the power, I'm not sure. Let's take the power. And then what could be x2? Dimensions. Let's take the dimensions. What could be x3? Could you tell me what could be the basic difference between split AC and window AC? So what I was talking is, let's say x1 is your power, x2 is your dimensions of the AC. Let's say x3 is how efficient is your refrigerator based on maybe some other properties. You have some efficiencies, let's say, of your, not refrigerator, sorry, my bad, air conditioner, okay? So by these three values, by these three inputs, we know whether our output is split AC or window AC, right? So we have to train our machine learning model on this data. And how our machine learning model is getting trained? Using logistic regression. We'll train our model, our logistic regression on this data, okay? So once our logistic regression is trained, okay, with this historical data or the past data, so whenever we get a new data with some power, dimensions and the efficiencies value, what we will determine, we will predict the probability value. So if the probability is 0.5 less than or equal to 0.5, then it is considered to be 0. If it is greater than 0.5, then it's considered to be 1, class 0 and class 1. So the output what you will get from the logistic regression will be the probability values. Based on the probability value, it will be identified as whether it is 0 or 1. Okay, so if the output of this logistic regression is, say, the probability value is say 0.1, then you can tell that the output, the prediction for this new data which is coming in, the AC would be window AC. I'm just giving you some examples, okay? So, okay, with this power and dimensions and efficiency, if some client comes to you and asks what kind of AC we should manufacture, then you should tell that we should manufacture window AC because we have a lot of different window ACs with the same configurations, and that would be easy to put in the market. In this case, it is telling you the probability of split AC, probability of Y output is equal to 1, probability of output being 1. Okay, so higher the probability value, consider that it is class 1. Lower the probability value, it is considered as class 0. Okay, again, I just wanted to tell you that there will be a separate loss function for this. It's not the same loss function as we have in linear regression. If you want to explore, you can do that, but or else you can wait for the advanced course for this. Okay, so now there is one simple example which I have taken here. Okay, so it's pretty straightforward. You have a data set with age, different people with different age, and whether the person is married or not married. Simple. So this is a binary problem. Why is it binary problem? Because the output has only two classes, 0 or 1. Class 0 is considered as not married in this case. Class 1 is considered as married, right? So now if you have more than two classes, how will you work? See, Python will work for you. It's okay. You can directly implement. If you have more than two classes also, Python will work for you. But there is a separate logic which is called as multinomial regression, where there will be a slightly separate logic. It's just an extension of this logistic regression. You will have three classes, say 0, 1 and 2, and then there is a just slight extension of this logistic regression. So you have to explore about that, or else maybe we can discuss that in the future sessions, okay? But for time being, for logistic regression, where you have only binary classification, whether it is binary or multinomial, Python will do it easily for you. Same code, you have to just write same code. And for mathematics, you have to do some extension on that. There will be a slightly extended mathematics on that. Okay. So if you notice, for the age of a person, if it is 25, 26, 27, 28, then the person is not married. And it's slightly logical also, right? See, in this case, the data is very small. I'm able to interpret directly. But if the data is huge, then you have to do descriptive analytics, right? Exploratory data analysis. Then only you can understand whether the data is making sense or not, right? So for that, now I'm just doing it directly because the data is very small. Lesser age considered to be not married. With the age around like 30, greater than 30, married, which also makes sense, right? As per current era. So if you plot that on the graph, it will look something like this, right? Now, there is a new data which comes in, for example. So this is very important, okay? Now what we are trying to predict is the probability value will give you whether the person is married, okay? We always predict in logistic regression, we always predict whether the probability of y is equal to 1. We are trying to predict the probability for y is equal to 1. Y is output. So if the probability value is greater than 0.5, then it's straightforward, person is married. If it is less than 0.5, person is not married. Now you must be thinking, where is this magic number coming in? Why the threshold value is 0.5? Why it is so important? Now you have to understand. To explain this, it will again, I'll just try to give you some hint here. Let's do some analysis here. Now let's take an example. Okay, now it's very important, guys. It's very important. Try to understand this. Its name itself is confusion matrix, okay? Its name itself is confusion matrix. This looks something like this. For a binary logistic regression problem, it will look something like this. So let's say this is your actual, this is your predictions. Now let's say whether the person, we have to predict, say for example, let's take one more example of say x1, x2, x3 and y. There will be multiple inputs, okay? X1 denotes the age of a person, okay? X2 denotes salary of a person, okay? X3 denotes the gender of a person, okay? Now y is to predict whether a person has car or no. Now say you have 100 data points which you have splitted into training data set and test data set, okay? Say in training you have 70 data points, in test you have 30 data points. Now say this is your actual ones, your actual zeros, predicted ones, predicted zeros. So in linear regression, how did we predict the accuracy? Using R square, right? In logistic regression, How do we predict the accuracy? Simple. It's by how well we are predicting the output, right? That means, let me rephrase my question by using this confusion matrix. Okay, this is very important, guys. It will be your interview question. So for example, okay, on this 70 data points I have built a logistic regression. Okay, and in this 70, say I have 40 ones and 30 zeros. In this 30 test cases, say in 20 I have ones, in 10 I have zeros, right? So let's take this. So what do we think? If we are in actual, if it is 40 ones, we assume that we should also predict 40, predicted ones should be also 40, right? If the actuals are 0, the predicted ones should also be zeros, right? So I'm creating a confusion matrix for only training data set. Okay, 30. Okay, now can it happen? See, it's very rare that you get 100% accuracy. It's very difficult to achieve this, right? In real life, what you would notice is this. Say the actuals are total are 40 for ones, for zeros it is 30. Now the actuals are ones and the predicted are also ones, which are say 30. That means ones are correctly classified as ones, right? Say some of the ones are incorrectly classified as 0, because it's very rare to get 100% accuracy in a real life project. Now out of 30 zeros, whether the person has a car or not, so whether say 30 people were not having car in the training data set, say we have predicted correctly for 25 and for 5 we have incorrectly predicted. Now could you please tell me what could be the accuracy for this training data set? Simple common sense. Can you tell me what could be the accuracy for this model? How is it 75%? So no, it's not 30 by 40, but it's good that you understood that. So you are just telling the accuracy for only ones, but accuracy will be based on the classification of 1 and 0 both, right? So how many are correctly classified? 30 plus 25 divided by the number of data set in the training, which was 70. So it was 55 divided by 70, right? So now you should remember these terminologies. It will always be there in your lifetime if you want to become a data scientist. A 1 is always considered as a positive case. So actual 1, predicted is also 1, is called as true positives. Actual zeros, predicted as zeros, are called as true negatives. Okay. Actual 0 predicted as 1 is false positive. Actual ones predicted as 0 is false negative. So the accuracy formula is true positive plus true negative divided by true positives plus false positive plus false negative plus true negative. It's very simple to understand, but you have to remember these terminologies, because in interview they might ask what is true negative. You have to tell that negative events, or just say that the events which are of class 0 are correctly classified as 0, right? So what are false positive? So the ones which are incorrectly classified as positive events. What are false negatives? The events which are incorrectly classified as negative events, right? So as the class progresses, you will understand which is severe. See, for us, we have to minimize f and false negative and false positives, right? We have to minimize this. It's our objective, right? Our ultimate goal should be, our accuracy should be high and false negative and false positive should be as low as possible. But as the class progresses, as the session goes on, once you complete this course, you will come to know it's not every time that accuracy is important. You might have to look for false negative or false positive also. For example, in this case, let me give you one simple example. See, it's good that if we can minimize false negative and false positive, but we should know which one we have to minimize more, okay? And how to minimize that we'll look into later. But now what we are discussing is which one should be minimized? That's important. Let's take an example which is of a clinical trial. For clinical trial, the accuracy should be very good, right? Say now our confusion matrix, say this is malignant cancer which is considered to be 1, let's say, and this is say, or this is your benign cancer considered as 1 and malignant cancer which is considered to be 0. Okay, now for this example, say you all understand this benign cancer and the malignant cancer, right? Malignant cancer is the one which is more harmful. Say if I have here say 10 and here I have say 20, okay, with one of the logistic regressions or one of the classification problem, I got this as 10 and this as 20. You understood it, right? 1 0. So false positive as 10, false negative as 20. Now let me give you one more example of same clinical trial, same benign and malignant. Say this is 20, say this is 10. Say this is case A, this is case B. In case A we have used say logistic regression, in case B we have used some other classification algorithm. Let's not name it now because you have not learned it. Let's say it's some other algorithm. Now tell me which is more severe here. Leave it about true positives and true negative. Tell me which is more severe in this case. See, the point is here, say malignant cancer people are predicted as benign cancer, right? That means, see, first of all, it's important. The one which is more harmful is predicted as less harmful. Say here in this case, the benign cancer is predicted as malignant cancer. That means the less harmful cancer is predicted as more harmful cancer. So that's okay. What the doctor will do? Doctor will do the separate checkup, all the different tests for all these people, 20 people. But for this 10 people who were predicted as less harmful cancer, like what happens in a clinical trial, what they would understand that what they would think is this 10 people has less harmful cancer, right? But in case B, there are 20 such people who are having a malignant cancer but as predicted as benign cancer. So case B is more severe, right? So for this case, false positive is the one which is of important criteria which we have to minimize, right? Otherwise, if doctor goes with the prediction, they might not do the separate different test for this 10 people. And then you know what could be the end result, right? So which is wrong. So here the objective is to minimize the false positive rather than increasing the accuracy. The important thing is to reduce the false positive. Okay, it's okay if we have more false negative for this example, right? If we have more false negative, it's okay, because then doctor will be extra conscious on those patients. That's it. And they will do extra test. It's just a matter that they might have to spend a lot of extra money, but they at least they will not lose the life, right? It's a matter of life here, right? So it's important that we should understand for which kind of problem, which parameter is very important. Is it true positive? Is it accuracy? Is it false positive? Is it false negative? Did I clear some fundas by taking this example, guys? For our engineer examples, it's very simple. So why will there be error again in the training data set? Right. So see, for example, this is your training data set. Okay, let me give you one example. There would not be, for simple problems, if you do it manually, you are doing a classification of whether a person has a malignant cancer or benign cancer using manually by looking at all the reports and different stages you're looking at, and then you understood that manually doing it by a specialist doctor, the error is 0%. right? But when we are making our machine to learn this using algorithm, okay, then it's not necessary that you will get a 0% error. 0% error is your very optimal result, right? It's your base by which you will compare. But machine cannot get accuracy of 100%, right? Because it's a machine, right? We will always try to achieve this accuracy towards 100% and or the error to 0%. We will always try to do that, but it's not possible. Okay, let's take for example, okay, say in this case, say there is one more person, say of the age 24, let's say of the age 24, okay, and say the person is married. Now when we train the model, 24 will be somewhere here, agreed? 24 would lie somewhere here, right? I'm just plotting it. So 24 would be somewhere here. So by looking at this graph, we can assume that this person will not be married. There can always be extreme cases, right? So for which it is very difficult to predict. Those cases will always improve the error percentage. See, manually you can always think the error would be 0%. But in some cases also, believe me, manually also you cannot achieve 0%. Okay. So by this example, I'm just trying to tell that it's not necessary for the training data set you will get an accuracy of 100%. You will always try to bring the accuracy to 100%, but it's very difficult. Okay. You always try to achieve a better results for training data set. So for example, you apply some algorithm, say A, you got some training accuracy, say 90%. With algorithm B, in the training accuracy you got 95%. Then what you would do is, you would test this on the test data set also. If the similar pattern is observed on the test data set as well, then see, in our case, both training data set and the test data set are historical data, right? We are just for our analysis, we are splitting test and training data set. Okay. So if we are looking at the same pattern for both training and test data set, then what we tell in the future, for example, in the future, if we get any data, then we will use algorithm B. Then we will go with algorithm B. Okay. So to give you one more example, okay, you have a training data set. X is, say, whether it is in X you have images. In Y, our output is whether it is cat or dog. Suppose you got the data set with 100 images. Okay, you got, let's say you got this data set. Image 1, image 2, image 3 and so on. Say this is cat, this is cat, this is dog, this is cat, so on. Right? See, in this data set, we already have the labels. Okay. What we are doing, randomly using random sampling, we are taking 70% of the data as a training data set. Now in training data set, you have, say, some 70 images. Okay. These 70 images will look at its output. Okay. Okay. See, we already have the outputs here. So that's the reason we are calling it as supervised learning, right? So it will look at this output. Okay. The algorithm will be built on this training data set. Okay. Based on that, it will predict. Now, once the algorithm is built based on this output labels, first it will predict for the training data sets also, right? Say for 69 images, or let's say for in actual results, we already have 100% accuracy because we have already labeled them. But our algorithm is built based on looking at the actual results. So let's say it has predicted well for all the 70 images except for one. The reason could be blurry image. So for a blurry image, imagine it, it's very important. Okay, let's imagine that you have a blurry image. For a blurry image, for a human being is very difficult to identify whether it is a cat or dog. It's just that you got in actual, you have labeled it with the help of some, say, animal lover. Okay, with the help of some animal lover, you have labeled all the images correctly. But if there are some blurry images, just imagine if a normal human being is able to distinguish whether it is a cat or dog, how will a machine distinguish it? Your algorithm is built on training data set. How? By looking your output labels. With those output labels, the algorithm is built. Now, once the algorithm is built, we are now implementing the same algorithm on training data set first to understand whether our algorithm is able to predict well or not for training data set itself. Okay, say, let me give you one simple example, very simple examples. Let's say you have 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Say you have ones, something like this. I'm just trying to give you one example here. Okay, now you have 1 0 here. Okay, concentrate, it's very important. Now if I want to distinguish these two classes by a single line, how will I do this? By the single line. So I have built an algorithm which differentiates these two classes. Now if you notice, for this extreme cases, this is incorrectly classified. Now to make it correctly classify, what should I do? Say I have 0, 0, 0, 1, 1, 1 and 1 0 here. Then the classification should look like, then I should classify like this curve, right? I should use curve, right? Exactly. Now, so what happens while doing this? So this is important, okay? We have tried to increase the accuracy for training data set. And the algorithm which we have used with this, it will have different characteristic, and this algorithm will have different characteristics. Both the algorithms will have different characteristics, right? Now there might be a training data set accuracy, say the training accuracy is say 90% with algorithm A. Here the training data set has an accuracy of say 100% with algorithm B. Okay, now we have to implement this on test data set. You don't worry about the curve based regression now. Okay, anyways we will be looking at curve thing by using different algorithms, but don't worry about the polynomial regression, that you can always use. Okay, but I'm not teaching that in this course. The other curved classification type which we will be learning are different in this course. Okay, so don't worry about that. But let's take curve to explain you in a better way. Let's take curve only. Now in algorithm A and algorithm B, what we are doing here is we are building an algorithm, different algorithms, such that here there might be at the backend very simple equations. Let's assume that there is a simple equation. Okay, don't worry about the linear regression because it's a classification problem. Regression will not be helpful here. Okay, first of all. Second thing, here we are using some other classification technique and we are classifying 1 and 0. So this looks very simple, this looks complicated. First point. Okay, second point, say for training you got a 90% accuracy with algorithm A. For test also you got say 89% of accuracy. Okay, now in training you got 100% of accuracy using algorithm B, and in test data say you got again 89% of accuracy. For your sake Naga, let me just increase the accuracy for this. Let's say it is 92%. Okay, see what you are thinking is we already have the label for training data set based on which the algorithm is built, but then that algorithm has to predict again for the inputs what is the output. But anyways, that point will be cleared by looking at this simple two cases. The first thing was in case B, algorithm is quite complicated, difficult to interpret. Second thing is the training data set error or the accuracy and the test accuracy is more or less same. Okay, and in the second data set you have complicated your algorithm so much, inclined towards your training data set. You have done so much calibrations or you have changed so much in your algorithm that your algorithm is giving you the accuracy of 100% for training data set, but for test data set it is giving 92% only. So now in data science area, case A is preferred than case B. I'll tell you why. Anyways, this was supposed to be discussed in week 6th or 7th, but anyway, I'll tell you the reason why. Because let's say this in simple English terms, your algorithm is able to generalize from training data set to test data set. That is the reason there is a consistency. For algorithm B, you have already tweaked your algorithm so much to give 100% of accuracy for training data set that for test data set you are getting 92% of accuracy, which is better, but that is not considered to be better because your algorithm is not able to generalize in a same way for test data set as it has done for training data set. So your algorithm is not able to generalize from training data set to test data set with algorithm B. But for algorithm A, it is able to generalize. Okay. So whenever we build the algorithm on the training data set, it's just that you will take one algorithm, it will look at the training data set, inputs and outputs. Based on that, it will come up with some equations at the back end. Okay. And then it will again predict for the training data set, and then we will look at the accuracy for training data set and then for test data set. If you try to improve the accuracy for training data set, say 100%, then you should make sure that for the test also it is near to 98 or 99%. Then only we can tell that our algorithm is able to generalize from training data set to test data set. Otherwise, it will be a risky case for us. So the cases which we are talking, when the accuracy for training data set is very high, but it is not able to generalize for test data set, then it is called overfitting. It is called overfitting. Overfitting in the sense, you have tweaked your algorithm at the training level so much, you have fitted your algorithm so much at the training level that it is now considered to be overfitted now for training data set, such that it is not able to generalize for test data set. Okay, this is called as overfitting. Now there is something called as underfitting also that we will discuss in later sessions, because I want to discuss few more things here. Anyways, so for binary classes you can always look for the accuracy using confusion matrix. So going back, how to do this in Python? Okay, same thing, NumPy, pandas, matplotlib, scalar, same thing, import linear model. Now don't worry about all the different things. You can use the pandas and you can import the data frame which I have explained you yesterday. Once you import the pandas, the line which we will be changing here, if you remember from yesterday's example, it was reg equal to linear underscore model dot linear regression, right? Here there is one simple difference. You don't have to worry about this. This will come under advanced things if you want to write anything under brackets. So it's just that you have to write linear regression equal to linear underscores model dot logistic regression. Instead of linear regression, you are writing logistic regression. And as I told, reg is a variable. I can use anything here, right? So in this case, I have used CLF underscores multi. It's okay, it doesn't matter. You can use anything. That is the only one difference. And score, yesterday if you remember, for linear regression, how did you predict the score? Reg dot score, variable dot score. Here also, variable dot score, simple. Okay. Now, the important thing which I wanted to tell you is we have to split our data set. See, I will not be running the algorithms in the class. You have to practice at your home, and then if you have any questions, then we can discuss in the doubt sessions. There will be separate support sessions on the doubts. There we can discuss. Here I'm just telling you the method how to write it in a Python coding language. So before implementing logistic regression, we have to split our data into test and training data set, right? It's very simple. You can do, if you have say 100 data, you can directly take 70% into training using top 70% of the data, top 70 data, and last 30 data into test data, right? 70-30. But then by this you are biasing your data set. If you remember, this is not a simple random sampling, right? We should always use probability sampling methods. We should not use non-probability methods. So what is a simple random sampling method says? It can be every event or every sample has an equal probability of getting selected, right? So from sklearn, there is a separate function inside sklearn. So I have written sklearn dot model selection. If there is one more function inside, then I would have written dot something. But I already know. So this thing will come to know by practice only, guys. Okay. Even I also sometimes get confused, so I will use the help of Google. This function train underscore test underscore split is a function which is inside of model selection, and this model selection is inside library called sklearn. Okay. So now what I am doing, we have the data set X and Y. Now we have to separate that X and Y into train and test. So for training data set, you will have X train, Y train. For test data set, you will have X test, Y test. Okay. And this will be the same terminology which will be used till end of the course. Okay. Whenever you are going with supervised learning, you will have the same terminologies. X train, Y train, X test, Y test. Did you understand this 38 highlighted one? We have 4 variables now. Now, these 4 variables get the different random samples. How? Say, this is the function which is already inbuilt for simple random sampling, train underscore test underscore split, and then you have to write the dataset name. But for in my case, the dataset's name is, or the data frame name is digit. It's digit. Yesterday's case, it would be area, bedroom, and age. So this is say our data frame. This is our data frame. Then X would be area, bedroom, and age. Y would be price. But for this example, I have taken X as data, only data, one column, which is X, say data, and Y is one column, which is say target. So if you want to compare from the previous example, you can write it in this way also. Simple. You can take the same example and you can write it in the same way here. You can write it like this also. I'm just taking different data sets so that you can get used to it. So this is your X, this is your Y, and how much percentage you want in test data set. Say if you want 0.3, that means 30%, then it will automatically adjust 70% into training data set. Okay, these are just arguments, okay, inbuilt argument for this function. If I'm writing 0.3, then 30% of the data will go into X test and Y test based on what is input and what is output, and 70% of will go into X train and Y train. You can print and check it if you want. Now the important thing is, what is the significance of this random state equal to 5? What is the significance of this? It can be 1, it can be 0, it can be 100, anything. It can be anything, any integer. I'm just writing 5 for my analysis. So let me tell you what is the significance of this. What happens if you don't write that? Say I have 10 data sets. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Say this is X. You have lot of X1, X2 and so on. Let me just write X and Y. Now if I use 70-30%, say in my test data set I am getting 2, second index, fourth index and 10th index. Okay, because 30%, right? So 3 data points. Now say if I don't use this syntax of random state, say if I don't use this in my analysis, then if I run the algorithm again, then there is a high chances that it might choose different 3 data points in test. Say this might be 1 now, 2 and 4 in the test data set. If you run it again, there could be a chance that it might choose 2, 3, 5 or 5, 6, 7 something. But if I'm by writing this random state, just by writing random state, you are making sure that by running your code again and again, you are making sure that in your test data set you always have 2, 4 and 10th index observations. You have only these 3 observations. This observation should not change because it's a random sampling, right? It might change. So but for our analysis, once you do the random sampling, it should not change, right? But we have to run the code again and again, so it might change again and again. So for that you have to just write random state. So you can write 0, 1 or anything. If you write 0, you might get 3 different samples. If you write 1, you might get 3 different other samples into test data set. If you write 2, you might get 3 different samples into test data set. But whatever you write 0, 1, 2 or some 99 or 98, but you should write for that one Python file, you should maintain that consistency. Otherwise you will get the slightly different results. Every time when you run the model, you will get slight different result because every time you are taking different samples into test data set. Did you understand the significance of random state? Right. So now we have 70% in training, 70% of Y in training, and then 30% of X in test, 30% of Y in test. So now we have 4 variables. Okay, so I have assigned logistic regression to one variable, like yesterday only. Like yesterday, I have to do variable dot fit x comma y. Yesterday we didn't split, if you remember, training and test. Today we have splitted it. So variable dot fit x train comma y train is built on training data set. So now if you look further, what you want to do is you want to predict for test data set, right? So what you can do is just write new values for y predict, variable dot predict, give some new x test. We already have the x test, right? From here. just give those X test here, and then you will get Y predict. Okay, we have given some random new values, right, for testing yesterday, like this. But in this case, we have already split it training and test. So I'm directly incorporating test here. Okay, and that is assigned to Y predict. Now for the test data set, you have Y predict and Y actuals. You have Y predict and Y actuals. Now again, you can form a confusion matrix out of it. You can form a confusion matrix out of it. And then you can calculate the accuracy. And that accuracy can also be given by dot score. If you want to predict the accuracy for training data set, that also you can do it. So from the previous session, everything is same. It's just that we are splitting the data in this case now. So from now on, whenever you do the project on machine learning, you should start splitting your data set into training data set and test data set. That is the first step. Second step, build your model on the training data set. Third step, predict your new outputs for the test data set. Fourth step, calculate the accuracy for test data set. If you want to calculate the accuracy for training, you can also do that for the same. Okay. Now, if you want to visualize this confusion matrix, then what you have to do, from Skill-Lync, there is a separate function or module which you can import by name metrics. In that matrix, what you have to just assign a new variable cm metrics dot confusion matrix, which is a function. And we know confusion matrix is built on output values, right? Predicted outputs and the actual outputs. So Y test and Y predict. And then you'll get a confusion matrix. So this will give you confusion matrix. So what is the first step? Import the necessary modules or the libraries. Second step, import the data using pandas. Third step, do the lot of exploratory data analysis on that data set or the data frame. Try to gain as much as knowledge from that data set. Try to absorb that data set so that using your domain knowledge, you should be able to understand the data, which would be helpful when you predict something in the later part of the coding. How will you give the data? Just assign this new data to df. Say I have given you a data set in Excel format or CSV format. You have to just import that CSV format using pandas. This is the syntax. pd.read_cv and then import that CSV or Excel file. From 6th week, you will get the data sets. But till now, till 5th week, you have to do a lot of mathematics on the pen and paper only. You can get the intuition about what is this all about machine learning and how we are going forward with machine learning course. That's the reason I've given a lot of mathematical questions in the challenges, pen and paper questions and coding. But from 5th, 6th week, you will get the projects with the data sets. Okay. So now important thing to note here is how to import the CSV file or data set that is stored in the data frame. Then play around with that data frame. Then split that data frame into test and training data set. Build your model on the training data set. Okay. And then do the prediction for your test data set and calculate the accuracy using the score function. Or you can, if you want to visualize, you can visualize using confusion matrix. Till now we have learned only 4 libraries: NumPy, Pandas, Matplotlib and Skill-Lync. There is a separate library by name Math. For example, there is a separate library called Math in which you will have some mathematical functions if you want to do it. It's up to you. So these are the 5 libraries which we have used till now, and there will be 6th library which we'll be using in the future session, which is TensorFlow. But let's stick to these 5 libraries. And if you can play around with this 5 or 6 libraries, then you can become a data scientist. And you don't have to worry about other libraries now. Data scientist and machine learning is built on only 5 or 6 libraries. And in future, if you want to go for advanced analytics, then you can have a lot more different libraries. But to become an intermediate machine learning engineer, this is enough. Okay, so going to the challenges. Derive log loss function, gradient descent on paper and replicate it in Python. So if you're not able to do this first problem, it's okay. But log loss is very simple. You have to just apply log. But if you're not able to do it, it's okay, because anyways we'll be doing it in the advanced sessions. What are the different loss functions for classification? I have already told you one is log loss function. Don't worry about first and second. If you're not able to get it, it's okay. I want you to give a try. Third problem, what is one hot encoding? Okay, this is important. I have taken one example. No, say there was one example like this. X1, X2, X3, Y. So X1 is age of a person, X2 is income, X3 is a gender. Let's say in the gender, I have male, female, so on. Your algorithm cannot read these categorical variables. It's better if you convert your categorical variables into numbers first of all. That would be a better way to do it. It will be better if you can convert your categorical features into numerical features. So it's very simple, right? You can write male, female as 1 and 0. Male as 1, female as 0, or female as 1, male as 0 as per your analysis. But you have to maintain that consistency in your analysis. So converting that categorical into numbers are called as dummy variables. Okay. So from this dummy variables only, did you understand dummy variables, guys? In terms of mechanical example, say if you have one column as say vehicle name, say Audi, Mercedes, Porsche, you have say different names, and you want to use this in your analysis, then it will be better that you convert your categorical data into numerical data using dummy variables. Okay. Now, say if you have two categories, then you can just split that into 1 and 0. Say if you have Mercedes Benz, Audi, Porsche, for example, there is one feature or column where you have three different names. Then you can use 1, 2 and 3. And then you can replace that feature or the column with this 1, 2, 3. This is called as label encoding. Okay, these are just terminologies. Similarly, there is one more terminology, one hot encoding, which I want you guys to work on it and come up with and tell me what is one hot encoding. I'll be asking you in the next class. Okay, and we'll be looking into this log loss function also in the next class, so that once we go into the advanced course, you should have some knowledge about this loss functions. Okay, whenever I tell something, no, try to do that on paper using pen and paper, and that implement that the same thing on the Python. By that you will not forget things. Okay, because in Python everything is just like a 1 or 2 lines of code. If you do it by using pen and paper, then you will remember for lifelong. Okay, so that was all which I had for today's session. Okay, thank you guys, thank you so much. Let's catch up on next Saturday.
Welcome to the next session on Introduction to AI and ML using Python.
In the last session, if you all remember, we were actually going through with linear regression and the logistic regression. We have also discussed when to use linear regression and when to use logistic regression. So these are the two popular machine learning algorithms, and these are the two where you can actually look for a lot of mathematics in it. So for linear regression, I remember that we have discussed in and out about the mathematics of linear regression. But for the logistic regression, I know that we have not discussed that yet. So that would be coming in the advanced session, because that would require a lot of maths and it requires some time to understand. So it's not very straightforward. So that was the reason I have not taken that. But I thought I'll give a question in the challenges, so that if someone knows the answer, if someone can explore it on the internet and then come up with the answer. But I don't expect the answer, to be very honest, because anyways we'll be training you on this in the coming sessions, in the advanced sessions. But if you want to give a try, you can always give a try. Yes, so similarly, I just start with second question because first question will take a lot of maths. And if I start that now, I think it would require complete 1 or 2 sessions. So starting with second question, did you look into the internet or like some of the books? What are the different log loss function? What are the different loss functions for classification, logistic classification or logistic regression? If you remember, for linear regression, I have told you about mean square error as a loss function, mean absolute error. You can also have mean square error, similarly, so on. So I'm just trying to revise and recap so that I can understand if you guys are doing your homework or not. So did you try finding the solution for the second question, guys? Second question is very straightforward. What are the different loss functions used for logistic regression? Or let me just change this, otherwise you might get confused with the logistic regression and classification. Classification is a problem. Logistic regression is a machine learning model which is used for solving the classification problem. So yes, you are right. There are different losses. You have mentioned some of them, but in detail, we will be looking at this log loss function in the advanced session because this is the most used one. Similar to mean square error, which we use majority of the times for linear regression, similar to that, log loss is a function which is used majority of the time in the industries. So we'll look into that in the future, but it's okay. But yes, third and fourth question. Third question, I think I have explained in the previous session also. Did you try what is one-hot encoding, guys? So what happens in real life, you will not be having all the input feature data as numerical data. So some of them are categorical. See, for example, you want to predict the price of a car. Okay. So how do you predict the price of a car? First thing, maybe the engine configurations. Second thing, maybe the chassis or BIW configuration, or maybe the tires configuration, maybe the quality of brake, maybe if the car has the different feature of like how is the suspension of the car, does the car have the airbag system or not. All these features will decide what could be the price of the car, right? If you go for buying a say car of BS4, that would be less costlier than BS6, right? And if you are buying a car, you notice the windows will not be having the automated roll ones. Automated roll ones in the sense, there is one knob. If you push that knob, automatically windows come down and windows goes up, right? That facility will not be there for some of the cars at the rear end. You might have to pay an extra amount for that. Whenever you are going to a showroom, you can notice that. And then price also depends on the models of the vehicle, like models in the sense, for example, there are two different cars, say X and Y, both has the same feature, but both are coming from the different clients or different customers. Do you think both the price will exactly be same? No, right? It depends on the brand, right? It depends on their advertisement cost also. So there are a lot of things which are involved behind the cost of a particular vehicle. So let's say in this prediction, I'm talking about prediction, okay, not classification now, but this concept is valid for both prediction and classification. So while predicting, you notice that one of the input features, say the brand of the vehicle has three different brands, okay? One, say BMW, second, say Audi, third, say Porsche. So let's assume that all these three vehicles don't get into technicalities, not get into mechanical technicalities. So let's assume all the three vehicles have the same features, exactly same features, BIW, everything is same. But which would be more costlier? Right, so it depends. So BMW is a higher version, right? So it could be BMW, yes, but Porsche is a further higher version of, in terms of brand, Porsche is even further at a higher level. So whenever you Google it, you will notice that Porsche, Rolls-Royce, these cars will come in the tier 1. Mercedes, BMW, Audi comes under tier 2. But that's okay, it doesn't matter. But you understood the point, right? So it depends on the brand also. So you cannot neglect this input feature which has the brand names such as Audi, BMW or Porsche, right? Second thing, now these are categorical variables. How do I tackle with them? So to tackle with them, we have to convert those categorical variables into numerical variables. And how do I convert that? There are many ways, but I will explain only two ways. The one is label encoding. The second one is one-hot encoding. So in label encoding, what happens? It will label BMW as say 1 or Audi as 2 or Porsche as 3. So 1, 2, 3. So by this you are converting a categorical variable to numericals, right? So this is one way, which is label encoding. Okay, label encoder or label encoding. The second one is one-hot encoding. In one-hot encoding, what happens? Suppose you have a single feature with Audi, BMW and Porsche, right? Now instead of converting that into 1, 2, 3, what it does, it splits this feature into 3, and this new 3 features names will be Audi, BMW and Porsche. So to explain this in a better way, say this is your X1, X2, X3, X4, X5 and Y. Let's say your X4 is a feature which has the brand of the vehicle. Now we have 3 brands in this data set. I'm only considering 3 brands to make the problem simpler and to explain it in an easier way. Say Audi, BMW and Porsche, right? Now what happens? We cannot tackle, first of all, you should understand it's not a good practice to ask your machine learning algorithms to tackle with categorical variables. It's not a good practice, guys. So you should convert this X4 into, say, new 3 variables, say X4 1, X4 2, X4 3. Don't worry about the terminologies. I'm just giving some random terminologies. So this, the feature, the column name would be here, would be Audi. Say here it will be BMW. Say here it will be Porsche. Now, let's say in the previous data, you had this X4 as, so you had say data set with lot of different records, right? So let's take starting 5 records, okay? Of this data set will have millions of records, okay? I'm just taking only 5 records and I'm only displaying X4. So let's say this is Audi, this is Audi, this is BMW, this is Porsche, this is BMW again. Now, label encoding you already understood. It replaces this column with one column, which is 1. If you are denoting Audi as 1, BMW as 2, and Porsche as 3. But what happens in one-hot encoding, it will create 3 different features altogether, right? Now, if I write for Audi, then the first, say this is 1, 2, 3, 4, 5 records. The first one is Audi, so it will write 1. Second one is Audi, it will write 1. Third one is BMW, it will write 0. Fourth one, it is Porsche, it will write 0. Fifth one, it is BMW, it will write 0. Now for BMW, it will write 0, 0. This will be 1. This will be 0. This will be 1. Can you please label your column, third column Porsche? So it will look something like 0, 0, 0, 1, 0. Now, this is your one-hot encoding. Now the fourth question is very important, guys. This can also be your interview question. What is a dummy variable trap? Now, you must be thinking, let's imagine in this way, guys. I have a X4 as a variable where I have a brand. Now, it's important. I have splitted X4 column or feature into 3 columns, right? Now, imagine in this way. The first column is 1, 1, 0, 0, 0, right? And the third column is 0, 0, 1, 0, 1. And similarly the third column. In the first record, if you notice, there is only 1, 1 and the remainings are zeros. Similarly, in the second row also. Similarly in the third. Similarly in fourth and fifth, right? Making sense? So let's say if I give you x4 1, x4 2, can you derive x4 3 or not, guys? Without looking the data also, can you derive x4 3, yes or no? Let's say I have some other data set. Okay, say this is 1, 0, 0, 0. Okay, this is say 0, 0, 1, 1. I have not given you the parent data set now. I am telling you that x4 1, x4 2, x4 3 are the columns coming from one of the features using one-hot encoding. Can you tell me what could be x4 3? Exactly, right? It makes sense, no? So I don't have to tell you anything about x4 3, but still you are able to understand what is x4 3. So what I'm trying to tell you here is this x4 3 is dependent or can auto calculated using the other two remaining columns, right? So your algorithm will be smart enough to calculate this third one. So you don't have to separate out this x4 3. You can remove this from your data set. Okay. Now this is about one-hot encoding, and this is removing that one of the columns is called as dummy variable trap. Because if I give these two columns, indirectly I am giving the third column also to my data set. Okay. So now, why is it important to remove this? I have explained to you what is dummy variable trap. This is what is dummy variable trap. But why is it important? Now, it is important because linear regression and logistic regression both works on very important assumption, which is called as your input features. Concentrate, your input features, that means x1, x2, so on, should not be very good correlated. That means, for example, say if I give you one feature, say as the date of birth of a person. Okay, let's say my new feature x1 is date of birth. My new feature x2 is the current date, and x3 is age. Now don't you think age is dependent on x1 and x2? Because now if, for example, if I have a date of birth of a particular person and if I have a current date also, can't I subtract them and get the current age of a particular person? I can, right? So what we are trying to do here is we are giving a redundant variable as an input variable to our algorithm, or extra feature to our algorithm, and you are not supposed to do that. By this, it will create the randomness in the results in the output. Did you understand this, guys? This concept that your input features should not be dependent on each other, or it should not be very good correlation between input features, right? Now fifth one, what is the difference between linear and logistic regression? Why is this assumption? Yes, so this assumption is important, right? See, for example, you are predicting something. Say it's a normal something you are predicting, say y. Say your output is dependent on your x1 and x2. Okay. Now you are giving one more feature. Say this is your x1. Say this is your x2. Now if I draw something like this, the correlation is very bad between x1 and x2, right? And if I draw the curve like this between x1 and x2, the correlation is still bad. But say if I have the graph something like this between x1 and x2, now x2 is equal to say 1 by 2 of x1. Now x2 is dependent on x1, right? If you remember, we always try to, in our mathematics also, if we know that x2 is dependent on x1, we try to convert that our equation, we replace x2 with x1, right? And then we try to do our mathematical problems in our school days also, right? Otherwise, it will become complicated to calculate y. Do you remember this? Yes. Similarly, in machine learning also, you are not supposed to provide any variables which are dependent on other variables. See, then what happens? Then people will start giving lot of variables, thinking that if I give lot of input features, my prediction will be good. But they will not understand this x4 is already dependent on x1 plus x2. Say for example, x4 is already say x1 plus x2. Then why is it required? If we are putting this in our mathematical equation, this will complicate our analysis. Similarly, in machine learning also, if we incorporate this, our algorithm will calculate the solution. There is no harm in that. It will calculate. But it will, this redundant feature will incorporate the randomness in the result. The results might not be that accurate. Okay, so the assumption is, because if you remember the R square from your linear regression, what is R square? Coefficient of determination. And what is the significance of R square? It signifies how much your output variable is influenced by your input features, right? If your input features is already dependent on your input features, then it's a problem, right? Then you cannot justify by looking at your R square value. You won't be able to tell how good your results are. Okay, so this will come with the domain knowledge. You don't have to worry, guys, because see, for example, I have one column as say area and one column as say thickness. As a mechanical engineer, if I give you volume, you know that volume is not required, because if I have these two, it will automatically calculate volume. Now, if I have a sphere, if I give you diameter and volume both, the information of volume is redundant, because you know that using the diameter, you can always calculate the volume, right? So this is called as feature engineering, guys. And it is very much important so that you can reduce your number of input features in your algorithm. See, if I have 10 input features and I'm running a machine learning algorithm, say it takes 1 hour. It will not take 1 hour until unless you have very huge data, but still let's say that it will take 1 hour. Now, if I know that there are three variables x8, x9 and x10 are which are dependent on any of from x1 to x7, then I can remove those, right? By this, I am reducing the dimension of my data set. And by this, our algorithm will become computationally effective, right? So this thing, you have to remember, this is called as feature engineering. This will also come again in week 7 and 8. Okay. Now, going to decision tree. What do you think? What could be decision tree? A tree which actually helps us in taking a decision. Simple, right? Now, let's say again, decision tree, what I am doing here, decision tree can be used for classification problems or it can be used for prediction problems. You all remember what is prediction problems and classification problems, guys? So the difference between this regression and classification. Regression is generally used for predicting the problem. For example, predicting the price, income, age. Classification is used for classifying the input data into, say, whether the emails are spam or not spam, whether the person is married or not married, whether the car line belongs to Mercedes-Benz or to BMW, whether the problem which we are getting belongs to cantilever beam problem or what all we have. I'm not able to recollect now. Okay, so whether the problem belongs to, say, I would say thermal problem or it's a design problem. So these are the classification problems, right? Now, or whether if you have the data, by looking at the data, whether this component will sustain, whether the break disk will sustain or not. These are the classification problems, right? So these are very important. What do you think number of people entering into a store? Is it a discrete data or continuous data? Discrete, right? But if I look at this problem, say I am predicting, I want to understand how many people are entering into the store today by looking at the past data. So for this, I need linear regression, right? You can say in this way. Whenever you have a data within some range, then you can go with regression. And whenever you are classifying something, such as categorical data, you are absolutely right. Then you can go with classification. But for logistic regression, if I could remember, I told you logistic regression is used for classification, but the name why it is regression, because inbuilt it uses linear regression. So that's the reason the name it has a regression, but it is used for classification. You should not forget that. Okay. Similarly, decision trees and we have multi-talented people, right? Similarly, decision tree is also very multitasking. It can be used for classification problems. It can be also used for prediction problems. But in the industries, decision trees majority, it's being used as a classification for classification. So when it is used as classification, it is called as classification trees. When it is used as regression, it is called as regression trees. Now, in this course also, we'll be looking at only classification tree for decision trees. So to get started, let's say you have some input data. Let's say you have a data set, and that data set has an output, say whether the person is fit or unfit. Simple. Now, to validate our outputs, we will also have some inputs, right? So those inputs are given in this flow chart, what I'm showing you, this tree graph, kind of tree chart. So here, the data set name is a person fit, simple. And our outputs are fit, unfit, fit, unfit, something like this. Now, say one of the input features is age. Okay, let me draw this, otherwise you might get confused. So let's say you have a data set. Let's say your output is whether the person is fit or not. Okay, fit or unfit. So say fit, fit, unfit, unfit, unfit. And this output data is dependent on your some of the inputs. Say this is your x1, x2, x3. x1 is say age, x2 is say does a person eat pizzas, the third say is whether the person exercises in the morning. Okay, so this is your data set. See guys, it's important whenever I give example, I take very small examples and small data set, but in reality that this will not be a case. Okay, anyways, from 6th week onwards you have to start doing projects. Otherwise, you will think that the problem will be so simple only. So now we have to identify the class of our output. So now we have to predict whether the person is fit or unfit. It's a classification problem. So for that, so now the point is, first feature which I am taking, say age. I will check whether the person is less than 30 or greater than 30. Let's say that the age of a person is say 29 here, 21, 40, 33. So what it is doing, we are trying to segregate our first feature now, whether the person's age is less than 30 or greater than 30. Let's say if it is less than 30, yes, then it's quite obvious, right? When we are having an age less than 30, it's quite natural that we eat a lot of junk food, right? I'm just making a general statement, guys, okay? Don't get me wrong. But it's a general statement. And when we are more than 30, it's a general practice that we will be more conscious about our health because we might have eaten so much junk food in our early days, right? So I'm dividing this into yes or no. So now my first data is divided based on this criteria. Okay. Now, if it is yes, then does the person eat a lot of pizzas? If it is yes, then it is unfit. If it is no, then it is fit. Similarly, if a person is greater than 30, then does he exercises? If he exercises, he is fit. If he doesn't exercise, then he is unfit, right? So does this simple flow chart or this simple tree make sense to you guys? It's quite logical, right? Right. Similarly, decision tree also works in a similar way. Now, this is a very simple thing, but very important. Why did I start with the age? Why did I start my root node, the first node? See, you know that our output should be our output, right? So if I had say multiple data sets, for example, say if I had say x1, x2, x3, x4, x5, and then y, then let's say I'm taking a root node as say x2. I'm looking for yes or no. Say I'm doing yes or no with yes. I'm getting say x1 here, and say here I'm getting a lot of say x3s. Okay, and then again I'm checking with yes or no. And then with yes, say I'm getting here x4. Okay, and I am getting here say x5, and all the x3s are directly going into the output. Like that means when a person belonging with this criteria is directly having a rule that it goes into the output y. Say some output y as say 1, and then here it goes to y, the output is 0. Here it goes to a white, which is output as say 1. Similar to fit unfit, right? So what we are trying to do here is we are trying to make the tree with the help of certain rules, right? Now the important thing which you want to understand is this is called our root node. This is called as intermediate node, and this are called as leaf node. So how to decide which one will be the root node? That's an important question here. Okay, so as you can see, I have also given one more example here. Whether the person height is greater than 180 centimeter, yes or no. If it is yes, it's quite logical that like the probability of people having height greater than 180 being a man is more, right? So it's a male. If it is no, then we will look at the weight. If the weight is greater than 80 kgs, then the output would be male. If it is less than, the output would be female. So it's quite natural, right? Now again, when we are trying to come up with this kind of trees, the important thing is how to decide the root node. See, I can take weight here, height here, okay? But in these small problems, it doesn't affect. If I have say x1, x2, x3, so on up to x10, but then it will become very important to choose this root node in a right way. Before choosing that root node, so I'll tell you on what algorithm this decision tree works. Decision tree works on very basic divide and conquer rule. Very basic rule. What it tells, select a test for the root node. Some random test. Okay, I'm selecting height here. You can select weight also. In the previous example, I've selected age. You could have selected exercise as your root node. Okay, how do you select? That's a second issue, but let's look at the algorithm first. Okay, so select your some random root node from your x1, x2, so on up to x10. Create a branch for each possible outcome of the test, like what we have done here. Yes, no, right? Split the instances into subsets. Okay, one for each branch, extending it from the node, root node. So here we have this is as a root node, this as a leaf node. There would be some intermediate nodes also, as I explained here. Okay, but this is a very simple example, so you don't have very intermediate nodes here. But in general, you can have intermediate nodes also. Now, from intermediate node, you have to go to again some other intermediate nodes, so on, and then at the end you will go to leaf node. You have to repeat this process until and unless you tell that one particular rule gives you one particular output. Now, the important thing which you want to understand how to decide which will be, this is called our root node. Great. So I was talking about this divide and conquer rule. It's very simple. Decide with your root node. Look for the rules, yes or no. Divide them successive, like consequently, and then again come up with other feature. By looking at other feature, again divide them, you looking at the yes or no. So you're just, what you're trying to do here is you're trying to create a tree based on some rules. So it's very simple. Let's say you want to go from one location to other location. You will ask a person, say you want to go, say, to place X. Now you will ask a person whether this road will go to place X or no. They will tell yes or no. Based on yes or no, you will take a next decision, right? Similar to that, decision tree also works. It's the only difficult thing in decision tree is how to decide this first root node. Okay. Now, for that, we have to go into some mathematics here. Okay. Now, as I already told, the first and foremost question is which feature to select as a root node. You know how to do your decision tree. Python will do it for you. You just need to write one single line of code. Python will do it internally and it will decide which node or which feature should be your root node, right? Python will do it for you guys. But I don't want you guys to just follow it blindly, right? So I always try to give you some mathematical background behind every code when I feel that it comes under intermediate level. Okay. So you all know entropy, guys. Will calculate the disorder in the system. Disorder in the sense different information. As I already told, you have to keep splitting your trees until unless you get the final output as pure. What do I mean by pure? Pure means at the leaf node, all the data belongs to a same class. Same class in the sense, if you look at the previous example, fit or unfit, right? So pure, that is what we call it as. Keep on dividing your tree from root node to intermediate, intermediate to intermediate, intermediate, and then leaf node until and unless you get your final outputs at the leaf nodes as pure. Okay, pure in the sense the data belonging to that particular leaf node has the same output. Very simple. Now, how do we make sure? We can take any root node now, but the problem is we cannot take any root node here. If we take any root node, say for example, if I take the root node as in the previous example, I have taken age. So for example, for age, selecting as a age as a root node, I got, there was one root node and one leaf node, and I have only say one intermediate node. So it is a 3-level tree. For just assume if I had selected some other feature as my root node, then my tree would have 4 levels, one root node, 2 intermediate levels, and then one leaf node. So it's very difficult, and we should always try to optimize our tree. Otherwise, it will lead to some of the problems. And what are those problems? We'll look into later. But it will lead to a problem of underfitting and overfitting. Remember these terms, underfitting and overfitting. But making your tree very big will lead to a problem of overfitting. There is something also called as underfitting, which is different. But let's not discuss that now. I think I've given you a small hint about overfitting and underfitting in my previous session. Did I? Right? Yes. I've given you a small glimpse about overfitting and underfitting, but I don't want to tell more about that now in this session. But what we have to make sure is your tree is not complicated. If your tree is complicated, that means you have more levels in your tree. That means it is complicated. If it is complicated, that means you're trying to solve your algorithm over. That means overfitting in simple English. I'll tell you in mathematical terms also later on, but for timing, just understand this will lead to overfitting. So to reduce this overfitting problem, sometimes we compromise with the purity of output. Sometimes we do compromise with the purity. If you remember, how can a training data set have an accuracy less than 100%? If you remember, I have told that answer. Your training data set can have the accuracy less than 100% by compromising so that your model does not overfit by compromising the accuracy. Similarly, here also we are compromising with the accuracy and so that our model do not overfit. These are some very simple terms, but I will explain you again in the future with the help of examples. But I think I've already explained you, but I'll also explain you with the help of example in the future sessions. Don't worry. What is overfitting and underfitting? Now, you don't worry about this formula much. It is a formula. We can derive it, but to derive it again, it is a separate session. So I don't want to get into that. So P is a probability value. Okay. I to M, these are the samples, number of records. and you know how to calculate log of something, right? So this is your entropy value, the measurement of amount of disorderness. Based on this entropy value, we calculate information needed, okay? And then based on this information needed, we will calculate information gain. I know it's very difficult to understand with this terminologies. See, tuple has a different meanings, but tuple is something which cannot be changed. So you don't worry about this, all the terminologies. What you have to understand is how to decide your root node. And root node is dependent on your information gain. So if a particular feature, if x1 has more information than x2 in terms of influencing your output y, then x1 would be considered as your root node. So don't worry about the terminologies. These are the formulas which we'll be using in next slide. Then you will understand in a better way. Yes. Say in this case, I have taken a big example here. Buying a computer is our output, and x1, x2, x3, x4, these are the 4 input features. So now, say if I decide age to be my root node, then say I have 3-level decision tree. Say if I take income as my root node, I have 4-level decision tree. If I take student as my root node, I have again 4-level decision tree. If I take credit rating, this might create 5-level decision tree. So 5-level in the sense you got it, right? 1 root node, 3 intermediate nodes, and 1 leaf node. So we have to choose the one which actually reduces your decision tree levels in simple language. And to decide that, we have to take a feature which has more information in comparison with other input features. Okay. Now, if I want to create a decision tree by looking at the age, let's say if I take age, let me quickly do one thing. So what were the features we had? Age, income, student, credit rating. Age, income, student, credit rating. And what was our output? Whether the person buy computer or not. I will explain you the concept. If we have time, we can look into maths. Otherwise, it's a very simple maths also. Okay. Let's say I'm choosing age as my root node. Okay. Now tell me how many bifurcations or branches it can have. Just by looking at the age, tell me. Less than or equal to 31, 31 to 40, greater than 40, right? Less than 30, 31 to 40, greater than 40. Did you understand this, guys? I'm trying to create the tree by taking age as my root node, right? Yes, very simple, cool. So for less than 30, say for less than 30, how many outcomes we have? You can have high. If I'm looking only with respect to income, I can have high, I can have medium, I can also have low, right? I have all the 3 different possibilities, low, medium, high. So now I'm looking at income now. High, medium, low. Okay. This is something similar what we have done previously. If you look into this age, whether the person age is less than 30, yes or no. Okay. If it is yes, does he eat pizza or does he not eat pizza? Okay. Simple. Similarly here also, in this case, we have 3 outcomes here. It's not about yes or no. It's about 3 outcomes here based on the income. Now this is very difficult. You have to understand, it becomes very complicated if I draw this tree. If I keep drawing this, you will notice it will become very complicated with respect to income. Similarly, for 31 to 40, how many outcomes do I have? High, low, medium, high. I have all the 3 outcomes. Okay. Similarly, for greater than 40, low, medium, I have only outcomes as low and medium. Okay. I have only 2 outcomes. Did you understand? So far so good, guys? We are done with the income. Now less than or equal to 30 with income high, what all possibilities of student we can have, whether this person will be a student, yes or no. For less than or equal to 30 with high income, we know it has only no. With less than or equal to 30 with medium, again it has no, but it also has yes also, right? So now what I will do, With less than or equal to 30, with high, we have noticed it has only no. So it has only no whether a person is a student. With less than or equal to 30, with medium, it can have either no or yes, both, right? It can have no, it can also have yes. With less than or equal to 30, with income low, it has only yes. That means income is low, age is less than or equal to 30, a person is student. So it has only yes, right? So far so good. So we have completed for less than or equal to 30 for income and student, right? Now for less than or equal to 30 with income high, we know that the person has only one rule, which has not a student. But again, the credit rating has a two outcomes, fair or excellent. So now this no will be divided into fair or excellent. See, I'm drawing only for one branch. See how difficult it is. Now, when a person is having an age less than or equal to 30, if the income is high and if he is not a student, his credit rating is fair, then he will not buy a computer. Similarly, when the age of a person is less than or equal to 30 and the income is high and he's not a student, his credit rating is quite excellent, but he still doesn't buy a computer. Okay, making sense? So our output here would be no computer, no computer, right? So far so good. Understand this. I have taken only first two records with less than or equal to 30 and have proceeded, and then you have noticed that how difficult it is. Now when I have less than or equal to 30 with income high, he is not a student, he is not buying a computer. Whether his credit rating is fair or excellent, he still doesn't buy a computer. So there is no use of this, because the outcome can directly be come out from this, that he will not buy a computer. No buying of computer, right? There is no need of looking at the credit rating. Now what I have done here, I have done only for one less than or equal to 30 with high income, with not being a student. I got a very pure solution that he will not buy a computer. With a pure solution, that means the output has the same outcome, that means no. Similarly, I can do it for all the remaining branches, but think manually how much time will it take to get all the pure outcomes. So if I go ahead and get the pure outcomes, the first thing is I'm overfitting the problem, because I'm over calculating. It's like a overdoing something, right? Something like that. So it's overfitting. You're trying to fit your machine learning algorithm over. At the training level, you're overfitting your problem. It cannot guarantee that for the test data set, it will work in a similar way or not. It cannot guarantee that. So sometimes we have to compromise with the purity or accuracy with this overfitting. Okay, making sense? What do I mean by that? Compromising. Compromising in the sense, what I will do is less than or equal to 30. If you notice, there are 5 less than or equal to 30s, and we can notice that 3 has no buying a computer and 2 has buying a computer. So what I will do, I will directly stop my tree here itself. Less than or equal to 30, I'll stop my tree here itself and say not buying a computer is our output. I know this output is not correct for all the 5 records. It is validating quite good for 3 records, 1, 2 and 3. But for this and this, it is not validating properly. But then, right, how system decides. So first of all, how the system decides that you have to tell to the system. It will try to achieve good accuracy, and then you have to replicate the same thing on the test data set. Okay, and then only you will come to know that it is overfitting, right? Then only you will come to know that if our algorithm is working fine for training data set, it is not working fine for the test data set, right? Then only you will come to know it is overfitting, right? So that's a different case, how system decides where to stop. But before that, we have to understand, can this tree be modified in a different way so that I have very less branches? You have to understand that, can we change this tree and reduce the number of branches? Can we do that? That's the first question. And for that, we have to decide what will be the root node, because here the root node had very much lot of branches. If I had taken, say, if I had started with student or credit rating, it would have bifurcated only into two, yes or no, fair or excellent. So that's the first question. What should be the root node? That's the first thing which we have to solve. And then once you start coding, you will come to know how system will decide when to stop, where to stop. Okay. And yes, system or the Python libraries are so robust that it will calculate all this maths at the back end and it will decide the correct root node. Okay. But how does it do? Let's look at the mathematics behind that. Okay. Now we have two classes: buying a computer, not buying a computer, right? So we have 14 records. Probability of buying a computer with yes is 9 by 14. Probability of not buying a computer, it's 5 by 14. Did you understand this part? Right. Now let's calculate the entropy. Entropy is the amount of disorder, right? Measure of disorder. Now what I am doing here, total there are 13 events. We might have to change this. How many no's? 5 no's. So 5 by 13. And this would be 8 by 13. Okay. You can do the corresponding calculations, guys. Okay. So now let's calculate the entropy. You can change these values as per the same. Okay. You can do that now. Okay. So let's calculate the entropy. Now, what is the entropy formula? Summation of probabilities log probabilities, denoted by information of D. This is entropy actually. Okay, there is some misprinting here. I will change it and I will send it again. Let's look at the formula itself first. So entropy in D, sigma minus sigma of probability of yes and probability of no, right? So probability of yes 8 by 13, log of probability of yes 8 by 13, minus probability of no is again 5 by 13, log of 5 by 13. Okay, you can calculate these values. Okay, I have calculated based on 14, so you can calculate it now. Now what is the information gain if we split on age? That is a problem which we need to solve. Okay, now for age, how many different bifurcations we have? Less than or equal to 30, 31 to 40, and then greater than 40, right? Now how many positive events we have for less than or equal to 30? Positive events in the sense, with less than or equal to 30, how many yes we have and how many no we have in our output? With less than or equal to 30, we have 2 yes and 3 no's. Similarly, for 31 to 40, we have 4 yes and 0 no. For greater than 40, so this is the table what we have, right? Now what we have to do, we have to calculate the second term. Second term says what is the information value. We have to calculate now. Okay, let's do one thing. What I will do, I'll just change these values and then I will share it again. Otherwise, you guys might get confused with 14 or 13. So what I will do, I'll just try to change this and then I'll share the values with you, because I don't want to get confuse you. Okay, but what you can do is just try to create one decision tree with respect to age, first as a root node, income as an intermediate node, and then student, and then credit rating. Try this today. Tomorrow I will exchange these values with respect to 13 and I'll tell you to create one more decision tree based on the information gain value. Okay, if I want to explain this thing, it's quite simple to understand, but I don't want to confuse you now because this 13 and 14 will be creating a confusion. So let me change these values and then I'll share it with you tomorrow, right? Because I will add one more row. Instead of changing the values, I'll add one more row tomorrow and then I'll share it. Okay, so for today your task is, if you can take the quick snap of this table and try building a classification tree with age as a root node and then income and then student and then credit rating. If you can do this, I know it will take one full page, but if you can try this, you will understand how things will change here. If you don't draw those trees, no, it will be really difficult to understand how root node is very much important. Okay, so it is 9,5. Okay, so meanwhile, what I want you guys to create one decision tree with the help of age as your root node, income as first intermediate, student as second intermediate, credit rating as your leaf node. Okay, so what you have to understand here is how decision tree is working. It is working on your branches. It keeps bifurcating until unless it goes to an output, common pure output. Okay, now so again I have imported numpy, pandas, matplotlib. Okay, and I have imported, so let's run this. I have imported one data set directly from the Skill-Learn library. So Skill-Learn library has lot of machine learning libraries. So machine learning library, as I told, Skill-Learn is a core of machine learning, which has all the libraries of machine learning. It also has different data sets. So for that reason, I have directly imported one of the data sets from the Skill-Learn itself. You can import some other data set. You can import the assignment data set which is already there. You can import the same data set itself. Okay, so I have imported that data set, created a data frame out of it, and then you don't worry about this because I am working on the images, which is unstructured data, but you will be working only on the numerical data, so you don't worry about that. So I have a pandas data frame now. So now everyone knows how to create a pandas data frame now. If you are importing any CSV or Excel file, assign that to some variable using pandas. Once you have created a pandas data frame, what I'm doing on 91st line? So in 91st line, we are splitting the data into test and training data set, right? And with what percentage going into training data set and test data set? 80% of it going into training data set, 20% of it going into, right, test data set, using this test size equal to 0.2, which is 20% going into test data set. What is this importance of random state? Remember I told you, right, ensuring repeatability in the random selection or sampling. Now we are splitting the data into training and test data set, maintaining that consistency. Okay, now as I always tell, there is only one line. Just give me a second, guys. I think in today's session there is something missing, right? So again from Skill-Learn, we have to import tree, like we have done for linear regression. Remember, from Skill-Learn we have imported linear model. From linear model we had linear regression and logistic regression. Similarly here we have to import from Skill-Learn, import tree, and from tree we are using decision tree classifier, right? It's just a few lines of code, that's it. You don't have to worry about this. Let me comment this. This will be there tomorrow. Okay, now same thing, model.fit. What we are doing, we are training our model on training data set, and then we are predicting the accuracy on test data set, and also we can predict the outputs based on the predict function on X. So In this line, I am finding the accuracy of the model with respect to test data set. Now, we already have the y actual, which is y underscore test. Here I am trying to find the y predicted values, right? Which is output is yes or no, right? And based on that, what we will do? So in this case, for example, our output was buying a computer yes or no, right? Which is 1 or 0, right? So 1 or 0, 1 or zeros are our actuals. We are predicting those values, right? Whether our output is 1 or zeros. So for some cases it matches and for some cases it does not matches. And if you remember from the last session, I told you confusion matrix. So we have to draw that confusion matrix and then we have to calculate that accuracy. But Python has an inbuilt feature which gives you the accuracy directly by using dot score function. In all the algorithms, if you notice, all the lines are common except for this line, right? So now once you run this, you will get your predicted outputs. You will get the accuracy of your model, decision tree model. Now, if you remember, I have told you something called as confusion matrix, right? Now, how to visualize that confusion matrix? Do you remember the confusion matrix, guys? Actuals and predictions. 1, 0, 1, 0, true positive, true negatives. If actuals are 0 predicted as ones, this is false positive, this is false negative, right? If you want to, yes. So if you want to visualize that, I think I've told you this also. You have to just write from Skill-Lync, you have to import matrix, and in matrix there is a function by name confusion matrix, and confusion matrix will be created on what? Actual output and the predicted output, right? So and then you can print this variable which is CM in which we have confusion matrix. By this, what we are doing, we are predicting the accuracy of our model. Okay, now so far so good. I am getting the accuracy of this decision tree model. There would be a question when to choose, like both decision tree and logistic regression are working fine, right? Both are working as a classification model, classifiers. So then when to use logistic regression and when to use decision tree? See, on the same data set, I can also use decision tree. I can also use logistic regression. Then how do we decide when to use logistic and how do we decide when to use decision tree? If there are many classifications, we use decision trees. Okay. So this is a rule which you have to understand. In the machine learning, there are lot of algorithms for doing the classification. Tomorrow also you will learn one more algorithm. But how to choose which algorithm we should perform is very complicated. So in industries, what people do, they will start with logistic regression first. Why? Because logistic regression is quite simple to understand. By looking at the coefficients, you can interpret the results. But in decision tree, it will calculate the trees at the back end. But in the logistic regression, you can always find the equation and then you can interpret the results. So it will be easy to interpret the results in logistic regression. So what you can do in future also, you should make sure that you can use 2 or 3 algorithms for one particular problem and then try to look at the results which is giving the better results. That one you should go ahead with. Okay, making sense? Right. And the next thing which I wanted to discuss, you cannot implement your algorithm directly on this data table. Incorporate your coding on this table. Why? Because we have categorical values here, right? So what you have to do? You have to convert this credit rating fair as 1, excellent as 0. So you have to convert this using if-else loop. You can use if-else or you can use one-hot encoding. You can use label encoding. It's up to you. But if-else would be very easy to understand, right? You can also use one-hot encoding. It's up to you. So 1 and 0. Convert credit rating into 1 and 0. Now how do you convert the column of income? 1, 2, 3, right? 1 as low, 2 as medium and 3 as high. Similarly, you have to convert the column age less than or equal to 31, 31 to 42, greater than 43, label encoding, right? I'm not constraining you guys, it's up to you. And then you have to convert your output also, yes or no to 1 and 0. Okay, so now you understand how to convert your this categorical table into a numerical table, right? So first you have to do that, and then on that data frame, you have to split the data into training and test data set, and then you have to apply decision tree model. So any questions apart from that root node thing? Any questions? Because root node thing will be clear tomorrow with the help of this slide. Information gain means, for example, this one, say you have this data table, right? Now you have this output. This output is influenced by lot of parameters. X1, say X1, X2, X3, X4. Now, if you remember, in linear regression, there was something called as R square, coefficient of determination. But in decision tree, you don't have something called as R square. Here we have information gain. So what this information tells us is how much information is gained with respect to this column age in determining the output. For this column, if I am calculating the information gain for income, then information gain means how much information is gained while predicting the output with respect to column income. Similarly for student and for credit rating. And that we have to calculate for all the 4 columns. We'll be calculating the information gain tomorrow. So for example, if we get the information gain of income greater than say student, let's say tomorrow you will see the values, like we have the gain value for age here, you will see the values for income and student. Let's say you have the values for income and student, and if you notice income information gain is greater than student, then that means income feature is more significant in predicting the outputs than feature student, right? So, and based on the information gain only we decide which will be our root node. So that we will be seeing tomorrow, and that will also clear your question where to stop the tree. So tomorrow we will be discussing half an hour on this slide only, so that you can understand this in a better way. But meanwhile, please try to draw the decision tree for this table with respect to age as a root node, and then income, and then student, and then credit rating. You will see how much difficult it is to draw the one decision tree for simple data set. Okay guys, so please complete the challenges from first week to fourth week, okay? Because all those challenges are more of mathematical, so please try doing it. Thank you.
Welcome to the next session on Introduction to AI and ML using Python.
From yesterday's session, found out that the calculation which I made was with 14 data sets, but while editing, I believe that there is a one record which is missing, but that's not a problem. So let's calculate with this itself. Once we calculate, we'll see how this is playing an important role. Okay, so what we can do is, first of all, we have to understand that we are calculating the entropy. That means the measure of impurity or the measure of disorderness in the output, right? Entropy means measure of impurity, right? And that's what we are doing, because in the output we have no and yes both, right? So we are separating them out, and we are calculating the information using the entropy formula, right? So this entropy is a measure of impurity, and that is what we are denoting with information. Okay, so now let's calculate the information for the output. Okay, we are calculating now information of the output using the same formula of entropy minus first probability of positive events. In this case it is positive. How many positives do we have? 8. Negatives 5. So probability of positive into logarithm of probability. So again, so, and then for the negative events, can you calculate the value of x? Can you please quickly calculate the value of x? I also got the same value when I did it today morning. Okay, so what is the value for this now? Use the same formula here. We have the same formula here, right? So instead of I of 8, 5, we'll be calculating I of 2, 3. Second one is pretty straightforward because we have one of them is 0. So if I write here 4, by 4 plus 4, 0, which will be 4 by 4. Here also logarithm of 4 by 4, and log of 1 will always be 0. So for this it is straightforward. And on this side it will be 0 by 4. So anyways it will be 0, right? So here it is straightforward and it will be 0. That's the reason I've directly incorporated 0 here. Can you calculate for the third one? So 0.3001. Okay. Now let's calculate the information of the age. Now let's calculate information of the age using this formula, because if you remember from yesterday we have this formula, right? So this is our information value, right? And so in fact this is the information value which we are calculating using entropy formula, and now the information is being calculated using information needed formula. Okay, so let's calculate information of age, because we have segregated into positive and negative events for the age, and then we have calculated it separately, because entropy cannot be calculated in a direct shot, right? So for that, what we have done, for the age column we have found out different subsets, and then using positive and negative events we have calculated the each corresponding information or entropy. Now if you want to calculate the cumulative information of age, then how we should do, using this formula which I have shown you in the previous slide. So here it will be dj by d, right? So here d is 13, 8 plus 5, 13, dj is 2 plus 3, 5, multiply by its corresponding information, plus 4 plus 0 divided by 13, multiplying it by its corresponding information, and then plus 2 plus 2, 4, 4 by total 13 into corresponding its information. So now let's substitute those values here. So what will be the value of this? It's pretty straightforward. Let's do it together then. So first one was minus 2 by 5, and the next one was minus 3 by 5, right? And then we have to calculate the logarithmic values, right? 2 by 5 comma basis Okay, so now, sorry, this is the probability value, so it should be positive. Let's write 0.4. What's happening with this? Let me change it. Okay. So now let's calculate this. Yes, base is 2. So what is the value which we are getting? 0.97. Okay. So I think we have calculated with base E, I believe then. 0.97 and then 2 by 4, 0.5 minus 1. Okay. So if right. So what we are getting is 1. Okay. So now let's substitute that here 0.97 and 1. Okay. Now let's calculate this value. 4 by 13, 5 by 13 into 0.97. So 5 by 13 into 0.97. 4 by 13. Okay. So did you also get the same value 0.68? Okay, great. So now these are the information values. Now if I want to calculate the information gain for the age, then that means that is which is called as, I'm writing it as gain of age, is information coming from the output minus information for corresponding age. So this value would be, am I right? This will be 0.281, right? Right. So now the importance of this is, see, first of all, this is the information gain. This is the gain value if I calculate for, similarly, if I calculate for income, student and credit rating, then it gives us the gain value for all the 4 features, right? It will give us the gain value for all the 4 features. Now, what is this gain signifying? Gain value for each feature. It tells that if, for example, the gain value of age is greater than the remaining 3, then it tells that age is a feature which actually having a lot of information in it, which signifies your output. Do you understand this statement? That means out of 4 features, feature age or column age has the highest amount of information hidden or highest amount of information there, which will influence your output. Or you can also tell in this way that your output has an information from age of 0.281, and if you calculate similarly for the remaining 3 columns, and then if you notice that age is the feature which has the highest gain value, that means your output is determined, or output is more influenced by your feature age. Did you understand this statement? Right. So it was pretty simple, right? So now what happens, you were asking, right, yesterday, where to stop. See, if you do early stop, and if you do not choose a right node, then there could be a chance that we are actually stopping our decision tree early without calculating. For example, let's imagine that age has the highest gain value from remaining three. Okay, and I've started my root node with say income, and let's say age is going at the bottom. If you are not doing this calculation of gain values, I've started with income as my root node and the age is going at the bottom, and then we are stopping the decision tree at somewhere in the middle due to we are compromising with the overfitting, between overfitting and the accuracy, right? Then in that case, we know that in some other way, we are actually stopping age also, right? But we know age has a lot of information in comparative to other features. So we cannot compromise with that feature because it has more information which is influencing your output. So yes, so just imagine we were doing this decision tree, right? We were creating some branches, right? Yesterday we were creating some branches out of different. We can start with age, we can start with income, we can start with student or credit rating. It's up to us. But in future, in this course, you will be doing coding, assuming that you got some accuracy. You will not be worried about overfitting and underfitting. But when you do advanced courses, you have to make sure that your results are neither overfitted nor underfitted, right? In that case, and decision tree is more prone towards overfitting. Why? Because we can keep creating the branches for each feature until and unless our final output is pure, right? In that way, what we are trying to do is we are trying to create more branches, very shallow tree, like lot of levels in the decision tree. So as I told, we have to stop in middle by compromising with the accuracy so that it doesn't overfit. Overfit in the sense we are trying to resolve every minute information from the data set at the training level, but not necessary that could be generalized to a test data set, right? So it will overfit the training data set, right? So that's the reason. And now we know that feature age has the highest information, right? So we cannot compromise with this column age. And if we do not start with age, let's say if you are starting with income and age is coming in between like intermediate nodes, and if we had to cut down our decision tree, unfortunately we are also cutting down our intermediate level at age, right? And which is not the right way, because information has the highest gain available, and that is a most important feature in determining your output. So that's the reason we tell, if we keep age as the root node, then it actually minimizes the overfitting issue of the decision tree. So now you understood, right? It's always important that we should not, because to make sure that our model is not overfitting, we might have to stop our decision tree in the middle, right? And if it stops in the middle with, for example, while resolving column age, then it's not a good thing, right? I'm just assuming that age has the highest information. So that's the reason the algorithm is built in such a way that the column or the feature which has the highest information should be kept at the on the topmost, that means on the root node. Now when you create two decision trees, let's say you have created one decision tree, say with income, and then student, and then credit rating, and then age. Okay, and then create the decision tree based on the information gain. Then you will notice the decision tree is not shallowing as much as it was shallowing when you have not done this calculation. Okay, see, I cannot, the problem is we have to draw two decision tree now. Okay, that you have to do it on pen and paper. So what you can do is calculate the gain value. We have calculated for age, calculate the gain value for income, for student, and for credit rating. Okay, Now based on the gain value, highest gain value should be at the root node. And then the next classification of the tree should be based on second highest value of the gain value. Okay, so that is how we are supposed to narrow down, that is how we have to branch out our tree. So I know that you have understood this calculation now, but you won't be able to understand the significance of this calculation until unless you draw two decision trees. And now what are those two decision trees? One decision tree will be based on your this calculation with highest gain value, that would be your root node. Second highest gain value, that would be your first intermediate node, and then so on. And then the second decision tree would be, so did you already calculated Naga for all the four? No. Yes. So as per gain value, first calculate the gain value for all the four and then try to create one decision tree, and then create one more decision tree randomly without considering the gain values. Okay, so create just two decision trees on pen and paper. You will understand the significance, and then you will cut down some of the branches. If you remember yesterday, we have cut down some branches, right? If both the two branches had the same result, we have cut down that branch, those two branches, remember? Similarly, you have to do it. Again, I am repeating myself. First, calculate the gain values for all the features. Based on those gain values, decide which will be root node, and then apply decision tree. And then second, without considering the gain value, just try to do it the decision tree. You will understand its significance. Okay, with the interest of time, I'm not creating those decision trees, and it will be very difficult to explain it like without drawing. It will be really difficult to imagine. So I would say please draw two decision tree at least, everyone, and then you will understand the significance of this. So can you quickly calculate the gain values? For income, it will be low, high and medium. Again, this will be divided into three like this, what we have done here. First of all, did you both understand the calculations what we have done in this slide? For age, first we have calculated the information of output, and then for age, and then gain value of information gain for age with respect to the output. Similarly, we have to do it for income, and then student, and then credit rating. What is entropy? Entropy is a measure of impurity. Simple, right? It is from our thermodynamics definition. Whether you take mechanical definition or data science definition, it is same. Measure of impurity or uncertainty in a bunch of examples, right? And what is information gain? What we are calculating at the end is the gain value or information gain. What is that? It is a measure of how much information a feature gives us about the output or about the class. So to do not lose any information, or I would say decision tree always tries to construct in a way maximizes the information gain, right? It always, decision tree is built in such a way that to maximize the information gain. Why? Because it gives us the information of a feature about the class. So that's a reason why decision tree always try to start with the root node which has highest information gain. That's the whole reason. Okay, so you have constructed the table like this, right? Like what we have done for age, we have to do it for similarly for income also, with low, medium and high. For low, how many positive and negative? For medium, how many positive and negative? For high, how many positive and negative? Okay, I think pen and paper would take lesser time than Excel. So always remember, decision tree is constructed in such a way that it maximizes the information gain. Otherwise, there is no need of this such algorithm if it is not maximizing the information gain. Because if it is maximizing the information gain, then only we can predict our output in a better way. So low has 1, we have 4 lows, okay, 1, 2, okay, yes are 3 and no is 1, correct. For high you are telling we have 2, 2, okay, let's verify that. Yes, we have 2, 2. For medium we have 2, 3, correct. It's okay, I got it, no problem. So it makes sense, you got the table. Now what we have to do is, we have to calculate, because for the output we have already calculated the entropy value or information value, right? Based on the entropy formula. We have to calculate, we are calculating for income. So now let's calculate the information for income for all the three, right? For low, medium and high. So for low, you're telling it is 1. Okay, let's calculate that quickly. It's 1 by 3, 1 by 4 and 3 by 4 with logarithm of 1 by 4 and 3 by 4. Okay, so let's calculate that quickly. 1 by 4, 3 by 4 and then 1 by 4 is 0.25, 3 by 4 is 0.75 and then I'm getting 0.8, no? First of all, for high, which you are getting 2 and 2, right? For that, it should be 1, right? From the previous example, we have already seen that. For 2 and 2, it will be 1. Same value, no? So it should be, for 2 and 2, it should be 1. You don't have to calculate it again, right? For 2 and 3, it would be 0.97. And for 1 and 3, it would be 0.81. Exactly. Because, see, for age only, we have calculated 2, 2, right? For age, we have calculated, right? For 2, 2, we have already calculated. For 2, 3 also, we have already calculated. That's the reason I've asked you, it will take only 5 minutes because we have to calculate only for 1 and 3. No problem, no problem. Right? And then what is the final value then? 4 by 13 into 0.81 plus 4 by 13 into 0 plus 5 by 13 into 0.97. So what is this value? Information of income 0.622. Now subtract 0.622 from 0.961, you will get 0.34, right? So let's calculate 4 by 13 into 0.81. The next one is 0. Last one would be 5 by 13 into 0.97. 5 by 13 into 0.97. Now I have to give here equal to value and then I have to add here 0.5 by 13 into 0.97. So it's 0.622. So 0.622 is the correct value and then information gain value is, information gain for income would be 0.34, right? So what we have seen, the gain value for the income is slightly more. Similarly, we have to calculate for student and credit rating and then based on this information gain value, you should calculate one decision tree and one decision tree randomly. You will understand how the decision tree is working at the back end. Okay. Now, the first question, importance of entropy and information gain. So I have already told you what is entropy and what is information gain and the importance of information gain and how information is gain calculated. It's based on entropy, right? How decision tree can be used for regression. This I didn't tell you guys. I told you how decision tree can be used for classification, but I didn't tell you for regression. So I want you guys to explore on this, okay? And then create all possible. Here you can make sure that create 2 decision trees. Let me change this. On paper for below data, out of which one should be based on information gain value. Okay, it's the same Excel sheet, same data. Okay, you don't have to worry, you have already calculated for 2 columns, you have to calculate for remaining 2 columns. Now create the decision tree for above data using entropy and information, which I have already given here. So I will remove this question now, it's not required. Okay. Now the fourth question is list down the advantages and disadvantages of decision tree. You must be knowing what is the disadvantage of decision tree now. That it is more prone to underfitting or overfitting? Overfitting, right? So now to overcome this issue of overfitting, which you have asked yesterday, where to stop, how to stop. So for that question, there are different methods to stop this. Okay. There are different methods which we'll be learning in the advanced course. But one such algorithm, which is an extension of decision tree, helps us in resolving the issue of overfitting. So that algorithm is known as random forest. It's a random forest. So this is a single decision tree on the left side, right? On the right side, if you notice, I have 10 decision trees. Okay, so it's simple. When we have a single tree for finding a decision, it is called as decision tree. And then when we have multiple trees, where we will have multiple trees, lot of trees in the forest, and that's the name, forest. So when we have lot of trees, that's called as forest. And why is it random? Because if you notice, different decision trees will give you different output or different predictions. Now how to tell which output or which prediction should be chosen? That's the ultimate goal for us, right? So think in this way. You want to watch, say, one Hollywood movie, and you are asking your friend, how was this movie? If you are asking to a single friend and he asks you certain questions, okay, do you like Hollywood movies? First of all, if you tell yes, he will think in this way. And then he will ask, do you like James Bond? And then he will take a different path again on that. And then he will ask some more questions. Do you like fantasy movies? And then he will take different path. And then at the end he will tell, then yeah, you might not like this movie, or you might like this movie. Based on your questions he will be asking you. For example, if you say no, I do not like Hollywood movies, then he will stop at that point itself. If you don't like Hollywood movies, then you will not like this Hollywood movie itself, right? Or he might ask some more additional questions, and based on that, he might tell you, okay, you might like it. It's not a conventional Hollywood movie. You might like it. So this is a single decision tree. But imagine we generally, what is our human mentality? We will not ask one person. We will ask multiple persons. And why do we ask multiple persons? So for example, let's drop the idea of movie. Think of buying a two-wheeler. When we are buying a two-wheeler, we will not ask to a single friend, right? We will ask multiple friends. We will read the reviews. We will ask internet. And then only we will decide which one we have to choose, right? Right, exactly. It helps us in a better judgment. So the point here is, what I'm trying to make here is, if you have asked your 10 friends and your 7 or 8 friends tell you that this two-wheeler of, say, Honda is better than TVS, then you might buy a bike of Honda. Or else if 8 people tells you that no, TVS two-wheelers are better in terms of services, mileage, then you would go with TVS. Simple. So it will help you in taking a better prediction. And how would you do that? By using the majority rule. Majority rule in the sense, you will see how many people are going with prediction A, how many people are going with prediction B. And then you will go with majority rule. Simple, very simple, right? Did you understand this random forest? Now, how does it work? That's important. See, at the back end, it works in a similar way using entropy and information gain. But let's imagine, don't look at the right table. Just look at the left table. You have been given with one data set which has 6 features, for example, and these are your input features. Okay. You're not considering, as of now, we are not considering any output here. I'm just showing you how this Once we have only single data set, how do we come up with multiple trees? That would be a question in your interview. So when we have single data set, what we do, we try to create multiple data sets here using the single data set. How? So for example, this is my first data set. This is my second data set. This is my third data set. So if you notice, and this is my ninth data set. This is my 10th data set. So if you notice, guys, in my first data set, what I've done, I've taken some random samples out of this with only 2 records and with 5 columns, any random selection of 5 columns. I've not taken column 4 here. Now using this data set, we will try to predict the output. So similarly with this data set, I'll try to predict the output with this data set. So these are all random samples which I'm taking out from the main data set. Similarly, in the ninth data set, I'm taking more samples. Okay. So, and the one important thing which you should understand here is bootstrapping. So we know how to do the sampling analysis, right? For example, I have 100 numbers and I'm taking a sample of 10. Now, once I take the sample of 10, say I'm getting the samples as, say, let's assume 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Now, once you have taken the samples out, then when you take a second sample, you should take that second sample again from the same 100 data set, not from the remaining 90. You should take from the same 100. So for example, to give one more example, say you have a bag with 10 balls, okay? Say 5 red balls and 5 black balls. Now, if I want to take a sample of 2 and first, let's say I have taken a first sample, I got 1 red and 1 black. Now, if I want to take a second sample, it should not be a sample from the remaining balls. This sample should be in such a way that you are keeping this first sample back into the bag and then you are extracting second sample. So what I am doing? I am taking the sample with repetition or selection with repetition, and this sampling with repetition is called bootstrapping. See, otherwise we will be having lack of data, right? We cannot come up with multiple samples then. See, for example, if I take this as one sample, then I will left with only very less data, right? So to get with multiple samples, which will help us in our prediction, we should have, to get a better prediction, we should ask more friends. Similarly, to get better prediction, we should take multiple samples. To get the multiple samples, we should do sampling with repetition, and that is called as bootstrapping. And then based on the majority rule, you will decide which one to go ahead with. So how to decide? But will it have negative impact as the data set is increased by duplication? See, now imagine in this way, if you have one of your friend ask you the same question and he tells you, yes, you should go and watch this movie based on some questions. Similar to that, if you have another friend who has asked the same ditto questions to you, and then based on the answers which you tell, he will also recommend you the same thing, right? Yes or no? Yes. So this is the first thing. If there is a duplication, I'm telling you, it will not impact the result in decision tree or random forest. It might impact in your linear regression and logistic regression, because there you will working with equations. Here you are working with rules. And then whenever random forest works, in reality you will notice it will take the samples, but it will not try to repeat the same sample. Did you notice out of these 10 samples, did you notice any of the sample is repeated? In general, I have never noticed that these samples are repeated. Okay. So the next question is, how do we decide how many samples we should take? Yes, how to get majority I will tell you. Okay. That will duplication impact your result. So I would say it has multiple factors, But yes, if you have the exact duplication, it might impact. Okay, it might impact. I'm not sure. This will help you in answering or analyzing in a better way. Okay, let's imagine, say you're taking 5 samples, 10 samples, 20 samples. Say your accuracy is increasing. As you are increasing the sample, you are getting better judgment, and then slowly your accuracy will decrease. For example, your accuracy is decreasing. So what does it tell? Asking to so many people sometimes leads your confusion, and what you're talking about duplication, that can also be taken care here. When you take more samples, there might be a chance that random forest might take a sample which is repeated. So what we should do is we should generally draw a curve of accuracy with respect to your number of decision trees which you are taking, or number of samples in your random forest. Okay, so if you see, if you will notice this curve for sure. I'm pretty sure that you will notice this kind of curve. With samples of increasing decision trees, it might increase your accuracy, and then after that it will keep decreasing. So you will stop somewhere here when you have maximum accuracy. So there might be an impact of duplicate sample, but in general, random forest try to avoid that. But if you keep on increasing the number of samples, then it has to take the duplicate sample, right? It has to take, it can't do anything. So in that case, when your data set is say very small like this, and if you go ahead and take 100 samples, then there might be a chance you might encounter a duplicate sample. Now, how to get a majority rule? In general, the random forest in Python coding, it will already take the majority rule. You don't have to worry about that. Okay. But if you want to do it manually, then you should take a majority rule. For example, if you're taking 10 samples, then 6 would be the majority one, 7 would be the majority one. So now this is how you should identify your optimum number of samples or optimum number of decision trees. And based on that, you have to, or algorithm will decide your prediction based on the majority rule. Now, this kind of algorithms, this random forest or this kind of algorithms are called ensembler classifier or ensembling methods. I think there is some spelling issue with my calc. Ensemble. Okay. So if you remember from English meaning also, ensemble means joining or together, unity, right? Something like that. Random forest, this kind of algorithms are called ensembler classifier, or the technique is called or these methods are called ensembling methods, right? Because we are taking decision tree multiple times, right? So we are taking a lot of things together. These are called ensembler classifiers. Okay. So in interview, if someone asks you, do you know anything about ensembler classifier? Then you can talk about random forest. So there are several other algorithms which are ensembler classifiers, but the scope of this course is with only random forest. Okay, guys. Now we have learned so many classifiers. Okay. Now how to decide the accuracy? I think I've already talked about this, but still I wanted to talk you on this with the help of this small confusion matrix. Let's say you have, I think while drawing I have drawn in this way, right? While drawing, I think I have drawn in this way. Here it is actual, here it is predicted. But it's not a problem. You can take this as P and this as actual. It's just a definition which gonna change. Not definition, it's the ordering of initially true positive was here, now it is here. It's just that the definition will be the same. When you have actual ones and the predicted is also same, then it is called as true positives. When actually it is no or actually it is 0 and the prediction is 1, then it is false positives. And when actuals are no and the predictions are also no, then it is true negative. When the actuals are yes and the predictions are no, then it is called as false negative. Now you must be thinking why I'm talking again on this. Okay, so if you remember in the previous sessions I have already told you, you cannot decide your algorithm just based on the accuracy. Different domain problems will have its own different parameters to come up with the better algorithm. Every time accuracy is not a measure. Sometimes there are different parameters which would be a measure. How? Let's see in that direction. Okay. Now let's say true positives. There are where the cases in which you have predicted yes, that means they have the disease and they do have the disease, right? True negative is also same. We predicted there is no disease, but they are in actual also they don't have any disease. But consider this false positive thing. We have predicted a person is having a disease, but they don't actually have the disease. This is called as type 1 error. In interview, they will ask you what is type 1 error and what is type 2 error. False negative. We have predicted no, but they actually do have the disease. This is called as type 2 error. So with this disease example, say my accuracy is 99%. Say I have two scenarios again. Scenario A, scenario B. In scenario A also I have 99% accuracy. Scenario B also 99% accuracy. But in scenario A, I have false positives, say some 1%. I'm just talking in terms of percentage, but this will be numbers, okay? False negatives are 0. In scenario B, false positive is 0. False negative is 1%. Now tell me which scenario is important. Let's say this is only 98% and say this is, okay, let's go with first 99% to make things simpler. And then I will try to change this problem. Let's compare first apple to apple. So A is better because see, you have to think in terms of as a being a patient here. We have predicted a person has a disease, but he do not have a disease, that is false positive. If it has a false positive, then what he will do? He will go and he will do the checkup, right? But in false negative, we have predicted no, but they actually have the disease. That's a type 2 error, right? So we should try to diminish or try to come up with a model which reduces your type 2 error, because that is severe in this case. In your case B, if you notice, false negatives are 1% of the patients are false negatives. That is severe problem because a person is having a disease but we are not able to predict that. So for this clinical trial, accuracy is not much important. What's important? How much we are able to diminish our false negatives. Let's say my accuracy here is 97% and say false positive are 3% and false negatives are 0. Tell me which is better now, A or B? Which algorithm is better? Don't think in terms of algorithm. You should think in terms of being a patient. Think in terms of being a human being here. Which is better? Which is better algorithm, A or B? In terms of mathematical algorithm, B is better. But in terms of business case, A is better because A do not have any false negatives. So this is how you have to consider, you have to understand which parameter is more important. Similarly, we have several more parameters. I will go with some more parameters, and there are a lot more parameters in outside world which you can always go through, but I am taking some more parameters here. So these are some more parameters here. Accuracy you already know, guys. So when I'm writing total means true positive plus false negative plus true negative. So accuracy you already know. I don't have to tell anything here. Misclassification rate. It's very simple. As the name suggests, it's 1 minus accuracy value. If you have 90% of accuracy, then misclassification rate would be 10%. So what could be the formula? False positives plus false negative divided by total, right? So this is misclassification rate. What is true positive rate? This is important, guys. You should remember. In interview, they will ask you what is recall or what is sensitivity or what is true positive rate. This is true positive rate. not true positives. This is true positive here. Here it is true positive rate. So what is true positive rate? When it is actually yes, how often does it predict it as yes? So true positives divided by actual yes. That means true positive divided by true positives plus false negative, right? What when it is actually yes, how often does it predict yes? So when it is actually yes is this, and how often does it predict yes? That is true positive. So true positive divided by true positive plus false negative. So for some organizations, accuracy will not be a matter. The measure of performance would be recall for some organizations. They always try to improve the recall. So this is a clinical trial example is one of the examples for recall, where you will not look for accuracy, you will try to improve your recall value. And how do you improve your recall value? What is recall? True positive divided by true positive plus false negative. To improve your recall, this should be as small as possible, right? So this example is a recalls. In our engineering problem, we generally go with accuracy, okay? That's okay. But I'm just telling you for different domains, different parameters are important. Did you understand, guys? What is recall? Now let's go with false positive rate. When it is actually no, how often does it predicted? Yes. When it is actually no, how often it is predicted? Yes. So false positive divided by actual no's. So that means what will this be? False positive divided by true negative plus false positive. Okay. True negative rate. When it is actually no, how often does it predict? No, simple. It is also equivalent to 1 minus of false positive rate. Why? Why is it so? Because your false positive rate is false positive divided by true negative plus false positives, right? This is your false positive rate. What will be a true negative rate? True negative divided by true negatives plus false positive. So when you add these two, you will notice that will be equal to 1. That's the reason true negative rate is also same as 1 minus false positive rate. And this is also called as specificity. Now, precision. Okay, this is precision. What is precision? When it predicts yes, how often your prediction is correct? It is true positive divided by true positives plus false positive. So in my projects, what I do, I always look at precision value. No, it's not similar to TPR, no? What is TPR? TPR is true positives divided by true positives plus false negatives. When it is actually yes, how often does it predict yes? Here in precision, when you have predicted yes, how often your prediction is correct? Those two are two different things, no? So in my projects, whenever I do the fraudulent projects or engineering projects, I generally look at precision values also. And prevalence, I have not seen many of the applications where prevalence is used, but you can also look at prevalence. How often does the yes condition actually occurs in our sample? So it's actual yes by total. But I've not seen this much in the real-time applications. Okay, now what happens, guys? Sometimes people will get confused which parameter should be chosen for our performance, whether it is true positive rate, whether it is accuracy, or whether it is true negative rate or precision. So there are several other performance parameters also, but I'll tell you one of them, which is called as F1 score. So what is this F1 score? This F1 score is a combination of two different parameters here. It's a combination of true positive rate and precision. It's a combination of recall and precision. So people generally, so that they are on a safer side, they have created one more measure for performance, which is a combination of recall and precision. Simple. Okay. Now I have some questions, guys, for you. Let's say that you are doing some prediction, or let's say that you are doing some classification problem of whether a car is Mercedes or BMW, and you have some historical data. In the historical data, let's say you have some images of cars, and this is your output. You have some images here. Okay, you have some images. By looking the images, let's say this is being classified as Mercedes, this is classified as Mercedes, this is classified as BMW, and so on. So this is your historical data. Okay, and this has been already classified. Okay, now let's say that this has been classified manually. Okay, this has been, let me go to this here. Yes, this is better. Because historical data what we have is being done it manually by a human being. Okay, it's being done by a human being, and based on that, in the future, then only we can do machine learning, right? Once we do not have historical data, you cannot implement machine learning, because machine learning is all about data. Okay, so let's say you have images. See, in this course, you will be only working with structured data, which is a numerical data. Now I am taking an example of unstructured data, which you will be learning in advanced course. But let's take an example so that it could be easy to understand. Okay. Let's say you have some images of cars. Please forgive me for my images drawing. Okay. Let's say this is Mercedes, this is BMW, this is BMW, this is Mercedes. Now I have millions of data set like this. Now tell me, the human, they can also, so what we are doing manually classifying whether it is a Mercedes or BMW by looking at the images. Similarly, this has been done manually, right? Manually, someone has looked at the image, they have classified whether it is a Mercedes or BMW. Manually, we have looked at the second image, we have classified whether it is a BMW or Mercedes. So tell me, can there be human error here? Yes or no? Yes. So let's take that. There is a normal human being, H1. There is one automobile engineer, say HA. Okay, and these two guys have done the classification of these images. Because some images can be blurry, so there is always a chance that there might be some error. So when a normal human being is doing this, let's say there is an error of say 3%. When an automobile engineer doing this, let's say the error is 1%. Okay. Now this is called as the base error. Base error by which we are comparing. So human base error, right? This is called as human base error. Okay. Now out of these two, which one we should consider as a base error? 1% or 3%? So it depends on the, see, in general, we go with 3% as the base error, and then we perform our machine learning algorithm, and we always target that our algorithm should try to achieve an accuracy of greater than or equal to 3%, because most of the machine learning algorithm cannot beat the human error. Nowadays, there are some advanced machine learning which are called as deep learning. They are able to beat the human error. Okay. Sometimes, but that is very difficult. Okay, there is lot of calibration which is done at the back end, but in general it is very difficult to beat the human error. And if we are considering this as a human error, human bias error, then it's even further difficult. Okay, so let's say that 3% is my human base error. What is this? Human base error. If human error is known and calculated, won't we correct it? Okay, think in this way. For the historical data, you can always correct it. But how about for the test data? Because on this, see, this is manually what we are doing for human bias error. But in data science, you are not doing anything manually, right? This has been done manually for us. Once we have achieved the manually data set, this would be our training data set, and this should be used. This training data should be used for our machine learning to train our model, and then this model should be implemented on test data set. Now imagine for 10 million data, if the 3% error is there, how much will that could be around 0.3 millions. Will someone go back and correct this? If someone has so much patience, yes, they can correct it. There is no harm. They can correct it. Okay. But if you remember, our objective is that comes later, correcting the error. How is it calculated? Someone has done that. But imagine in this way, someone has done the calculation manually that there is a 3% error and corrected it. Just imagine in this way. When we implement machine learning algorithm on training data set, how will you correct your machine learning model? That's the question. See, manually you can correct it. But how will you calculate? See, when a human is able to come up with this error, when he is doing manually, think when machine learning is incorporated on the training data set, will it not be able to come up with the error? Of course it will. Why? First of all, for that we have to understand, because you are asking very advanced question, let me tell you why this 3% error is there. This 3% error is there because there might be an image which is from the side view. If there is an image from the front view or the rear view, you would be having the logo to understand. As a mechanical engineer, we also know the bumper shape, that would be different for Mercedes-Benz and for BMW. But if you have the side view, then someone has to go for that, searching for that car which is there in the image, and then they have to identify whether it is Mercedes or BMW. That's again a different task. What you are doing is you are improving your data set, which is right thing to do, but is it worth it for our machine learning model? That's important. See, again, if it is a clinical trial problem, then you have to go back and correct it. But for engineering problem, it might not be required. We might live up with say 97%. Okay, and there could be other chance. If we are not improving it, how we have calculated error? See, I'm just giving you one example. Okay, someone might have gone checked it. That's true. Your point is correct. See, for example, there might be some blurry images. Someone might have gone and checked it, and then only they have identified the error. But here I am giving you an example. I'm not telling you that someone would go and check it. I'm just giving you an example. Okay. So see, with this data set, you will split your data set, right? You will split this data set into training and test data sets, say 80% and 20%. Now imagine these blurry images, side view images are also there in training data set and test data set. So when you build the model, machine learning model, when human is not able to identify that by looking at the image, see, by going back and looking at the car, they might be able to come up with. That's different story. But what we are doing, we are not doing anything manually. Here, what we are doing is we want to automate things, right? That's the reason we are using machine learning. So when human has some error, machine learning will also have that error. in the training data set and test data set. So imagine that your human error is 3% and your training error and your test error, which you are calculating from machine learning, say I have a data set here which have a 3% error by doing a classification manually, but you can correct it going back and then you can check it. You can correct it, but that's a different story. But here the aim is when a human classifies that manually just by looking at the images, we are getting 3% error. Let's assume someone has calculated that, okay? Because that is something which has to be done manually. Now for training error, let's say that you got 4% error and then in the test data, you got say 15% error. What does it mean, guys? It's simple, no? Your machine learning model is not able to generalize from training to test data set. Yeah, it's not failed, it's about, it's not able to generalize, okay? It's predicting, right, with 85%. Okay, no problem. So what we are trying to tell here is this is called as overfitting issue, okay? You have fitted your model so well for training data set that it was not able to predict properly for test data set. Now you must be thinking why it is happening. Say when you have splitted your data into training and test data set, imagine that all the blurry images are sampled into test data set. Imagine, it could be possible, right? Because it is simple random sampling. Most of the blurry images are gone into this. So it is classified incorrectly. That's the reason you have got a bad accuracy for test. So this is called as overfitting issue. Now, say your human bias error is say 3%. Now your training data set is 15% and your test data set is 16%. Now you're having a lot of blurry images in training data set and your machine is not able, your algorithm, say decision tree, your decision tree is not able to classify this correctly with more than 85% of accuracy. Then your algorithm is not behaving properly for training data set itself, then how can you expect it for test data set? So this is called as underfitting issue. Now let's say your human bias error is say 3%, your training error is say 15%, your test error is say 30%. Then it is over and under both, right? Under and over both, because your algorithm is not able to capture such minute details for the training data set itself. Now your human bias error is say 3%, your training error is say 3.2%, your test error is say 3.5%. Now tell me, this is the best solution, right? So in reality, how do we calculate that human bias error? In reality, you will not be provided with this human bias error in your projects. So what you should do? You should try to minimize your training error and then you should test it over test data, and then your test error should also be minimum and very near to your training error. Did you understand this? The training error and the test error should be minimum as much as possible, but both should be equal to very near to each other. then it is called your algorithm is the best algorithm or the right algorithm or the apt solution. Now remember this. This overfitting issue, sometimes people will call this as variance issue. Underfitting issue is called as bias issue. And underfitting and overfitting both is called as bias and variance issue both. Okay. Now I'll give you one example. Tell me, I have performed a linear regression. I got the mean square error as 1% for training data set, and the for test data set I got say 10%. What issue is this? Variance or bias? This is very, very, very rare. I think it's, to best of my knowledge, it can only happen when you have very simple data sets. But it's very rare. I have never seen. It can be more or less equal. Your tested error can be equal to your training error, but it cannot be lesser than your training error. I have never seen any such scenario. Because imagine that your algorithm is building on your training data set, right? If you're having a training error, then how can that algorithm performs or beats your training error? It's very rare. I've never noticed that. Training error and test error I've seen equal once for very simple data, but I've never seen that test error beating training error. So tell me, what is this issue? Variance or bias? Right. Now let me give you one more issue. What is this now? Underfitting or bias? Now, this would be confusing, guys. This would be really confusing how we say that this is the minimum error that we can achieve. So for that, you have to apply different algorithms. You have to try standardizing your models. You have to try different combinations of 80, 20, 70, 30, 90, 10. And then only you can tell whether it is underfitting issue or not. Okay. But by looking at this 10% and 11%, I am thinking that this could be underfitting, but it depends. When you do a lot of analysis, when you run different algorithms on the same data set, when you do training test split as 70, 30, 80, 20, 90, 10, something like that. You have to do a lot of trial and error, and then only you will come to know what could be the minimum error that can be achieved. And then based on minimum error, you can benchmark that error, and then you can tell for the different algorithms that these algorithms are behaving underfitting or overfitting. Okay, so overfitting is very simple, but underfitting requires, to understand whether the model is underfitting or not, we have to do a lot of analysis. Okay, now how can be a same case be over and underfitting? Okay, let me give you this. Let's say that in machine learning language, we have noticed that neural network is the best algorithm. Okay, we have not learned that. I'm just giving you example here. So let's assume that in this you have got a training error as say 2%, and your test error say you got 3%. You have performed random forest here. You got 2% as training and 8% as test. Now you perform very basic logistic regression. You got 10% here and 15% here. Now in this case, this logistic regression model is not able to train your data set in a way it is supposed to. So in this case, this model is behaving both underfitting and overfitting. This model is behaving it as only overfitting, and this is a just right solution. So that's what I'm saying. To understand whether a model is underfitting, you have to perform a lot of different algorithms on the same data set. Otherwise, you cannot benchmark, right? Until and unless in the project they give you what is a human bias error, you cannot benchmark, right? Okay, so let's visualize this in a better way. Let's say I have a training data set. It's a multi-dimensional, okay? It's a multi-dimensional, guys, okay? And I'm just plotting the circles as one output class, say 0, and triangles as 1. Okay, so let me take some other one. These are circles. Let's say this is for training data set, okay guys? This is for training data set. Now, I am coming up with one algorithm. So these circles are zeros, triangles are ones, okay? Which splits your training data sets like this. So it's a classifier model which classifies circles and triangles as 0 and 1s. So now if you notice, it is misclassifying for some of the zeros, right? If I try to make the algorithm better, now what I can do? So I'm trying to calibrate my algorithm in such a way that it classifies all the points correctly. But this has made your algorithm very complex, and then there will be a chances that it will not behave correctly for your test data set. So this is called as overfitting. You're fitting your model over. This is called as underfitting. I'm just giving you one example, guys. Okay. Now, let's say that I'm coming up with a graph, something like this. It has less curve when compared to this overfitting graph, but then there are some misclassifications here. So that's okay. So that is how we have to compromise with the accuracy and make sure that our model is just apt, so that it should not be overfitting or underfitting. Okay, this is just an example, guys. Okay, I'm not a very good drawer, but it is just an example which I'm trying to show you how underfitting means and overfitting means and just apt means. Now, how to tackle this underfitting and overfitting, that you will come to know when you do project, okay? Or you can try with different algorithms to come up with the right solution, or you can try changing 70 to 30 to 80-20 or 90-10. But there are some more methods also. We'll be noticing that when we do the final project, because that is something which requires a lot of knowledge, and that you will get it at the end of this course. And then when you do final project, at that point of time you can try making your model overfitting and then making it, bringing it back to the just right solution. Okay, you know how to make your model overfitting. Just train your model in such an efficient way that it doesn't behave correctly for test data set. Maybe 95% and 5% will make your model overfitting. It has more chances. Okay, so difference between decision tree and random forest, that you already know now. List down the advantages and disadvantages of random forest. You know what is the advantage? It is less prone to overfitting. But what are the disadvantages? You should tell me. One is that it might take more time. What are the other parameters to assess the classifier? So I think I have taught you some of the parameters here. Apart from these parameters, there are a lot of more different parameters such as F1 curves and other things which you can look into internet, and then you can answer this third question. What are the other parameters to assess the classifier? Now, this would be your first project, guys. Perform exploratory data analysis and all the different classifiers or the regression, whichever is required for the case study, and you can evaluate the performance. So for time being, what you can do only exploratory data analysis. That's okay. If you want to do this classifier or regression thing also, you can do it, or if you do only exploratory data analysis also, that's fine. So what is exploratory data analysis? It is descriptive analytics, right? Do calculating mean, median, variance, skewness, kurtosis, and then plotting histogram, bar graph, like bar chart, different graphs, and then by looking at these values, trying to identify if there is any outlier or how different parameters are interrelated, and if this different columns, by looking at this descriptive analytics, are you able to come up with some recommendations, not doing any machine learning, just by doing exploratory data analysis. So it's only calculating mean, median, and then coming up with some insights. Okay, it can be anything, nothing will be wrong here. It's just that some insights you have to come up with, and based on the data you can tell whether you have to perform classification or regression. If in the data set you are not able to understand what is the output, then you can only perform exploratory data analysis also. Okay, now let's go back to coding. Again, same thing, NumPy, Pandas, Matplotlib. I didn't teach you how to calculate mean and variance, that you have to do it, okay? Okay, so we have created our pandas data frame. If you have to import your CSV, create your pandas data frame, and then as usual from sklearn import model underscore selection, and then from that there is a function which is train underscore stress underscore split your data as you want. You can try 70-30, you can try 80-20, or you can also try different samples so that you can come up with the different accuracy values, and you can check whether it is underfitting or overfitting. So which samples would be better to go with training and which sample would be better to go with test. So you can try different things now. Now you have sufficient knowledge to play around with the data. Now, last time we have imported tree from sklearn for decision tree, but now we are importing ensemble. So your ensemble classifiers will be in ensemble. So again, assign this ensemble. In ensemble, you have a function by name random forest classifier. Assign that to what? One variable. Okay, but like till previously we were just putting empty arguments. Now you have to give some argument here, guys, because it is an ensemble method. You have to give some argument here. If you don't give, I believe it will take some random value. But then could you tell me what is this doing? I think you should be able to guess it now. What is this doing, guys? So with 40 trees, you're training your model.fit on the same training data set, and then finding the score on the test data set, predicting y on X test, and then plotting your confusion matrix with the help of predicted output and the actual outputs. Okay, so now you must have understood it's a matter of only this one or two lines which will keep changing. So you must be thinking this Python is very simple, right? If you remember this kind of data like this flow, Python would be very simple, right? But in reality, guys, if it is only a matter of only one or two lines, but then you have to do lot of exploratory data analysis. First thing. Second thing, your model will not be giving you just right solution. It might be underfitting or overfitting. You have to try different things. How do you try that? So now, in this case, you have to try with say 10, 15, 20 trees, 5 trees, 10 trees, 15, 16, 17, 20, 25, anything. And then find the score of training on the training data set and on the test data set. And then look at the accuracies with respect to different number of trees. Identify which could be a just right solution by looking at the accuracies. If the error should be less, that means accuracy should be more, right? So you have to come up with, here you have to write for loop now. You have to write for loop. Why? Because we have to keep changing this number of trees and store the accuracies in different variables so that we can analyze the solution in a better way, right? So machine learning is only 1 or 2 lines, but to have a structured thinking and implementing that on Python and having the results which could explain your client very easily, you should have some visualization techniques. So you have to plot graph here between your accuracy, and you can plot the graph of training data set accuracy or training data set with number of trees and test data set accuracy with number of trees. By looking at those two graphs, you will get the hint which could be the right model to choose or right number of trees to choose. Or also, if you know 3D graph, you can also draw that. So, but I always tell guys, please keep practicing on Python. Take the help of Google. You can always take the help of Google for any small syntaxes, because I also take the help of Google for syntaxes. I cannot remember. No one can remember the syntaxes. So it should not be a problem for remembering the syntaxes, because Google has all the syntaxes. It's just that your concept should be clear, because Google cannot tell you whether the model is overfitting or underfitting. That your concept will tell you whether the model is overfitting or underfitting. Google cannot give you the accuracy. You have to calculate the accuracy. Google cannot give you the precision. So I would say take the help of Google for syntax and try building up the model now. Just build the small algorithms, very small algorithms, importing the libraries. Second step, coming up with a Panda data frame, importing the CSV file. Third step, split the data. Fourth step, assign your model to some variable. Fifth step, fit your model and calculate the accuracies. Sixth step, calculate the predicted output and confusion matrix. If you can do this at this time of course till 9th or 10th session also, then you are good enough to go, guys. And then when you do final project, that will be a combination of different algorithms, and then you have to perform both exploratory data analytics and predictive analytics there. And then you have to give some recommendations also. So it will be a combination of descriptive analytics, diagnostic analytics, predictive analytics, and prescriptive analytics. So by end of this course, you would be able to understand how to deliver a data science project. Okay, guys? If you have any questions, we are planning to arrange a support session next week. I believe we will be planning to arrange one support session, because we have completed half of the course. So now we should be able to arrange one support session. So please keep practicing so that in next support session, we can have a lot of question and answers. Okay, guys, thank you so much. Hello everyone, I think we have completed half of the course, and now as we have the sufficient amount of the knowledge what machine learning does, it's a good time that you start working on the projects. And I believe that the team has already uploaded the videos and they have started giving you the assignment and the challenges. So in this week, you would be having the data where you have to play around with the data. You have to explore. You have to do a lot of stuff at the back end. You have to read a lot of things so that you can, like in Python, if you want to draw a histogram or a scatter plot, what is the syntax which is required, right? So for those stuff, you have to explore a lot of things in the Python. For mean, median, I think I've already told you. For mean is already there in numpy. So you have to use np.mean. Similarly, other functions will be there in other libraries. So that will come with practice, and you don't have to worry, guys, if you are not able to remember the syntax. As I already told you, syntax, it is just a matter of memorizing things. It's not necessary that people will judge you on that. So what's important is you should know the concept, and that is what I always focus on. So few things which I wanted to tell is, before going ahead, I just wanted to understand, till now we have worked on regression and classification, and there will be some more algorithms on classifications. But these algorithms can also be used for regression, but I'm not going into that detail for regression, but I'm using it for classification because in the outside industry, people uses all these algorithms mostly for classification. We could see very less projects on predictions, and whenever there is a problem on prediction, most of the people will go with linear regression. Why people go with linear regression? As I told, random forest and decision tree can also be used for predictions. I know that they can be used for classifications as well, but they can also be used for regression. If you remember, I have told you that in one of the sessions, you should understand how they can be used for regression, but I will not be going into that detail. So could you please tell me, for prediction, why generally people use linear regression? What do you mean by generalized prediction? That's not the right answer though, but yes, I would say, please keep trying, always try to think so that you can come up with the answer. So I would always encourage that you guys please keep thinking. And not really, we cannot say that linear regression is neither over nor underfitting. We cannot say that. The reason why we use linear regression is, for example, let's say you know the mass flow rate through the grills for a vehicle. You know this, right? For example, you know mass flow rate. How do we denote mass flow rate in our mechanical language? M dot, right? And let's say that we want to predict the temperature, let's say the overall average temperature of certain components, let's say any component. Okay, now say I am predicting the temperature where my x is mass flow rate. So can you tell me something? If I have a vehicle, as I always tell, I'm not a good at drawing. Let's say that I have a vehicle and you're driving a vehicle, and there will be a ram air which will be entering into the vehicle, right? So based on this vehicle speed, the mass flow rate enters would be different, right? Can you guys tell me, if I'm driving a vehicle at 35 kmph and at say 240 kmph, okay, now let's say I have n dot 1, this will be greater than m1 dot, or this will be less than m1 dot. Can you please tell me, guys, the mass flow rate entering into the vehicle at higher speed, will it be higher or lower? Higher, right? Even though if we are not mechanical engineer, we should be able to tell this because the examples which I am taking are very basic examples. Now we know that mass flow rate here would be higher. So now tell me, if the mass flow rate through the grills are higher than inside components, say engine, fuel tank, drive shaft, anything, then the temperature of these components will be higher in 240 kmph case, or will be higher in 35 kmph case? Where will be the temperature higher? 35, right? So let's go with that same assumption. Yes, 35 would be the higher temperature would be for 35, right? So now, because the force convection for 245 kmph is quite high, right? I don't know why I am using so much mechanical technical terms today, but seems like I have read an article yesterday and a lot of things refreshed in my mind, which I used to do long back. So a lot of things refreshed in my mind, and that's the reason I'm going with a lot of mechanical stuff today. So now let's assume that the relationship between average temperature and the mass flow rate is linear. So now tell me, will this be increasing graph or decreasing graph? Decreasing, right? So let's say that you have some random, I'm just taking some assumptions always, okay guys. So what I wanted to show here is, say, what is this then? This is your beta naught, y-intercept value, right? And this, what is this? So we know that this would be the slope, right? So what is beta 1 telling? It is directly telling us the slope value, right? So if you remember y equal to mx plus c, if you compare this graph equation with y equal to c plus mx, what is c? Y-intercept. What is m? Slope. Similarly, right? So it is easy to interpret. For example, if I tell that, say the mass flow rate is increased by certain parameters, say by 5 units. Let's say that your mass flow rate has been increased by 5 units. Then you know your average temperature will decrease by say 5 units. Okay, I'm just talking in very simple mathematical terms. Why I'm talking it will decrease? Because your slope is negative, right? Your slope is more than 90 degrees. So tan of more than 90 degrees would be negative, right guys? Do you remember? All silver tea cup. Here all the ones would be positive. All the trigonometric functions. Here only sine and cosecant will be positive, right? So tan would be negative and always the slope would be represented by tan of angle, right? So it will decrease. So what do you think? It is easy to interpret, right? Once you have developed machine learning model, once you have trained the model, it would be very easy for you to interpret once you have the equation. But it's not the same when it comes to different algorithms such as decision tree or random forest, because that would be lot of things would be done with the back end in the algorithm. But of course you can interpret that, but you have to do lot of analysis for that. It's not that you cannot interpret, but you have to do lot of analysis for that. But linear regression is very simple, very easily understandable, very easy to interpret. That's the reason people will go with linear regression. Okay? Yes, we can't use linear regression only because of ease of interpretation. You are absolutely right, but I always try to use linear regression first rather than going with decision forest for regression, or decision trees for regression, or random forest for regression. I generally start with linear regression because by that I will try to understand, I will do lot of exploratory analysis, and then once I develop linear regression, I would be in a position to understand first of all that whether linear regression is performing well or not for the given data. See, we cannot always jump directly to a complicated algorithm. We should start with simpler. First of all, we should understand the problem. Okay? And then we should understand which algorithm needs to be used, whether it's a regression problem or classification problem. In regression or classification, we have to start with simpler algorithm to understand whether the accuracy or the performance what we are achieving is good enough or not. And then we should go with different techniques. Okay, great. So whenever I generally recommend, whenever you try to do the project in the future, always try to implement at least 2 algorithms to understand whether the accuracy what we are achieving is it sufficient enough or not. And then you should check for errors also. Okay, and you should check whether it's an overfitting or underfitting. What's the difference between decision tree and random forest? So decision tree we have already discussed. Decision tree, in this we have seen the entropy and information gain, right? What is entropy? I'm just refreshing few things guys, because it could always be possible that there should be few things which might come extra when I talk something again. There would be 100% chance that I might tell something new on that. So what is entropy? It's a measure of impurity or uncertainty. What does impurity mean? If you remember, at the end of the classification, when we have looked into the decision tree, we have to make sure that the classes are pure. That means it has to be either 1 or 0. If it is a binary classification, if it is a multinomial classification, then it has to be either 1, 2 or 3. But then the point is, are we supposed to get the exact purity? No, because then our tree would be very shallow and then it would create an overfitting issue. What do you mean by irrelevance? Could you please elaborate?
I meant that our characteristic might not be influencing the output.
Right, you're talking about entropy, right? I got it. So that's the whole point. And then the point which I wanted to make is entropy is just a measure of impurity. How is it helpful for our analysis? Because using entropy, we are calculating information gain. And that's the ultimate goal for us. What is information gain? Information gain is the one which tries to reduces the entropy, and then we understand by that which feature has the more information carried by to influence the output. So that is our information gain. Now, what is random forest? The decision tree is just a single tree. So, and then random forest is multiple trees. So I have given you an example. So if you want to buy a car, then we generally don't ask only one friend, right? We will ask a lot of people. Similarly, random forest also works in a similar direction. If you are searching for some mobile and you don't know which mobile I should buy, then you will ask your friends, right? It's not that you will stick to your only one friend. That's the whole point of using random forest. And then it also avoids overfitting. That's the main advantage of random forest. So I've already told the second answer, the advantage of random forest. What is the disadvantage of random forest? Please find out what is the disadvantage of random forest. Okay. One of the disadvantages would be it has to take multiple decision trees running, right? So it will take more computational time. And remaining thing you can find it out. What are the other parameters to assess the classifier? So apart from this, I told you to find out what are the other parameters which people go and look at. So did you find out other parameters for classifier, how to evaluate the performance of a classifier apart from these parameters? Okay, no problem. You can go ahead and find it out. I think I have given one example of F1 score in the last session, which was not there in this PPT, but then F1 score is an important parameter also. And then this was your first project, perform exploratory data analysis and all different classifier regression for the case study given in the session, evaluated based on the performance. But you can neglect this for time being. What you can do is you can just perform the exploratory data analysis for the case study given in the session. In the sense that will be provided by the Roshan. Okay, that will be provided by Roshan. So, but it's not necessary that you have to take the same case study. You can always take any random case study. You can take any and then you can perform exploratory data analysis. It's up to you. The ultimate goal is you should be able to understand the data. That's the whole point. I'm not sticking with the respect to one particular data set. My ultimate goal is you should be able to understand the data. You should be able to play around with the data. Before going ahead to one more classifier, again, I wanted to remind you guys, in this session, we will be only looking at the classifier and how to model that classifier, the concept behind that classifier, and then how to code that in Python. That's the whole purpose of this session, that you should be able to work on any data science project or machine learning project. But there is a separate course on the advanced version where you will be understanding more of mathematics behind every classifier. The way we have learned for linear regression, there would be a mathematics involved for more or less all the classifier. We should be looking in detail. Okay, in the first we are taking one step at a time. At this point of time, we should be able to understand the concept and code. Now I have a question for you guys. Let me open. Let's say that I have a data set which has 10,000 records. Let's consider it's a binary classification problem. Now you have understood the problem statement, you know everything. Whether let's take a business problem here. Let's say that we have 10,000 different types of brake disc with different dimensions and different parameters. Our objective is whether the brake disc can sustain or not. Okay, let's say that we are doing it for winter climates in Europe. Let's assume this, okay? This is a given condition. So whether the brake sustain or not. Okay, now you might be having different parameters. How would you check whether the brake disc can sustain or not? Do you all know lump capacitance method, guys? So I don't want to go into much detail, but then you know that this one, when a body is considered to be a bulk in the lump capacitance model, the body would be considered as bulk. Bulk in the sense, say the parameters will, let's say this is a brake disc, the temperatures or the different parameters will not change with respect to XYZ direction. It will only change with respect to T, time. So that is the reason we consider capacitance method, we consider the body to be lump. So there what we do, the amount of energy stored in a body will be cooled down using convection, right? Now are you able to recollect this equation, guys? So now this is not T minus T infinity, this will be d temperature, right? So this is dt by d tau. So now this is lump capacitance method which we generally use when the parameters are not changing with respect to spatial coordinates, but it is changing with respect to time. Okay. Anyways, so you can do those analysis if you want to do that. But anyways, these are the different parameters which are, so for example, you already have in your data set, and you have whether the brake disc can sustain this or not using the historical data set. Someone has done the analysis using this 1D analysis, using this lump capacitance method, or the test results. Let's say you have test results. Now you have divided this data into 70% training and 30% as test. Now the important point to understand here is, let's say that, do you remember the threshold probability which I've told you? 0.5 in classifiers. Let's say in the logistic regression, if you remember, let's take a logistic regression, right? We have considered the threshold value as 0.5, right? So let's assume, now the question is why we have considered the threshold probability value as 0.5. So the whole point is, it's not necessary that we should always consider 0.5 as the threshold probability, that if the probability is more than 0.5 then it will go in the class 1, otherwise it is class 0, right? We are providing equal chance, but then is it necessary? Not really. So we start our analysis with a threshold probability value of 0.5, but then let's say, because this is your training data set, you can compare your values also, right? Here while building the model, say this is your y actual, say you got some y predicted, say this is what you are getting, okay? And this y predicted is based on the probability value of 0.5. Say this is your predicted value based on 0.5. Now let's say that you have got different data 1000 something, and then you are predicted based on 0.5, you got this result. While training, let's say that you got this value was y predicted with 0.5 as a predict. Let's say with 0.6 as a threshold value, assume this, okay? You are getting this. Then which threshold value of probability is the right value, guys? 0.5 or 0.6? 0.6, right? So that's the whole point. So we should start with 0.5, but we cannot always restrict ourselves with 0.5. This would be your interview question. Is it necessary that logistic regression should always, the threshold value for the probability should be 0.5? Not really. It's not necessary. Sorry, it's not necessary. So ideally in real scenario, what you should do is, let's say with 0.1, with 0.2, with 0.3, with 0.4, 0.5, 0.6, 0.7, 0.8, different probability value as a threshold value, you should try to come up with your y prediction, okay? And then based on that y predicted value, you should build your confusion matrix, and then you should check for which threshold value of probability you're getting the better performance, and then you should carry forward with that we should go ahead with that probability value. Isn't it so difficult to do it for every probability value? For 0.1, 0.2, 0.3, it's okay. There are intermediate values also, right? 0.11, 0.15, 0.55. Some models might work better for 0.55 rather than 0.5. So how do I treat those things? How do I understand what should be used? Of course, I know that you can use for loop with different probability values, and then you can come up with a different confusion matrix, and then you can compare the results, and then you can tell us which probability value is a right value. But there is something called as ROC curve. You have to tell me what is the full form of this in next class, okay? ROC curve. These curves are specially meant for classifiers. So what you have to do is to have a better representation. ROC curve, what it does, on the x-axis you will have false positive rate, and on the y-axis you will have true positive rate. Do you remember what is true positive rate and false positive rate, guys? We should always target for higher true positive rate and lower false positive rate. So in ROC curve, this is your true positive rate, this is your false positive rate. Now, if I have different probability threshold values, and let's say that what could be the maximum true positive rate? Can you tell me what could be the maximum value of true positive rate, guys? 100%. 100%, that's okay. That means 1, right? What would be the maximum value of false positive rate? If you have a worst algorithm, 1, 1. Similarly, the minimum value of true positive rate and the false positive rate would be 0, 0, right? Now, let's say for different threshold values, this is the one which you have got, the threshold value of probability, say 0.55. Say this is the probability value with 0.5. I'm just giving you an example, guys, okay? Let's say that with this you got 0.5, 1. With 0.5 you are getting 0.75, 1. So which threshold value you will choose in this case? 0.5 or 0.55? With 0.5 you have the false positive rate as 0.5 and true positive rate as 1, and with 0.55 you have false positive rate as 0.75 and the true positive rate as 1. Which one will you choose? 0.5, right? Exactly. So now you're getting my point. So what happens in general, we draw this curve for different probability values, threshold value, we might get different curves, something like this, and then we draw those kind of, we join those points, and then we'll get one curve. Okay. Similarly, let's say this is for logistic regression. You have used logistic regression, different threshold value, you have got this result. Let's say now, I'm just drawing randomly, guys, okay, don't worry about it. Say this is your logistic regression. Now, this is your ROC curves, okay. Now, let me take other color. Let's say, these are coinciding here. Let's say this is your different threshold values of probability. This is the graph which you are getting. This is the ROC curve which you are getting for random forest. Okay. Now, tell me which algorithm is better now. Okay, tell me area under curve for logistic regression is more or for random forest is more. For which one? Right. Random forest is better. You are able to analyze it, right? Because it can give us the result with very less false positive rate and very high true positive rate. So the area under the curve, for which we have to check the area under the curve, which is called as AUC. So higher the area under curve, better the algorithm. So ROC curve and AUC, these both go hand in hand. Area, you should find out the ROC full form, okay, and area under the curve. So these both will go under hand in hand, and this is the famous interview question which you can always anticipate in the interview.